Learn the foundational elements of a microservices architecture with .NET by building a real microservices-based application. Julio is an excellent teacher and has created many popular .NET courses.
Welcome to Building Microservices with .NET, the basics. My name is Julio Casal, and I'll be your instructor through these first steps in your microservices learning journey with the .NET platform. Before we move on to learn about microservices, I'd like to walk you through the fictional client application that drives the requirements for the backend system that you will build, the high-level architecture of the system, and the technology stack that will be used across this course. Let's imagine a video game where the player will need to acquire a series of items to stay healthy, become stronger, and survive the multiple dangers that await him in his adventures. There will be a series of stores that will allow the player to purchase items like potions, antidotes, and even swords and shields. These items have a price, and to purchase them, the player will need to present the right amount of some sort of currency that we will just call GIL. Once the player successfully purchases an item, it then goes into his inventory bag, where it will be available for him whenever he needs it. Now, the client side of this game, the app that runs in the player's device, is already being built by our company's client team, so you don't have to worry about it. And in fact, this client app is not part of this course. Our team has been chartered with building the backend services for this game, which the client will heavily depend on to be able to store the items catalog, the player's GIL and inventory, and to enable the in-game purchase experience. Let's now look at the high-level architecture of the system. To support the client applications, the following microservices-based architecture has been designed. At the core, we have identified 4 microservices: Catalog, which owns the list of items available for purchase; Inventory, which keeps track of the quantity of items that a player owns; Identity, which manages the list of players and also acts as an identity provider; and Trading, which owns the purchase process that can grant inventory items in exchange for GIL. Each of these services have their own database that has no relationship with other databases and that are of exclusive use by the owning service. For inter-service communication, the system makes use of a message broker, which allows the services to collaborate by publishing and consuming messages asynchronously. For the clients to interact with the microservices, this architecture adds an API gateway, which provides a lot of flexibility to make changes to the services without impacting the clients, and lets the services focus on their business while delegating multiple cross-cutting concerns to the gateway. There is also a front-end portal that enables the administration of the items catalog, the players, and their inventory, and it also includes a store section where players can purchase items. Finally, there are a few infrastructure components like logging, distributed tracing, and monitoring that all microservices can interact with and that can greatly help to troubleshoot issues and make sure the whole system remains healthy. Now, there are a lot of topics to cover to implement this system, so in this course, the basics, we will focus on the most fundamental parts related to microservices collaboration. In that sense, you will implement only the catalog and inventory microservices using .NET and ASP.NET Core, and you will use MongoDB to host a NoSQL database for each service. You will initially explore how the services can communicate synchronously via REST and HTTP, but later you will stand up a RabbitMQ message broker that will allow all services to communicate asynchronously by publishing and consuming messages via the MassTransit distributed application framework. That will give you a solid understanding of how to get started with microservices and .NET and how to tackle the multiple challenges of getting the services to collaborate in a resilient way. The front-end portal is based on the React UI framework. You won't be coding this portal, but you will get access to all the source code so you can build and run it in your box and use it to see how a real and modern client can take advantage of your microservices. Also, you will run all infrastructure services like MongoDB and RabbitMQ via Docker containers, which is the best way to get things up and running in your box very quickly. At the end of this course, I will point you to the next steps so you can continue your journey by implementing the rest of the system. In the next lesson, you will download and install the first set of tools that you will need in your development box for the upcoming models. In this lesson, you will set up the development environment that will be used across this course. Here are the tools required for this model. The .NET 5 Software Development Kit, or SDK, which includes everything needed to build and run .NET applications. Docker Desktop, which has all the tools needed to run the multiple infrastructure services that we will use across the course. And Visual Studio Code, the lightweight but powerful source code editor that we will use to write, build, and debug our microservices code. A few of the future models will require more tools, but for now this is all that is needed. Let's go through the installation of these tools and the overall setup of our development environment. Before getting started, just keep in mind that the pages that you will see for downloading the tools will likely look a bit different depending on your operating system and the versions available at the time that you're taking this course. But regardless, the overall download and installation process should be mostly the same. So let's start by going to the download page for the .NET SDK. So let's go to net.microsoft.com/download. And this page is going to present you the latest version of the .NET SDK, which in my case, that will be .NET 6, and in your case, it could be different. But one thing to keep in mind is that this course has been designed for .NET 5, not for .NET 6 or any other future version. So even if you have .NET 6 or another version installed in your machine, you have to make sure that you get the .NET 5 SDK in your box. Otherwise, the project templates that you will be using will generate different code than the one that you're going to see in this course, and you're also going to get a few syntax errors. So, to get the .NET 5 SDK, what you want to do is go to this link, all .NET versions, and then you want to go into the .NET 5 link over here. Here, at the top of this page, you want to look at this table here, which lists the links to install .NET for the different operating systems. So, you have to choose the link that corresponds to your operating system. In my case, I'm running Windows, and my platform is x64. So I'm going to click in the x64 link, and that is going to start the download. So this download could take a few seconds depending on your download speed, so let's just give it a few seconds. Okay, so the installer has downloaded. I'm going to click on the installer. I'll click on install, and installation starts. This could take a few seconds or a few minutes depending on the speed of your machine. So again, let's just give it a moment. Okay, so the .NET 5 SDK has been installed already, and I'm going to just close this window. And what I'd like to do now is to quickly go ahead and verify the installation, just to make sure that it has been installed properly. So to do that, I'm going to go and open my Start menu, and then I'm going to look for my terminal, my Windows terminal, and of course, depending on your operating system, what you can do is just open whichever terminal or shell is available in your box. This should work in really any kind of terminal or shell. And then all you want to do is just type .NET and then --info. And this is going to present you with a bunch of details regarding your version of the .NET SDK and your machine. Like in my case, it is showing that I have version 5.0.404 of the .NET SDK. And then there are many other details here, but in the end, this shows that .NET has installed properly into my machine. So .NET is ready to go. Now let's go ahead and load the page to download Docker Desktop. Let's go to docs.docker.com/getdocker. And in this page, if you scroll down a little bit, you're going to see again that you can pick your operating system. So again, my operating system will be Windows. So I click on Docker Desktop for Windows and Docker Desktop for Windows. So I'll click on that button and let's give it a few seconds for the download to complete. Okay, so let's go ahead and open the Docker Desktop installer. Okay, so here it goes. We'll just keep these two checks right there. No need to change anything. I'll just click on OK, and that's going to get things started. Again, this may take a while, so let's give it a moment to complete. Okay, so installation succeeded. I'll click on close. Another thing about Docker is that Docker Desktop will usually not automatically start in your machine after installation. So you do have to start it at least the very first time that you install the tool. So to start Docker, I'll just go to my start menu, I'll type Docker. So here it is. You're looking for Docker Desktop, I'll click on it. And you should see a new icon show up in the right side. Bottom right, I guess, which is starting the Docker process. Okay, so this screen shows up. I'll click accept all the terms, accept. Notice how Docker Desktop is starting. And then this screen shows up. Docker Engine waiting, Docker Engine starting. Give it a second. Installation has completed, it has started. I'll click on skip tutorial here. And at this point, Docker is up and running. And to verify that Docker is up and running properly, what I'll do is also type a quick command in the terminal window. But I'll open a second terminal just because we want to make sure that it has gotten the chance to read the new environment variable to locate Docker. So I'm going to close this terminal here, close our windows, and I'll open a new terminal, Windows Terminal. And here, what I'll do is just type docker version. And if Docker is installed, it should show up all the details about the current version of Docker, which in my case is version 20.10.11 for the Docker client at least. And with that, our Docker installation is complete. So now I'll go ahead and install Visual Studio Code. So I'll close this terminal and I'll close this, and I'll go into the browser. Let's go into aka.ms/vscode. And here's the install page for VS Code. And as usual, you're going to be offered the version that corresponds to your operating system. So I'm going to click on this big blue button here, download for Windows stable build, and the download starts. And this should be pretty fast. This is a small installer. Okay, so I'll click on installer, accept agreement, and then I'll just click all the default options here. Click install, and let's give it a moment to complete. Okay, so then I'll just click on finish, and VS Code is opening up right away. I'll maximize this window, and as you can see, VS Code has opened up. And that completes our installation of the initial tools. In the next lesson, we will go ahead and customize Visual Studio Code for C# development. Visual Studio Code is a lightweight but powerful source code editor that has built-in support for JavaScript, TypeScript, and Node.js, and has a rich ecosystem of extensions for other languages and runtimes. Since all the code that you will write across this learning path will use the C# language and will run using the .NET runtime, you will need to install the popular C# extension. So to install extensions, what you want to do is go into your activity bar on the left side, this one over here, and look for the extensions view via this extensions icon. You can click on that one. And this is going to show all the available extensions in the Visual Studio Code marketplace, of which there are really hundreds of them. And then what you want to do is just search for C#. And the extension that you want is usually the very first one on the list, and it is the one that is provided by Microsoft, and it says C# for Visual Studio Code powered by OmniSharp. So let's click on that one. And this is the extension that adds all the editing support needed for C#, including syntax highlighting, IntelliSense, find all references, and many other features. It also adds support for building and debugging .NET and ASP.NET Core applications in your box. So you have to make sure that you get this extension in your box to be able to do proper coding with C#. So I'll go ahead and click on install. And this may just take a few seconds, after which you will be ready to start coding in C#. Okay, so extension is ready and you're ready to code on C# with Visual Studio Code here. But let's also go ahead and enable a few optional settings to further improve your coding experience. So let's go to, let's first close this and let's close that. Let's go to File, Preferences, Settings, and here let's type place open brace on new line, and this is going to filter a few options here, and the ones that you want to enable are this one here, JavaScript format place open brace on new line for control blocks, and place open brace on new line for functions. These two settings will help you format your control blocks like if-else blocks and your functions so that when you open braces, the opening brace automatically goes to the new line. So you don't have to use this setting, but I find that my code reads much better when I use it. The next setting is, let me delete this one here, delete this, is format on save, which is this option right here, this first one. So I'll click on that one. So what this allows is to make sure that all your code for whichever file you're working on will be automatically formatted as soon as you save it into your machine. Right? So you save the file and it will get all the formats. So that would, again, it will help you make sure that the code looks way better without you having to do a lot of work across your lines. And the last optional setting that I will recommend you is this one in file autosave. So as the name says, what this allows you is to automatically save whichever file you're working on without you having to do anything. So as soon as you finish typing your code, the file will be automatically saved to your machine. So I find that very handy to make sure that I never forget to save my files. So I'm just going to click on autosave, and that will enable the setting. The last thing that I wanted to show you here is the Visual Studio Code integrated terminal, which is the one that you're going to use to type a bunch of commands across this learning pad. So let me go ahead and close this settings tab here. And to open a terminal, what you can do is either go to View, Terminal, or you can go to Terminal, New Terminal, or you can use a few shortcuts. Like for instance, in the case of Windows, you can do Ctrl+, that will open terminal, or let me kill this. You can also use Ctrl+J and that will also bring up a terminal. So of course, the shortcut keys will depend on your current operating system. Now, as you can see, in this case, this has opened a terminal, a PowerShell terminal in my case, and that's because that's a default for Windows. But you can always go ahead and use this drop down on the right side, right here. You can open up and you can switch to any other terminal that better suits your needs. So if you want to use bash, you can use git bash here, you can use a standard command prompt, or you can switch to even an Ubuntu-based terminal. So it's really up to you what terminal to use. In this course, we'll be using mostly PowerShell because that's what I mostly like to use, but it's up to you to use whichever terminal fits better your needs. In the next couple of lessons, we will define the concepts of monoliths and microservices, how they compare, and which are their pros and cons. Before diving into microservices and their benefits, it is probably worth it to understand first what a monolith is, its benefits, and the issues it can present. To understand what we mean by a monolith, let's look at one way we could design our play economy system. We start with our desktop and mobile clients. Like we said, they need some sort of backend piece to enable the game experience. Therefore, we introduce a server component, likely hosted as a web server somewhere in the internet. As we go through the requirements, we identify a model that needs to take care of the in-game catalog of items. So we introduce a catalog model. Right away, we also perceive the need for a place to store these catalog items, which means it is time to introduce a database along with a table to store these items. We also identify the need to store the information about our players, and in general, any user of the system. So we bring in a users model, which we place in the same web server next to the catalog model. Also, since we already have a database configured for a web server, we decide to add tables for the users model in that same database. Next, we identify the need to store the set of items that the player has purchased. So we bring in an inventory model. And same as before, we place it next to our other models and add relevant tables to the same database. We also need some place to perform the actual purchase process. And since this involves both debiting yield from the player and granting items to him, we also know we will need to use some sort of transaction for this. So we introduce a trading model on the same server, and we will let it take advantage of the transactional capabilities of the database. Finally, we will need some way to secure the access to our web server, so that only players registered in the system can make use of it. So we bring in an authentication and authorization model, which we will abbreviate as AuthC. As with everything else, we will place it on the same server and make it use the same database. This system that we have just described is what we call a monolith, and more specifically, a modular monolith. In this system, all of our server-side capabilities are hosted together in the same web server, and they all use the same database. Likely, we also have the source code for all the models in a single repository. We build all the code base with a single build process, and we deploy everything together. Let's now look at the pros and cons of a monolith. Here for the pros and cons of a monolith. First, the pros. Convenient for new projects. Usually, when you're just getting started, a monolith is the best option since you can put all the source code in one place, including all common libraries. This lets you iterate quickly for a while. Tools mostly focus on them. Most IDEs are built around the concept of building a single application, which aligns pretty well with a monolith. There's great code reuse. Since all the code lives in the same repository, it is easy to reuse code across the multiple models of the application. It is easier to run locally. Being a single process, it is straightforward to have the full application running in your box, usually with a single command. Easier to debug and troubleshoot. When it's time to fix bugs, there's usually a single place to look for logs to find out what happened. You can also start a debugging session in your box to reproduce and fix the issue. There's one thing to build. A single command is usually enough to build the entire code base locally, and if using a continuous integration server, a single build pipeline will do the trick. There's also one thing to deploy. All the application models can be deployed as a unit with a single deployment pipeline. There's one thing to test end-to-end. End-to-end verification of application can take place as soon as the application has been deployed, with no other moving pieces that could impact testing. And there's one thing to scale. When the increased load demands more instances of the web application, there's only one app to scale. Same when the increased scale is no longer needed. There's only one thing to scale down. Now, the cons. Easily to get complex to understand. Since the entire code base is in a single place, there will be a point where it starts becoming too hard to navigate it and understand the relationships between the different components. Merging code can be challenging. When using things like Git, and with more and more people contributing to multiple models in a single code base, eventually resolving conflicts gets more troublesome, and the chances of a bad merge that could impact on related models increases. It slows down IDEs. If the devs use an integrated development environment, or IDE, like Visual Studio, the massive number of projects and source code will eventually start slowing down the IDE, starting with simple things such as opening the work environment. Long build times. The bigger the single code base becomes, the more time it takes to build it. Things like incremental builds can help here, but this is something that can easily not be configured properly, and regardless, it is undesired to have to build code for all the application models when usually you only work on one or two of them. Slow and infrequent deployments. Just like building the code takes longer, it also takes more time to complete the deployment, since there are a lot of components to deploy with every new build. Not only that, teams tend to delay deployments to Friday night or even weekends due to the lack of confidence on the impact of the changes that go into that deployment. Remember that with each deployment, you are deploying all the application models all the time. Long testing and stabilization periods. Once a deployment is complete, regardless of what changed in the deployment, you still need to test all the scenarios across all of the application models. Not only this is inefficient, but also teams that don't have testing fully automated may need to run manual tests to compensate and run them again for all the application scenarios. Rolling back is all or nothing. Bugs will eventually make their way to deployment, and sometimes there's no time to code and deploy the ideal fix. In these cases, you just want to roll back to a previous version. However, with a monolith, you will be forced to roll back the entire application, not just the faulty model, and once the fix arrives, you will need to redeploy the entire thing again, with all the associated testing and stabilization. No isolation between models. The smallest bug in one of the models that makes the web application crash will take down all the models with it. It can be hard to scale. This really depends on the kind of app that you're building, but if you have some model that needs, say, a lot of memory and therefore needs to be scaled to multiple instances to not take over all the RAM in a single server, while all the other models are fine with a small amount of RAM most of the time, you still need to scale the entire application with all the models to satisfy the RAM needs of the first model. Also, it's hard to adopt new tech. If you would like to move one or two of the models to the latest version of, say, the .NET platform, you are forced to update all the models along with it, which significantly increases the time investment and the associated risk of moving to a new stack. Moreover, if you need to switch a model to a different programming language or web framework, you still need to account for how that change will impact the rest of the models. In the next lesson, we will start learning about microservices, their pros and cons, and when it's a good time to start considering them. In this lesson, we will understand what microservices are, how to decompose our previous monolith into microservices, the pros and cons of using microservices, and when is the right time to start thinking on using them. There are multiple definitions of microservices out there, but here's one I have synthesized from a few sources and that I think covers the fundamental characteristics of microservices. Microservices refers to an architectural style that structures an application as a collection of independently deployable services that are modeled around a business domain and are usually owned by a small team. So instead of having a single application deployed as a single monolithic unit, we break it down into smaller services where each of them is closely aligned to some part of our business domain. Each of these services can be deployed independently, which by the way includes granting each of them their own database, which is one of the main challenges of moving to microservices. Also, there's usually only one small and fairly autonomous team behind each microservice. Let's see how this looks like for the game backend example we talked about in the previous lesson. We start again with our client apps, which will still interact with some backend pieces to enable the required game experience. And, just like before, we come up with most of the models that we talked about before to address the multiple scenarios. However, this time each of these models live in their own individual server process, or likely a web server process, fully isolated from the other ones and with their own lifecycle. Not only that, but also each of these services have their own associated database that has no relationship with the ones from the other services. Also notice that we decided to group the users and OutC models in a single process that we are now calling the identity service. But even when these services are now independent, they still have ways to collaborate with each other so that, for instance, when a purchase starts in trading, this service will communicate somehow with the identity and inventory services in order to achieve the exchange of yield for catalog items. This here is what we call the microservices architecture pattern. Next, let's learn about the benefits and drawbacks involved in a microservices architecture. These are some of the pros and cons of using microservices. Let's start with the pros. They have a small, easier to understand codebase. Since the microservices are now independent, the source code for each of them is usually stored in its own Git repository. This implicitly results in a much smaller repository, which is much easier to understand, especially for devs new to the codebase. They are quicker to build. The smaller independent codebase per microservice allows for building each service much faster and in parallel, both on dev boxes and on CI pipelines. They allow for independent, faster deployments and rollbacks. Each service can now be deployed individually as soon as the development source code has been built, and testing for the domain covered by the service can start right away and is much smaller in scope. Also, if an issue is detected with the deployment, it can be rolled back to the previous version without having to roll back any other service. They are independently scalable. Different services can be scaled according to their needs, so if there's one service that needs to scale, given the amount of RAM or CPU it uses, it can be scaled independently of the needs of any of the other services. There is much better isolation from failures. Microservices are isolated from each other so that a crash in one service has no impact in the availability of the other services. They are designed for continuous delivery. Since microservices are small, usually start fast, and are independent from each other, they are great candidates for continuous delivery. They can be deployed as soon as the code has been built, and this can be done safely in an automated way multiple times a day. It is easier to adopt new varied tech. Different services don't need to use the same versions of their multiple dependencies, including the .NET runtime. Even better, if one of them needs to be moved to a completely different language or web framework, this is much more straightforward to do with a small microservice than with a big monolith. Microservices grant autonomy to teams and lets them work in parallel. The natural independence of deployment and isolation of microservices and the fact that they are closely linked to a specific part of the business domain results in the owning teams to have great autonomy around the entire lifecycle of the service. Some teams might decide to deploy their microservice every night, while others will do it every hour or whenever an urgent fix needs to be shipped. Different teams will do what's best for them. Now, the cons. It is not easy to find the right set of services. How do you know that you have split the app into the right set of services? Are 3 microservices enough? Or 10 perhaps? How much granularity? These questions are not easy to answer, but techniques like domain-driven design and aligning the services to specific pieces of the domain and the teams behind them helps to find the right balance. Using microservices adds the complexity of distributed systems. The fact that each service lives in a separate silo introduces a lot of complex issues that are non-existent in monoliths. How to have a service communicate with another one if a module can no longer make a simple method call to the other? Issues like these are the reason for this curse. The shared code moves to separate libraries. Any piece of code that needs to be shared across 2 or more microservices now needs to be either duplicated in each service, which is not ideal, or moved to a separate library and likely shared via NuGet packages. This is technically good since it forces the owners of the shared code to have a good way to test the shared code independently. But on the flip side, things are no longer as easy as adding a new shared class or method to any of the services' code base. Also, you may end up with dozens of shared libraries that may need to collaborate and have the right set of dependencies. There is no good tooling for distributed apps. IDEs are usually focused on a single app, not on running several services together. This means that devs will usually work on one service at a time and will need to figure out ways for their code to interact with other services in their dev environment where needed. Releasing features across services is hard. Simple things like adding a new attribute to, say, a user record and have it being used across the entire system can involve touching multiple services in a very coordinated fashion. Even worse, updating or removing attributes from data classes is extremely painful and usually avoided as much as possible. It is hard to troubleshoot issues across services. When a customer reports an issue with the system or application, where should we start looking? With features potentially distributed across dozens of microservices, you are forced to have a very good story around tracing issues across services to be able to quickly find out the root cause and address it. You can't use transactions across services. Since each service has its own database, atomic transactions that impact multiple tables are usually out of the question. How to ensure a purchase operation will both debit yield from the user and grant it the relevant items when one of the involved services could unexpectedly fail in the middle of the purchase process? A few new patterns and techniques need to be introduced to properly handle these concerns. Finally, it raises the required skill set for the team. With each team fully owning the service, and since not all services will be built similarly, each team now needs to learn not just how to code features for the service, but also how to build it, deploy it, test it in isolation, diagnose it, roll it back, etc. Many times this also involves building a ton of automation and shared infrastructure to ensure teams can remain agile, building features, and not have to worry too much about all the other aspects. This requires a lot of investment. Let's close this lesson by understanding when you should start considering microservices. You should keep in mind that it is perfectly fine to start with a monolith and only later move to a microservices architecture. Your business domain and the set of requirements for your system might not be full flushed out by the time you need to start designing and building the system. Therefore, jumping into building multiple microservices from the start could not only significantly slow down the small starter team at a time when quick proof of concept are desired, but also you may end up building the wrong set of microservices with additional cost of having to restructure them later. The heavy investments on shared infrastructure and automation will only make sense as the boundaries are clearly defined and the team has grown in size. You should start looking at microservices when the codebase size is more than what a small team can maintain, the different teams can't move fast anymore due to the amount of shared code, the builds have become too slow due to the large code base, or the time to market is compromised due to infrequent deployments and long verification times. In the end, microservices are all about team autonomy. Anytime you notice multiple teams no longer being able to deliver features in an agile way due to the drawbacks of the monolithic architecture, you know that your teams have lost their autonomy and they could potentially greatly benefit from using microservices instead. In the next module, we will get our hands dirty by building our first microservice. In this module, we will build our first microservice from scratch. This will give you the foundations and tools you will need to create microservices with the .NET platform. By the end of this module, you will have a solid understanding of the following: how to create a microservice from scratch via the .NET CLI and Visual Studio Code, how to define the microservice REST API with the most common operations, and what are and how to define the data transfer objects to establish the contract between our service and the service clients. In this lesson, we will create our first microservice, the catalog microservice, using the .NET CLI and Visual Studio Code. To create our microservice project, we will take advantage of the .NET command line interface, also known as .NET CLI, which comes installed with the .NET SDK. So the first thing I'll do is create the folder where I'm going to store my projects. So to do that, I'll go to Terminal, New Terminal, and then I'll switch to my D drive and to my projects folder, and I'll create a folder called play.catalog. So everything related to the play.catalog catalog microservice will be stored in that location. So I'll open that folder in Visual Studio Code now by going to File, Open Folder, and then I'll look for that location here. So this opens a workspace in that location. So being here, what I'd like to do is create yet another folder to store all the source files for the microservice. So I'll go on the left side here, I'll go and click on New Folder, and then I'll type src. So src is going to be the folder that stores all the files related to compile the application. I'll expand this, and then I'll right click on src and select Open in Integrated Terminal. So this opens a terminal exactly at the location where we're going to create the project files. To actually generate the files, what we can do is type .NET new. And at this point, you can actually pick from a bunch of different templates for creating .NET projects. But the one that's most useful for microservices is usually the Web API kind of project. So I'll type Web API, and the name we're going to give it is play.catalog.service. Hit enter. And this is going to go ahead and generate all the files that we need for the project, which at this point you can see on the left side. Also notice that there's a small warning about the ASP.NET Core HTTPS Development Certificate, which we'll take a look in a moment. Now, if by any chance you have multiple versions of the .NET SDK installed in your machine, and you're not sure that .NET 5 is your default version, please add the -- framework argument to the .NET new command, specifying the value of net 5.0 for .NET 5. That will make sure that you're using the ASP.NET Core 5 templates when creating projects, which will produce the same files that you will see in this and in future lessons. Now let's go quickly across the files that just got generated and see what they're meant to be used for. So the first one is going to be, I'll actually just close this terminal. The first one is going to be the csproc file, which is what we call the project file. So this is the file that defines how the project is going to be built and what version of the .NET runtime is going to be targeted. In this case, it's going to be .NET 5. The next one is program.cs, which is what we call the main entry point of the application. But also notice that as soon as we open our first C# file, Visual Studio Code is going to prompt us to add a few required assets to the project. We'll say yes. So this will create a .vs code folder on the left side with a couple of files that are needed to build and debug the application. Now, like I said, back in program.cs, this is the main entry point. So this defines how we're going to start the host for our application. Next file is going to be startup.cs. This defines how we're going to register the services that are going to be used across the application and what we call also the request pipeline for ASP.NET Core. The next one I'd like to show you is the controllers folder. This is where we store all the application controllers to handle the requests that are going to come into the application. And this is accompanied with right now by a model that's called the weather forecast for the simple sample model that has been set up in this template. Next file is a launch settings.json. This one defines a few things, but the most important one is the application URL, which defines which is the address or the addresses where our microservice is going to be running. So in this case, it is going to be available in HTTPS localhost 5001 and on HTTP localhost 5000. Finally, like I said, Visual Studio Code generated a couple of files over here. Task.json, which defines how we're going to build the code from Visual Studio Code, and launch.json that defines how to start up, how to actually kick off the execution of the application in Visual Studio Code. Okay, now I'll close this, and it's time to actually build this project to make sure, well, build and run it to make sure that it's running properly. So in order to do that, what I'll do is I'll go back to the terminal, and you can do that by going to View, Terminal, which by the way, you can also do via the Ctrl-J shortcut, faster that way. And then I'll switch to our play.catalog.service directory. Yep, play.catalog service. And then while being there, what you can do, there's actually a couple of ways that you can build this project. So you can either do .NET build, like I'll do now. That will go ahead and build the entire project. Should be pretty fast. And the other way to do this is via Visual Studio Code's menus. You can go to Terminal, Run Build Task, and then you select Build. And that will also go ahead and build the project. Now, this second way is the way that you will most likely be using while being in Visual Studio Code. And to make this actually a bit faster, what you can do is add a couple of lines into the task.json file. So let me minimize this a bit. So go to task.json, and here under the build section, what you can do is just add one little group here. Let's add it. It's called group, and then we're going to go for kind build is default true. I'll save this, and after doing that, what you notice is that when you go to terminal and you say run build task, it will build it right away, as opposed to opening yet another menu to do the build. At this point, you can also use the Ctrl-Shift-B shortcut, like I'll do now, to kick off the build without having to go through any menus, which is pretty handy. Okay, now that we know how to build the project, and I'll actually just close this, how do we run it? So there's a couple of ways to do that too. So I'll actually switch in this dropdown. I'll go back to our terminal, the PowerShell terminal, and the way to run this microservice project is by just typing .NET run. So that may build the project depending on the current status, but after that it will go ahead and run it, as you can see, and it reports the current status, the address where the host is listening, the addresses in this case 5001 and 5000 in localhost, and how to actually turn down the application if needed by Ctrl-C. So that's one way, and I'll actually do a Ctrl-C to stop it. The other way to do it is by going to the run view on the left side, and here you can click on this icon here. It says start debugging. This will actually start a debugging session of the project as opposed to just running it. So I'll click on it. Okay. And this will open a browser window, as you can see here, for our project. Now, if you see this kind of an error stating that your connection isn't private, this is totally normal. So this just means that the development certificate for the web host has not been installed yet. So in order to address this, let's actually go back. Let's close this and stop it. And what we have to do is just install the certificate, trust the certificate in our machine. So I'll go to terminal, switch back to the PowerShell terminal here. What I'll do is use the .NET Dev Search tool. You have to type https://trust, hit enter, and this is going to pop up this little warning here, which is totally fine, and say yes, and that adds the certificate into your trusted root certificates store in your machine. So after doing that, I'll go ahead and instead of clicking on this, I'll just hit F5, which is a shortcut for start debugging. So I'll hit F5. So that opens the browser again. And as you can see, there's no errors anymore. And yes, it is not showing anything. That's because there's nothing really happening in the root of the website. So if you actually want to see something, you can do /swagger, and this opens the Swagger page, the Swagger UI page. So this is the page where you can start exploring the different methods exposed by your web API or your REST API. In this case, we have not really coded much. The only thing that you're seeing here is the default stuff that's coming with the template. So we'll not pay too much attention into it. But later on, we'll start using this page heavily to start working with our microservice. I'll close this and I'll stop the server. So that's it for this lesson. And in the next lesson, we will define the REST API for our catalog microservice. In this lesson, we will define the REST API for our catalog microservice. The REST API defines the operations exposed by the microservice. Since the catalog microservice owns the items that players will be able to purchase, here are the operations that it should support. Get items, which retrieves all the items currently stored in the service. Get item by ID, which retrieves the details of a specific item. Post item, which creates an item in the service. Put item, which updates a specific item. And delete item, which deletes the specified item. As part of the definition of the REST API, we also need to define the relevant data transfer objects. So, what is a data transfer object? A data transfer object, also known as DTO, is an object that carries data between processes. For example, let's go back to our client and the catalog service. When the client needs to retrieve the details for a specific item, it will send a GET request to the service with the item ID, and the service will in turn return the item details. This payload returned by the service is what we call the DTO. The DTO represents the contract between the microservice and the client. Modifying this contract has significant implications. Imagine what would happen if we decide to rename the price to item price. Our clients would break and they would need to get updated right away to ensure no disruption to our customers. As a general rule, you need to think carefully about each of your DTOs to ensure you minimize the need to update them later as much as possible. It's time to define the REST API for our catalog microservice. We'll start by deleting a few files that were created by the template that we will not be using across this microservice, which are the weather forecast controller, I'll delete this, and the weather forecast class over here. Now the first thing that we're going to do is declare the DTOs for our service. Now we will use record types for our DTOs as opposed to classes, basically because they are simpler to declare. They provide value-based equality, which means that when comparing two of the items, they will be considered equal if all their properties have the same value, which is not the case with classes. They are immutable by default, meaning that modifications after creation are not allowed, and they have a built-in toString override that shows the names and values of all the record properties. So to create the DTOs file, you can right-click on Play Catalog Service right here, say new file, and then let's name it dtos.cs. In this file, first thing we're going to do is just declare a namespace. So namespace should have the name of the folder to start with. So play catalog service, and then we will append DTOs. Now let's declare our first DTO. This is going to be the DTO that is going to be used to return information from our get operations. So public record item DTO, and the first thing that this is going to have is an ID. It's going to be of type GUID, and GUID is a type that is going to need a namespace import. So to import a namespace, I'm going to use a light bulb here, and I'll select using system, so that imports a namespace. And then we're going to declare a name, a description, a price, and a created date. Okay. Now the next DTO is going to be used for the creation of our items. So let's say public record is going to be named create item DTO. This DTO does not need an ID or a created date because both of them are going to be automatically generated within the service. So they don't need to be provided by the client. So we'll specify a name, a description, and a price. Finally, we're going to declare a DTO for updating an item. So public record, update item DTO. And this is actually going to have the same members as create item DTO, so I'm going to copy those. And it happens to be that right now they need the same members, but it could be in the future that they need different properties. So a good convention is to keep them separate, even if they have the same properties to start with. In the next lesson, we will add a controller to define our REST API operations. In order to add our API operations, we will need to introduce a controller, specifically a Web API controller. The controller groups the set of actions that can handle the API requests, including the routes, authorization, and a series of other rules usually needed in REST APIs. So to start, let's go to our controllers folder here, right-click, new file, and the name that we're going to give to this controller is items controller, since this is going to be the controller that's going to be managing our catalog items. So let's go ahead and collapse our navigation pane so that we have more space for looking at the code. Let's start by defining a namespace. So namespace catalog service controllers. Okay, and now let's define our class. It's going to be items controller. And so each of your Web API controllers should derive from controller base. And I'm going to import the missing namespace by doing control dot using Microsoft ASP.NET Core MVC. So you always want to derive from controller base, not from controller, but controller base, because this provides many properties and methods useful when handling HTTP requests, like the bad request, not found, and created at action methods, which we will be using in this and in future lessons. Now, you should always also add to each of your controllers the API controller attribute, so API controller. This attribute enables a series of features that improve your REST API developer experience, like for instance having model validation errors automatically return a 400 bad request error, or how to bind incoming requests into our method parameters. The other attribute that you want to add here is the route attribute. This one specifies the URL pattern that this controller will map to. For instance, if we use items here, that means that this controller will handle the reroutes that start with /items. So for instance, if we get, let's say, I'll just add a little comment here. So we have localhost 5001, and if somebody navigates into items, that means that since the route specifies items here, that means that items controller is the controller that's going to handle that specific route. Okay, so I'll remove this. And you can also use route for the different operations that we're going to define in this controller. You can specify your own routes, but for now, this is going to be our root route for all the operations in this controller. Now, since in this lesson we would like to focus on the REST API part of the microservice, we will not be interacting with a real database just yet. We will use an in-memory list of items that our API operations will interact with. And in a future lesson, we will introduce a proper repository class that will take care of interacting with our database. So let's start by defining this static list. So I'll declare private static read-only. We'll make this list read-only because we will only allow to construct it, to create it or instantiate it during controller construction time. And after that, there will be no need to modify the instance of this list. So it's going to be list of item DTO. because this is going to be the list that we're going to be returning when somebody requests the items from our REST API. So we want to specify the contract that we already defined for our items here. So item DTO, and then it's going to be named items equals new. And so let's see, we're missing some more namespaces here. Okay, so I'll do control dot again, season collections generic, and we also need our play catalog service DTOs namespace. So let's define our first item here. So I'll just define it inline here. So new item DTO. For the ID, we'll just generate a random GUID. So new GUID. May need another namespace import. Yep. And for the name, let's name this one Potion. The description is going to be restores a small amount of HP. The price is going to be, let's say 5. And for the created date, let's just do datetime of set.UTC now. Okay, it's going to be the current time in UTC time. So let's add, I'll just copy this to add 2 more items. The second one is going to be, let's say, an antidote. So the antidote cures poison. Price is going to be, let's say 7. Created date is UTC now. And the last item is going to be, let's say, a brown sort. And it deals a small amount of damage. It's going to be a bit pricier, let's say 20. And yeah, UTC now, colon, save. Okay. Also notice that we're using a static list here. So we do this so that the list does not get recreated every time somebody invokes one of our REST API methods, right? Otherwise, the list will be recreated every single time that a method is invoked, which we don't want. So now let's define our first operation. This is going to be the operation that's invoked anytime somebody tries to get all the items that we have in the REST API. So we're going to say public IEnumerable of item DTO get. And so yes, we're returning a list of item DTO. Now each of your API operations should be marked with the correct HTTP verb, right? Since this is going to be responding to the get verb, we should mark this with the HTTP get attribute. And then for this method, really it's super simple. We only need to return the current list of items, right? So we just return items. So that's our first get operation. The next one is going to allow us to return one specific item. So we'll name it public item DTO get by ID. Okay, and then we're receiving the specific ID as a GUID. And just like we did before, we need to decorate this with the HTTP get attribute. But here we also need to specify what part of the route that the user specifies is going to map to that ID. So in this case, we do that by specifying ID here. Okay, so that means that if somebody comes with, and I'll put it here, so somebody does a get, it's a little comment here, does a get into our items route, and then they specify some ID like 1, 2, 3, 4, 5. That 1, 2, 3, 4, 5 is captured as the ID in the HTTP get route, and that's mapped into the ID parameter over here. Okay, so the route would look more like in a more generic case, it's going to be /items/ID. And so to do this, the only thing that we have to do is just find the correct item in our list. So we'll say var item equals items where, and for this I'll need control.system.link. So for each item, we will do item.id should match the ID that we got in the parameter. And then we will say, okay, so let's find the only item that should match with that ID, get that one. Otherwise, I mean, with single default, we can say either get the item or just return null in this case. and then we return that item. Okay, so that's what we need for our get routes. So let's try them out, see how that goes. So I'll hit F5, my keyboard, to start the web server. That opens the browser, and let's now navigate to our Swagger page. So /Swagger, and here you can see that we have our two first API operations defined, items and items by ID. And we also have the schema of our item DTO showing up here, right? So if you expand this one, we can see the shape of our item DTO right there. So if I expand the items route, you can see a little example here of what it would return and expected return for a successful case. And then if you want to try it out, you just have to click on try it out. Then you click on execute. And here you can see the request URL that was invoked into our API /items. And then you can see the response body here along with the status code 200. And the response body has the 3 items that we have in our static list. So that's working fine. And let's say that we want to try the other operation where we have to specify an ID. So I'll just copy the ID of one of these. I'll collapse this for a moment. I'll expand the other one. So this one expects an ID as parameter. So I'll do try it out. I'll paste the ID here, and then I'll click on execute. And just as before, it will go ahead and use the items route, but it will append the ID of the item. And as you can see, we got a 200 OK, and we got in the body, we got the actual the body of the item that it was retrieved. Okay, so that's working fine. So let's now add a method for creating an item. So I'll minimize this, stop debugging, and then I'll close the terminal. Okay, so to create items, we're going to be using the post HTTP verb, and let's create a method for that. So it's going to be public action result. Now the action result type, so this one allows us to return a type that represents one of the several HTTP status codes, like 200 OK or 400 bad request. But it also allows us to return a more specific type, like a DTO type if we need to. So we can return different types depending on what we have available. So let's see how we're going to be using this. So action result of type item DTO. And this is going to be named, let's just name it post for now. And then here is where we're going to receive our create item DTO contract, right? So that in that way we enforce that whoever calls this API has to follow our contract for creating items. So create item DTO. And this one has to use also the correct HTTP verb. It's going to be HTTP post. And then for creating an item, we will just create it inline here. So I'll just say var item equals new item DTO. And we'll assign a random ID here, just like we did with the list. You do it. And then we will say for the name, we'll say create item DTO.name. For the description, that description. For the price, create DTO.price, and for the created date, again, datetime offset UTC now. So that's the item, and now that we got it, we will just say items.add to add the item to our static list. Finally, we're going to return the type created add action, which is derived from action result. So this is going to be used to say, hey, so the item has been created and you can find it at the following route. Which route is going to be? Well, it's the route with the name, so name of get by ID. So this means that the caller will be able to find, we're going to produce a header in the response that includes the exact route of the item as provided by the get by ID operation over there. We will also provide the ID of the created item as an anonymous type here. So it's going to be ID equals item.id. And lastly, the actual body of the response, which is the entire item. Right? So that's ready. I'll do F5 so we can try that out, see how that goes. Okay, back here, I'll just close this one. So back into the previous tab, I'll do F5. As you can see, now we have the post operation listed here and the create item DTO listed at the bottom. So I'll go for post, I'll expand this, and to try it out, I'll do try it out. And so here's where we can create a new item, right? So let's figure out some new item to create here. Let's say we're going to create a high potion. And so this one is going to restore a medium, restores a medium amount of HP. And the price is going to be, let's say, 9. Okay, and so now I'll do execute. As you can see, it invokes the same route, but in this case, it was with a post verb, post. And yeah, so we got 201, which means created at route, created at. Here's a response body, so the entire created item, including the auto-generated ID over here. And here you can see the headers includes the location of the just created item. So if I wanted, I can grab this ID and I can collapse, let's collapse post and then expand get items by ID, try it out, and I can paste that ID here and I should be able to find that just created item. As you can see, or here's the high potion. So post is working just fine. So now let's say that we want to update an item. So that's where we need to introduce the put operation. So let's go back to our Visual Studio Code. I'll stop this and close terminal. And let's declare a method to update items. So for this time, for this one, I'm going to declare public iActionResult, and I'll be using iActionResult because in this case, we don't really need a specific type for the return. We will just return this one called no content, meaning that's what you usually do for a put operation. You don't want to return anybody. You just say, hey, yeah, I did my job, but there's nothing to return. So it's going to be named put. So we want to receive the ID of the item to update, and we will use the update item DTO contract to receive the new payload or the new information for this existing item. So update item DTO. And we also have to specify the proper verb, so HTTP put. And just like we did with the get by ID, we have to specify what part of the route is going to be used for the ID parameter. So just like before, it's going to be ID. Okay, so once again, when somebody comes with something similar with get items by ID, somebody comes with not get, but put items / ID and some body, then this is the operation that's going to be honoring that route. So how do we implement this? So the first thing that we want to do is probably find the item that we're going to be updating. So what I'll do is I'll just say the existing item is going to be from our items list. Items list where item.id is the ID that we distributed the parameter, and then again singular default, right? So if you have it, we'll find it right there. Now that we found the item, we're going to update it, and to update it, we're actually going to do at this point is just clone it into a new item with the updated values. So we will say updated item is going to be the existing item with the name that is going to be update item DTO dot name, description update item DTO dot description, and price update item DTO price. Okay, so that creates a clone of the existing item and into updated item, and that's the one that we're going to be updating into the list. Okay, so now what we'll do is we're going to find the place in the list that that has the item that we need to update. So to do that, we're going to say, so the index of that item is going to be in the list, find index, okay, so it's going to be existing item.id equals ID. Okay, so that finds the index on that list where the item is. And then now that we have the index, we're going to say item.index equals updated item, replaces that in the list. And then we'll, like I said, we will just return no content. There's nothing to return. Okay, so let's try this out. So I'll do F5 once again, start a web host. And I'll close this page, and then I'll just refresh our Swagger UI page. And as you can see, now we have our put operation here at the bottom, and all the way to the bottom, we also have our update item DTO specified. So I'll expand put. This is going to require us first the ID of the item to update. So to get an ID, I'll actually execute our get items route. So I'll try it out, execute. And let's say we're going to update our antidote. So I'll copy the ID of the antidote, collapse this, and then back in input, I'll say try it out. I'll put the ID here, and then let's grab a few of the properties of the antidote. We don't have to start from scratch there. Collapse this, and then I'll place those items here, remove this comma, and then let's say we want to update just the price, and we'll say that the price, the antidote is going to be, let's say 9. And I'll go ahead and do execute. And as you can see, in this time, it invokes the API with the put verb into this request URL that includes the ID of the item. We get a 204 result, meaning no content. So as you can see, there's nothing being returned here, but the item was certainly updated. And we can confirm that by grabbing the ID of the item once again and going to our get items by ID route. We can try it out, paste it there, I'll execute, and then you can see now we have the antidote with price 9. So the update operation succeeded. So finally, let's add the operation to delete an item. So let's minimize this once again, stop and close. And before adding our delete route, just for completeness, let me add the comment here for our HTTP post route, which I didn't do. The post route is going to, as we saw, responds to the post verb, and the route is going to be like just items, right? So just so we have that comment over there. Now for the delete route, we're going to be using a method that is also be returning IAction result, just like in the put case, because we're going to be returning no content here also. And it's going to be delete. And we're going to receive, the only thing that we need to receive here is the ID of the item to delete. And we also have to respond to the HTTP delete verb. And again, just like we did with put, we have to specify which part of the route we're going to be using for the ID of the item to delete. So that's going to be ID once again. And here, just like we did with update, we need to find the index of the item to delete. So I'll copy that line from put, copy that into here. Okay. And so once we found the index of the item to delete, we're going to say, okay, so from the list, remove at, and we'll say index. So that removes the item at that index location, and then we will just return no content. So again, for completeness, let's add a little comment here. So when somebody comes with the delete verb and says /items and then /SOMEID, this is the method that's going to be honoring that deletion. So to try it out, again, I'll do F5. Okay, so back in Swagger UI, I'll refresh the page. And as you can see, now we have our delete route, our delete operation showing up here. And so I'll expand that. So we need an ID to delete. So let's actually execute our get items route, try it out, execute so that we can pick something to delete. Let's actually delete this antidote once again. So let's copy the ID of the antidote. And so I'll go back to delete, try it out, I'll paste that ID, and then I'll hit execute. And as you can see, now we're using the delete verb, invoking the API with delete. Here's the URL of the item that needs to be deleted. And we got a 204, no content. So as you can see, there's nothing returned, but the item should have been deleted. So if I go, I'll collapse this and I'll go back again to our get items route. I'll do execute again. And as you can see, the item, the antidote item has been removed. It's not here. So delete succeeded. So yes, our REST API seems to be working just fine. However, you can try querying for an item that does not exist, an existing item, or perhaps creating an item that does not have a name. What will happen in that case? So we'll need to do something about those situations. In the next lesson, we will see how to properly handle these kinds of invalid inputs. Let's try a few of the unexpected scenarios that our microservice REST API could face from time to time. So I have our catalog project open here, and I'll just do F5 to start a web server and go to our Swagger UI page. So here we are in the browser. I'll go to Swagger. And let's start by getting the full list of items as we have them right now. So I'll open our get items operation, try it out, click on execute. And here are the 3 items that we have available right now. So let's say I want to query for one of these items, the potion. So I'll copy the ID of the potion. I'll close this. And then I'll actually go to our get items by ID operation. Okay, so I'll do try it out. I'll paste ID here. But I'm actually going to flip one of the characters here. I'll flip this 1 to 2. So this is an existing item. We don't have that available. And I'll click on execute. See what we get. So what we're getting is a 204 result, right? Which is not expected. When an item is not found in the REST API, the expectation is that you would return 404 status code or not found. So let's see what's actually happening back in Visual Studio Code. See where we're getting this. So I'll put a breakpoint in over here in our get by ID operation. And then I'll go back to Swagger. I'll try this again. So I'll hit execute. And here we are, Visual Studio Code. So we try to find the item, and of course the item is null. We cannot find it. Okay. So what can we do about this? Let's see. I'll just stop debugging here, close terminal. And so really the fix is fairly straightforward here. What we would like to do is just check that if the item is null, we will go ahead and return not the item, but we would like to return the not found action result. However, of course, IntelliSense is complaining here because not found does not convert into item DTO here, right? So here's where action result becomes super useful. Now we can say action result of item DTO, and that gives us the ability to return either the item over here or the not found result over here in this case. So as you can see, we can return more than one type of result depending on the current situation. So let's try that out. I'll hit F5 once again. I'll remove this breakpoint first, and then I'll hit F5. Okay. So here we are again. I'll just copy this ID and refresh the entire page. Should still be a not found item. So get items by ID. I'll click on try it out. I'll paste that ID here, and I'll hit on execute. See what we get. So as expected, this time we get a 404 result saying not found. So this is the correct status code for an item that cannot be found in the REST API. And likely we're going to have the same issue with our put API, right? So let's see. let's see actually which APIs will be impacted. So not post, but put is going to be impacted because it needs to find the item. And likely the delete operation could also be impacted because it needs to, again, find the item before it can delete it. So let's start by fixing put. It's going to be pretty similar. Basically, if existing item is null, we will say not found. Okay, so that will do it for put. And then in the case of delete, what we're going to do is just that if index is less than 0, so basically a negative number, it means that we cannot find the index of the item. Therefore, we have to say return not found. Okay, so that should do it. I'll hit F5, let's see what we get. I'll close this. And I will, I'll copy this ID, unexisting ID once again, and I'll try to do a put operation now. So I'll try it out. I'll put this ID here, and I'll put just something here for the body. So some item description, and price too. So just to try it out. And so I'll go ahead and say execute, and as expected, now we can get a 404 on that case. Not found. I'll take that ID once again, and let's try out our delete operation. So let's try to delete that unexisting item, see what happens. So yep, as expected, delete is also returning a 404. So we can now say that we're probably handling the case of not finding items in our different REST API operations. Now let's try something actually different. So what happens if we try to create an item with some missing item properties, right? So let me collapse this and collapse this, and then let's go to post. Okay, so I'll try to post an item, let's say without a name. We shouldn't be allowed, really. And let's say that this was really for our high potion, which the description would be restores a medium amount of HP, and that price was 5, right? Perhaps 7. And so let's try to create an item with no name. So go ahead and hit execute, go down, and 201, meaning create that action, so it actually got created. But look at this, the name is null. And if we try to query for that item with this ID, so let's do get by ID, try to query for it, execute. As you can see, the item is now in our collection and is with a null name. And not only that, let's see what happens if we try to create it with a negative number, right? So not 7, but let's say -7. What happened in that case? So let's do execute. And again, it got created to 201. And then now we have this other ID. And so now this item actually has a null name and a negative price. So this is really bad. So what can we do about this situation? Let's go back to Visual Studio Code. Let's stop and close. And then I'll expand our navigation pane again. So what we can do is actually do some model validation, right? So back to the DTOs, we need to introduce a couple of attributes to properly validate the inputs here. And the DTOs that we would care about in this case are both the create and the update DTOs. So what we can do is, let's say for the case of the name, if the name is always required, what we can say is just add this attribute here called required, which might require a namespace import, system component model data annotations import, and that makes it so that name will always be required anytime somebody uses this create item DTO. Okay, and I'll also add it for our name property in the update item DTO. And then also we can do something about the price. So in the case of the price, let's say that, well, let's add an attribute here. And let's say that what we want to enforce is that the price should always be, let's say, between 0 and 1000 yield. Right? Let's say, but we actually want to allow free items, so they can be 0, but definitely not negative, and only up to 1000. So what we can do is use a range attribute here, and we can say here the minimum value, which is going to be 0, and the maximum value, let's say, is going to be 1000 here. Okay, so that makes it so that anytime somebody specifies a price here, it has to be in this range. That implicitly also makes sure that it cannot be null, right? But however, I mean, since this is a value type decimal, really this value can never be null. So worst case, it will be 0. But with this, we ensure that it has to be between 0 and 1000. I'll do the same thing for our update item DTO. Hit save. And now let's try it again. So I'll hit F5. Okay, back here. And I'll go ahead and I'll just copy this and I'll refresh our page. So let's go ahead and try to do a post. Try it out. And so let's start first with no name. So I'll say price is still positive, but we don't have a name. And let's try to execute this and see what happens. So as you can see this time, we do get a 400 bad request error, which is expected in this case. And we do have the proper validation message coming out of the errors, this errors array that is available now. So one or more validation errors occurred, status 400, and the name field is required. So that's great. And furthermore, if we still want to use that negative number, so I'll do -7, hit execute. See, now both validations have been performed. So the name field is required, and the field price must be between 0 and 1000. You can also try using invalid input for our put API operation now, and you should get similar validation errors. In the next module, we will learn about the repository pattern, and we will stand up a proper database to store our catalog items. In this module, we will update our catalog microservice to be able to store and query for items that live outside of the service and into a proper database. By the end of this module, you will have a solid understanding of the following: what is and how to use the repository pattern to store and query data, how to use a MongoDB database as the underlying data store of catalog items, how to use Docker to run infrastructure services like MongoDB Server, what is and how to use the dependency injection technique for proper decoupling of dependencies, and how to use the .NET configuration system to specify settings that could change across environments. In this lesson, we will learn about the repository pattern and how to implement a repository to manage the catalog service items in a MongoDB database. So, what is a repository? A repository is an abstraction between the data layer and the business layer of an application. To understand why you may want to use a repository, let's say that today we have the application logic of our service talking directly to our MongoDB database. However, a few months or years from now, requirements change and we need to switch to a different database provider. Given the way that things have been set up, we would likely need to rewrite a good chunk of our application logic in order to talk to the new database, which is pretty bad. Instead, what we can do is introduce a repository. This repository is the only one that knows how to talk initially to our MongoDB database, and it's the only one that our application logic will interface with. Then, if we ever get the requirement to move to another database, the only thing that we would need to change is our repository, but the application logic stays the same. So, the repository pattern is important because it decouples the application logic from the data layer and minimizes duplicate data access logic across our service. We will be using MongoDB as our database of choice for all the microservices in this course. MongoDB is a document-oriented NoSQL database which stores data in a JSON-like documents with dynamic schema. We will prefer a NoSQL solution as opposed to a relational database for our microservices because we won't need relationships across the data because each microservice manages its own database. We don't need ACID guarantees, where ACID stands for atomicity, consistency, isolation, and durability, which are properties of database transactions that we don't need in our services. We won't need to write complex queries, since most of our service queries will be able to find everything they need in a single document type. And we need low latency, high availability, and high scalability, which are classic features of NoSQL databases. Let's go ahead and implement our items repository. Before implementing our repository, we will need to decide which is going to be the class that represents the objects that will be managed by the repository and that will make their way into our database. The class that we use for this should not be confused with our DTOs because we want to have the freedom of updating how we store the items in the database at any given point, regardless of the contract that we will need to honor with our service clients. We will then give the name of entities to the classes that our repository uses. So let's start by adding a directory to store these entities. So right click on Play Catalog Service, let's add a new folder. Let's call this one Entities. And inside Entities, let's add a new file. And our main entity here is going to be the catalog items. So let's just call this one item.cs. And here, let's go ahead and declare our namespace. It's going to be namespace entities. And now let's declare the class. All right, so our item entity is going to have a GUID, which is going to be the ID. And let me control dot to import the system namespace. It's going to need a name. It also needs a description. We also need a price. And finally, we are going to need a datetime offset that's going to be the created date. Okay, so now it's time to actually add a repository. But before doing that, we're going to need a NuGet package, the MongoDB driver NuGet package, because this is the one that's going to allow us to actually interface with the MongoDB database. So to do that, I'm going to do Ctrl-J in my keyboard to open the terminal. And I'm going to switch to the directory where we have the catalog service. So that will be the catalog service. So then I'll just do .NET add package MongoDB.driver. So this will bring in a bunch of libraries that we're going to be using for interacting with MongoDB. So, and you can confirm that the package was added if you click on Play Catalog Service, csproc, you'll see that we have that new library right here. Okay, so now let me just close this terminal. And now we can actually create a directory for our repository. So I right click, Play Catalog Service, new folder, repositories. And in this folder, I'll create a new file. Again, since this repository is going to be managing our catalog items, I'll name it items repository. .cs. And at this point, I'll just close this navigation pane so we get more space. Let's add a namespace. It's going to be repositories. And the name, like we said, public class items repository. Okay. In order to be able to interact with MongoDB, we're going to need a few class level variables here. The first thing that we're going to define is actually a constant. We're going to name it collection name. Collection name. Which is going to be, the value is going to be just items. So the collection name represents the group, a collection represents a group of objects in MongoDB. Similar to as in a relational database, you will have a table. In MongoDB, you have a collection. Okay, so the collection that we're going to store all these items in MongoDB is going to be named items in our case. Now we're going to define the variable that's going to hold the actual instance of this MongoDB collection. So let's name this one read-only Mongo collection of item DB collection. Okay, so I'm going to need to start importing namespaces here. So control dot to import MongoDB.driver and control dot to import play catalog service entities. Like I said, DB collection is the object that represents our actual MongoDB collection. We'll add one more class level variable here to represent the filter builder that we're going to be using to build the filters to query for items in MongoDB. So let's declare a filter definition builder of type item. Let's name it filter builder. And we can get that from builders of item dot filter. Now that we have that, we can go ahead and declare the constructor of this repository. So public items repository. And here what we want to get is to actually construct the instance for DB collection. But before we can do that, we have to start by using the Mongo client class, which is the one that you can use to actually connect to the database. Here's where you declare how you're going to connect to MongoDB. So we're going to say Mongo client equals new Mongo client. And here's where we can specify the connection string to connect to MongoDB. For now, we'll just declare this connection string right here in plain text. But later on, we'll move this connection string to a more suitable place. So it's going to be MongoDB localhost 27017. Also, in a future lesson, we will learn how to actually stand up that MongoDB server so that it actually lives in localhost 27017. Now we're going to declare the object that represents the database, the actual database where these catalog items are going to live. So database equals Mongo client get database. And then the name that we're going to give to this database, since this is the catalog microservice, the name is going to be just catalog. Finally, we can get an instance for DB collection. And we can do that by doing database that get collection of item, and then we give it the collection name that we have already declared. Okay, we'll be using this DB collection object for a few operations in a moment. Now, for our repository public methods, we will be using the asynchronous programming model. This will avoid performance bottlenecks and enhance the overall responsiveness of our service. To take advantage of this model, all of our methods will become asynchronous by returning async task and by using the await keyword anytime they interact with the database. We will also use the async suffix on all the methods to surface the fact that the methods are asynchronous. Okay, so the first method that we're going to implement is the one that's going to be able to return all the items in the database. So let's name this one public async task of I read only collection of item get all async. Okay, so I'm missing a namespace here. So like I said, we need to return task to make this method async. And I'm also using iReadOnly collection here because really the expectation from the point of view of the consumer is that we're going to provide a collection of items that the consumer should not need to modify. So this is a collection that should only be read, right? So this is a good API pattern to follow. How to await this collection of items? So basically we can do return await DB collection, then we can do find, the find operation. And here, since we are not going to really provide any filter because we want all the items, we can just say filter builder.empty to list async, to convert that list into an asynchronous list. And then, yeah, that will give us all the items in the database. Okay, so let's now declare a method that we can use to get one specific item from the database. So I'm going to declare public async, again, task of item in this case, and we'll name this method getAsync. It's going to receive a GUID. It's going to be the ID of the item, and I'm going to import the system namespace for this. Okay, let's scroll down a bit. And then to be able to query for this item, we need to create a filter. So I'm going to declare a filter definition of type item. So let's name it filter. And then we're going to use the filter builder to say that we want to build an equality-based filter, where we're going to receive this entity object, where the entity.id should match the ID of the parameter that we just received. Okay, so that's how you can build a filter to find one of the items based on ID. And then we can just say return await DB collection find. Then we provide the filter, and we'll say we want to get the first item that we find. So we're going to use first or default async in this case. So that will find the first item in that collection that matches that filter. Let's now add a method to be able to create an item into the database. So to do that, we can define public async task, create async, receive our item that we're calling it an entity here. And the first thing we're going to do is a quick check to make sure that that receive parameter is not null. So if entity is null, we're just going to throw an exception, argument null exception, and we're going to name and give the name of our entity parameter. Okay, and then to create the actual item is as easy as saying await DB collection insert one async, and then we provide the entity. Right, so that will go ahead and create the item into the database. The next method we're going to implement is the one to update an item, existing item into the database. So to do that, I'm going to declare public async task update async. Notice that both create and update are not returning really anything. So the expectation is that we either just insert or update the item, but we're not going to return anything back to the client. Here we're going to receive the item to update. Let's call it entity. That's the item to update. All right. And just like we did with create, let's do a quick check, make sure that we're not getting a null value here. And now we're going to build our filter definition to be able to find that item. And I'm going to copy the one from getAsync just because it's a very similar filter. The only difference here is going to be that we're going to rename this parameter here to existing entity, just to not confuse with the entity that we're going to use to find the ID. So we're going to say we need to find the existing entity whose ID matches the entity that we received, that ID. So that's a filter to find the existing item, and then we can go ahead and say await DB collection dot replace one async. We pass the filter, and we pass the entity that has to replace the existing item found by that filter. And finally, let's implement the method to delete an item from the database. So we're going to say public async task. It's going to be remove async. We provide the ID of the item to delete. Again, we're going to use a filter very similar to the one we used for get async. So I'm going to copy that one once again. So copy that. That finds the item. And then we can say await DB collection, delete one async, and we pass a filter. Yep, that should go ahead and delete the item from the database. And with that, our items repository is ready. So in the next lesson, we will integrate it with our existing items controller so that it can start querying items from MongoDB. It is time to integrate our new items repository with our existing items controller. But before we can do that, we're going to need a way a way to translate our new item entities into our existing item DTO, specifically for the purposes of returning these DTOs in our GET operations in the REST API. So there's a few ways to do this, but one simple way that we can achieve is by introducing an extension method. So let's see how to do this. We're going to right click on Play Catalog Service, and we're going to add a new file that we're going to name extensions.cs. Let's add a namespace here. Namespace Play Catalog Service. And here we're going to declare a class that we're going to name just extensions. And in this one, we declare a public static method that returns IDDTO. And this is because all extension methods should be static. And we're going to name it as DTO. So this method is going to receive a current instance of an item entity. Okay, and then let's import namespace control dot play catalog service DTOs and play catalog service entities. Okay, so the purpose is to just turn the item entity into the item DTO. And to do that, we just have to do return new item DTO. And we're going to provide here the different parameters, right? Everything comes from the entity. So item ID, item.name, item description, item.price, and item.created date. Okay, so as you can see, it's a very simple method that just turns an item into an item DTO. We'll see how we use this in our controller. So now let's open up that controller. So in controllers, items controller, and I'm going to close the navigation pane once again to have more space. And the first thing that we're going to do is to actually get rid of this list. We don't need it anymore. And we're going to replace it with a variable for our repository. So it's going to be private, again, read only because we don't want it to be modified after construction. Items repository. And we're just going to say new. So it's going to get constructed. When the controller gets constructed, I'm going to import the right namespace here. So let's start using this items repository here. However, since you remember all of the methods in items repository are asynchronous methods, we will also have to turn all the methods in this controller into asynchronous methods. That way we can have the asynchronous benefits all the way from the controller all the way to the repository and to MongoDB. So to do that, I'm going to turn, let's start with get all. So we're going to turn this into async task of IEnumerable of item DTO. And we're going to append the async suffix to this method. Let's import a missing namespace, 3 tasks. And now to return the items, well, this is what we can do. Items is going to be wait items repository, get all async. Okay, and then from that, we're going to project these items into these item entities into DTOs. But before we can do that, we have to put this into parentheses. And then we can say, okay, so from that, let's do select. And each of the item entities is going to be turned into a DTO via our new asDTO extension method. So that's there you can see how easy it makes it this extension method to turn an existing entity into a DTO. And then we just return those items. Okay, so let's go to the next method. So this is get by ID. So once again, we will turn it into async task of action result of item DTO. Get by ID async. And then to get the item, what we're going to do now is just wait item repository, get async, and we provide the ID. And at the end of this method, we can't just return that item entity. We have to say as DTO, so that turns the entity into a DTO. Let's now go for the post method. Let's scroll down a little bit. So once again, this has to be an async task of action result of item DTO, and it's going to be post async task So instead of doing this, we're going to create an item entity, in this case, out of the properties of create item DTO. So we're going to say var item equals new item. And we're going to start giving it the properties values. So create item DTO.name, description, and create a date. Here's where we're going to give the current date as the creation date of this item. Also remember, this is not item DTO, this is just item. Okay, I may need a namespace here. Yeah, the entities namespace. Now we can go ahead and actually create the item via our items repository dot create async method, and then we pass the item. And finally, we have to rename this method from getById to the new name, which is getById async, the one that we just renamed, because that's where the created add action should point to. Let's now go ahead and implement our put method. Scroll down. So once again, we turn this into public async task of iAction result, put async. And once again, we have to do things a little bit different now. So I'm going to actually remove this whole block here. And first thing we're going to do is find the item now in the via the repository. So it's going to be existing item. We're going to see it's going to be await item repository that get async. Notice also how easy it is to actually interface with MongoDB via our item repository without having to write the same piece of code once and again, right? The filters and all that. So we just got the item just like that. And then, yeah, if we cannot find the item in the database, in which case it will return null, we want to keep returning not found, just like before. And here, once we find the item, we will have to just update these properties based on update item DTO. So that's going to be existing item.name equals update item DTO.name, existing item.description, update item DTO.description, and existing item.price, update item DTO.price. And with that, we can go ahead and say await item repository update async with the existing item. And finally, let's go ahead and update our delete method. So we're going to say again async task iAction result delete async. And we're going to do a similar logic to find the item as we just did with update. So I may just copy this piece here. Okay, I'm actually going to remove all this, paste that. Okay, I'm going to say, so yeah, so var item is item repository get async. If the item is null, we'll say not found. And otherwise, we can go ahead and say await item repository dot remove async with item.id. And then one last thing that we may want to tackle here, since we are making these changes, is to actually fix an issue, kind of a breaking change that happened in ASP.NET Core 3, where if you try to do, let me go back to post. If you try to do a post and create an action into a method that ends with async, with an async suffix, that's actually not going to work, because at runtime, ASP.NET Core is going to remove the async suffix from the method, and that will make it so that created action will not be able to redirect to the right place or to produce the headers that it needs to produce. And so there's an easy fix for that. So let's actually make that fix right away. So I'm going to go back to Explorer, going to open Startup, and let's locate the section where we do add controllers. In configure services, in add controllers, you're just going to add a little option here. So it's going to say options, and then we open and close braces, and we're going to say options that suppress async suffix in action names is going to be false. And with that, at runtime, ASP.NET Core is not going to remove the async suffix from any of our methods, and that will make post-async work just fine. So our REST API is ready to use our new item repository to store and query the items in the MongoDB database. However, we still don't have an actual MongoDB database or even a MongoDB server. But that's a problem that we can easily solve via Docker. In the next lesson, we will learn about Docker and how we can use it to run the infrastructure components needed by our microservices. In this lesson, we'll learn about Docker and how it can be used to run infrastructure components needed by your microservices. So what is Docker? Docker is a platform that provides the ability to package and run an application in a loosely isolated environment called a container. Here's how it works. We start with our catalog service, which, as we know, needs a database to store and query for items. The piece of software that knows how to stand up and operate this database, in our case, is MongoDB. The MongoDB server, along with all the software prerequisites, has already been packaged in what we call a Docker image. And this image is publicly available in a place called Docker Hub. We want to download and run this image in our box. And to do that, we use the Docker engine, which is one of the pieces that you installed at the start of this module. All Docker images are guaranteed to run anywhere the Docker engine is available. To pull and run this image, we will use the Docker run instruction in our box. Once the image is run or executed, it becomes what is known as a Docker container, a MongoDB container in this case. This is a fully working MongoDB server ready to respond to the requests of our catalog microservice. The catalog service will create a database via the MongoDB container and will start interacting with it via the MongoDB driver for .NET. Notice that even when this container manages the catalog database, the database itself does not live inside the container, but outside of it, to ensure that it is not deleted once the container is destroyed. Let's try it out. To start using Docker in my box, I'll start by opening a terminal. So I'll press Ctrl J, and then I'll also close our navigation pane, just so we have a bit more space. And the first thing that I'll do is I'll just type docker run to run a container, and then I'll specify the -d modifier so that we don't keep being attached to the Docker process all the time. And then I'll do --rm, so this we'll use so that whenever we stop running the container, it gets automatically deleted so that we don't keep hanging it around in the box. Next, I'll specify a name, which is going to be just Mongo. So you can put any name here, but the idea is that you don't lose track of this Docker container, because otherwise you get a random name and it's a bit hard to identify. Next, we have to specify a port. So we have to specify which is the port that we're going to be using to talk to MongoDB, to the MongoDB server. So we'll specify -p 27017 mapped to 27017. So this means that in order for us to reach the MongoDB container, we can use port 27017, is the external port. And then in order to get that mapped into the internal MongoDB server, we have to map into 27017 also. So this port is the default port that MongoDB uses internally. And this just means that from the outside, we open kind of a window in order to talk to the container via 27017, and then that can be mapped into the internal port where MongoDB is already listening. You could be using any port in the left side, it's really up to you. We're just choosing a default mapping there. Then we'll specify a volume. The volume we're going to be using so that we specify how we are going to store the database files that MongoDB is going to be using. So we're going to say MongoDB data :data/db. So this section on the right side of the column /data/db is the default location where MongoDB stores the database files. So this mapping means that anytime that the MongoDB server tries to store files inside the container under /data/db, those files are actually not going to be written inside the container, but outside of the container into this location called MongoDB data, which is part of our local host machine. So it's outside of the container. So this is the way that we can prevent those database files from being deleted anytime the Docker container gets also deleted. And finally, we'll specify the name of the Docker image that we want to run. In this case is Mongo. Now I'll hit enter. Now perhaps I'll expand this a little bit more. So at this time, Docker is pulling all the layers of the MongoDB Docker image into my box. Okay, so layer by layer, it gets unloaded just the first time, and this may take a while. But the second time that you do this, and any subsequent time, this is going to be much faster because the image is already there. So if I did that again, it will run instantly. Then we can confirm that the Docker image is actually executing by just running docker ps. As you can see, the Docker image is up and running. It's been running for 14 seconds right now. Okay, so now we can try running our REST API against this Docker container and see how that goes. So I'll hit F5 here. And I'll go to our Swagger page. So the first thing that we can try, just to verify that there's nothing here because it's a brand new database, is our get all items operation. So I'll try it out. I'll hit execute. And as you can see, there's nothing in there. The database is all empty. So next, let's try creating something. So I'll go to our post operation, try it out, and let's try to create something here. So we will go back to our potion sample. So I'll just name this potion, and this is going to restore a small amount of HP, and the price is going to be 5. And with that, I'll hit execute. And as you can see, the item has been created. We got a 201 response code, create that action, here's a response body, and we also got the location here to find our item. So in fact, we can copy this ID of this item, and we should be able to use our get by ID operation to find it. So I'll collapse this, I'll expand get items by ID. I'll try it out, paste the item here, execute, and certainly we can find the item. So the item has been stored into the database. But now if you wanted to know how this item has been stored into the MongoDB database, there's an easy way to figure that out. So I'll go back to Visual Studio Code, and then I'll just stop and close this. And what you can do is use a MongoDB extension for Visual Studio Code. So to install that, just go to the extensions hub on the left side, look for MongoDB, and it should be the first hit on the left side. So I'll click on that, I'll click on install. And now there's a new icon showing up on the left side for MongoDB, which I'll click now. And then it should connect straightforwardly into the MongoDB database just by expanding this node for localhost 27017 since it's the default port. It just connected. So I'll expand this. And as you can see, there's a catalog database available right there. So it has been created. If I expand that, there is an items collection available. This is the one that where we are storing our items. And then I'll expand that further. And as you can see, there is one document already created into the catalog database. If we expand that, we can see that there's an item in there. However, if we try clicking on it, let's click on it. What you can see most of the members of the created item, but some of them are not easy to recognize. Like for instance, the ID is not the GUI that we were expecting, and the created date is a bit hard to read. The other elements are there, so potion, description, and price. So how can we get a better, a more friendly, representation of these items like ID and created date? So ideally, we want to see something more easily recognizable. So there's actually an easy way to fix this. Let's go back to our Explorer, and let's go to our startup class. Okay, once again, I'll collapse this. So to fix the JSON representation of our items, we just need to register a couple of MongoDB serializers. We can do this in the configure services method of the startup class. We will talk more about the role of startup in ASP.NET Core Apps in the next lesson, but for now, let's just think of configure services as the place where we register services that can be used across the entire application. So let's scroll down a little bit. Here we are in configure services. And what I'm going to do is just expand this a bit. And I'm going to add Bison serializer. And for this, I may need to import namespace, MongoDB.bison.serialization, .register serializer. And here we're going to provide the serializer we want to use. In this case, it's going to be new GUID serializer. And then I'll import MongoDB Bison serialization serializers. And then it's going to be Bison type. And I'll import one more namespace, .string. Okay, so that means that anytime we store any document into MongoDB with a GUID type, it will be stored actually as a string, as opposed to the representation that we were looking at a moment ago. And we're going to do pretty much the same thing for the datetime offset. So in this case, we're going to say, so instead of GUID serializer, we'll use datetime offset serializer. And then this line now says that anytime we store any document with a datetime offset property, it should be stored, that property should be stored as a string. Okay, so save that, and that should be enough to fix our representation of the items in there. However, to not mix things, what I'll do now is I'll actually delete our existing database so that we can recreate it with the proper serialization type. So I'll close this here and I'll go back to our MongoDB extension, and I'll right click in the catalog database. I'll say drop database. I'll type the name, enter. And if we refresh this, there should be no database available anymore. Okay, so with that, let's hit F5 once again. Okay, back in Swagger UI. Let's see if we still have the post available here. Yes, we have. So I'll just refresh the page. And I'll go back to post, and once again we should have no items, so I'll go to get all items, try it out, execute. So there's no items because a new database has just been created because we deleted the previous one. So back into post, I'll try it out, and I'll paste the what we typed a moment ago. So it's a potion, price 5, restore a small amount of HP, and I'll hit execute, and once again the item has been created with this ID. And this time we'll go back to Visual Studio Code, and let's see how that got stored. So I'll refresh this, right click, refresh, expand catalog, items, documents. And as you can see, the ID, it already looks like a GUID. And if I click on it, and I'll close this a bit, now we have a much friendly representation of the item. The ID is a proper GUID, and the created date is a datetime offset that we can actually understand. So that's the effect of using these serializers in there. So let's continue using our REST API. Let's make sure all the operations are working properly. So as we saw, we just created this item. And if we use get items by ID, we should be able to find it. So let's confirm that. Paste in there, execute. So yeah, indeed, we were able to find the item. Now let's try an update on an item. So to do that, let's use the put API. So I'll click and expand on this. I'll say try it out. Let's grab the ID of that item once again. So it's over here. Here's the ID. So I'll paste it here. So we're going to update that potion. And then for the elements of this potion, let's copy also a few of the existing elements. So I'll copy this from our get by ID route into here. Actually inside there. I'll remove this extra comma. And so the only thing we're going to modify here is just the price of the potion. So instead of being 5, I'll say it's going to be price 7. And I'll hit execute. We're at 204, so no content, successful no content. So this means that the item has been updated. And to confirm that, let's go back again into our get by ID route. Let's execute again. And as you can see, the price has been updated. So our put route is working just fine. And for the final exercise, let's try to delete this potion, right? So I'll go ahead and copy again the ID of the potion. And let's collapse this and that. And let's go to the delete route. Try it out. Paste here. I'll hit execute. 204, no content. and it's a success. So the item should no longer be there. So I'll try to actually get this item by ID once again. Let's see what happens. As expected, it's 404. It can't find the item. And in fact, if we go to get all items, there's nothing there. So the item was deleted. Okay, so at this point, we have a fully working REST API with all the basic CRUD operations that's working against a MongoDB database. But we still need to polish a little bit the code base that we have so far. So in the next lesson, we will learn about the dependency injection technique and the .NET configuration system. In this lesson, we will learn about the dependency injection technique and the .NET configuration system. What is dependency injection? To understand what dependency injection is, we can start by thinking about a class that uses some other class. For instance, our items controller uses the items repository. When you have this relationship where one class uses another class, we say that this second class is a dependency of the first class. Now, if instead of constructing the items repository object directly as we are doing so far, we receive an instance of items repository in the items controller constructor, then we are injecting items repository into items controller. This is what we call dependency injection. But also notice that the constructor is not exactly receiving an instance of items repository, but instead it receives an interface called IItems repository. This relates to what we call the dependency inversion principle. The dependency inversion principle states that code should depend on abstractions as opposed to concrete implementations. Let's bring again our class and one of its dependencies, dependency A. Currently, the class depends directly on dependency A. However, we can change this so that the class instead depends on an abstraction, which in the case of C# is an interface. And then we can have the dependency depend on or implement the interface. Why would we do this? Well, by doing this, our class implementation is decoupled from the dependency implementation in such a way that if we ever decide to switch to a different or updated dependency, our class does not need to change at all. The only thing that the dependencies need to do is to implement the interface that our class depends on. So, by having our code depend upon abstractions, we are decoupling implementations from each other. And this also makes our code cleaner, easier to modify, and easier to reuse. Now that our code is decoupled from these dependencies, we have a new problem. How and who is going to construct the dependencies? Imagine once again that we have our class, which depends on an interface implemented by dependency A. Since our class cannot construct the dependency directly, because it only knows about the interface, a third actor comes into play, which is called the service container, which in ASP.NET Core is known as iService Provider. During application startup, which typically happens in startup.cs in ASP.NET Core apps, we would register our dependencies with the service container, and this one in turn builds a map of all the registered dependencies. Then, eventually, when our class needs to get constructed, the service container first finds, constructs the dependency, or reuses it if it already has been constructed, and then injects it into our class as it creates our class instance. This is very powerful because you could even have dependencies that depend on other dependencies, but as long as they all have been registered with the service container, they will all be resolved properly whenever any class needs them during the application lifecycle. Let's also talk about configuration. At this point, our service is able to talk to our MongoDB database via the host and port information that have been hard-coded in our service implementation. However, this is not ideal, since eventually the MongoDB Docker container will live outside of our local box, where localhost will likely not make sense and port 27017 is not guaranteed to be available. Luckily, ASP.NET Core supports a few configuration sources that are able to store and provide such configuration details to our service when needed. One of the most popular sources, especially for local development, is the appsettings.json file, where we can store all sorts of configuration information that we expect could change across environments, like the database host and port. And the good thing is that, just like this one, there are several other sources like command line arguments, environment variables, local secrets, and even the cloud. All these configuration sources are automatically read for us and loaded into the configuration system during host startup, which is configured in the program.cs file in ASP.NET Core Applications. And from there, we can get access to them typically in our startup.cs file. Let's now update our catalog service to take advantage of both dependency injection and the ASP.NET Core configuration system. In order to start using dependency injection in our microservice, we will need to start using interfaces as opposed to concrete types when constructing dependencies. Let's start by updating items repository so that it implements an interface that we can use in items controller. So let's go to our repositories directory, items repository. And then what we want to do is to extract the interface that represents items repository. And we can do that by clicking on items repository. And as you can see, there's this yellow light bulb over here. You can click on that one, and then you can click on extract interface. By doing that, as you can see, the full skeleton of the interface has been extracted out of the items repository class, and items repository is now implementing iItems repository, our new interface. We also want to have the interface living in its own file just to follow some good code organization across our microservice. What I'll do is I'll click on iItems repository, I'll click on the light bulb, and then I'll click on move type to iItems repository.cs. Now iItems repository lives in its own file over here on the left side, iItems repository in the same repositories directory. And so with that done, we are able to start doing dependency injection of items repository into the items controller. So I'll open the controllers directory. I'll go to items controller. I'll scroll up all the way to the start of the class. And I'll start by updating our items repository definition here so that we actually use items repository as opposed to item repository. And I will not create an instance right there. It is time to introduce a constructor for this controller. So I will do public items controller. And here's where we are going to inject the items repository dependency. So items repository. And here we'll just do this item repository equals item repository. So just by doing that, item repository is being injected into items controller. Now, the same way that we are doing this, we also want to use dependency injection in items repository itself. So let's go back to that file. Because we don't want to be constructing the Mongo client like we're doing it here. We want to just receive an instance of our Mongo database or iMongo database directly as a dependency injection. So what I'll do is I'll just declare in items repository an iMongo database object, and we'll say database. And with that, we will get rid of these two lines. So now items repository is ready to receive an instance of database via dependency injection. However, now that we have removed those lines, we need a way to actually construct this database object and configure it. So let's go into the configuration part of this now. To configure the host and the port that our service needs to connect to, what we can do is to declare these settings in our app settings.json file. So let's go to app settings.json. And here's the ideal place for you to declare these kind of configurations that could change with different environments. So what I'll do is I'll open up another section here. Let's call it MongoDB settings. So we'll open up a section. I'll put a comma also here. And then the first setting is going to be the host, which in our case, since we're running against a server in our local machine, is going to be just localhost. And the port is going to be 27017, the default port and the one that we've been using in our Docker container. We are also going to add another settings section to define our service name. This service name is going to be used across a few places in our microservice. So let's declare that just on top of MongoDB settings, we will name it, this section is going to be service settings, and we'll just declare one property here, which is going to be service name, which in our case, since this is the catalog service, we will just put the value of catalog. Okay, so now we have a setting for the service name and for the MongoDB host and port. Now the thing is, how do we consume these settings in our code base? So there's a couple of ways to do that, but I think the most straightforward way is to define a class that represents each of these two settings so that then our code base can start using them right away. So to do that, what I'm going to do is just right click on play.catalog service. I'll create a new folder that we're going to name settings. And in this folder, I'll declare classes for both service settings and MongoDB settings. Let's start with MongoDB settings actually. And I'm actually going to copy the name of the setting. So to make sure that the class that we create here matches exactly the name of MongoDB settings in there. So I right click, new file, MongoDB settings.cs. Let's declare a namespace. It's going to be play catalog service settings. And let's declare our class, MongoDB settings. And just as we just did, it should have properties for host and port. So let's declare prop string host and prop string port. Actually, this should be an integer. So prop import. And then since we are not planning to change these settings after the microservice loads, we will switch from this setter from set to init. So that will prevent anybody on any piece of the code to modify the values after they have been initialized. Next, we're going to also declare another property, kind of a calculated property, that's going to define the connection string to MongoDB. So we're going to declare public string, connection string, and we'll do a little bit of string interpolation here, where we're going to declare MongoDB, and that's going to have the host and port. So the host comes from our host property, and the port comes from our port property. Okay, so this is what we call an expression body definition. So it's a property defined directly by the value on the right side. Right, so we have a connection string there. The next thing we need to do is define a type class for service settings. So I'll copy the name of service settings here. And then again, I'll right click settings, new file, service settings.cs. Declare again namespace, catalog service settings, public class service settings, and the only property that we have for this one is a service name. So prop string service name, and again this will be init. Now that we have all this defined, it's time to start constructing all these services, constructing and registering and constructing all these services that we'll be using for dependency injection, and also taking advantage of configuration. So to do that, we'll go to the startup.cs file, and I'm going to collapse this to get a bit more space so we can see. And the first thing that I'll do is I'll go to the top of the startup class, and I'll define a variable, a class level variable for our service settings, just because we'll be using it in a few places across the subsequent lessons. So private service settings, and I'll have to do control dot to import play catalog service settings. All right, and then just before adding controllers, I'm going to open a section here where first we're going to retrieve the value of those service settings. So what we're going to do is service settings equals, and here's where we access the .NET configuration system, where we'll be at the configuration property that we have available right here at the top, configuration. So we're going to say, okay, so configuration, we're going to get section So we want to get the section that has the name of our service settings class. So this is what we wanted to make sure that the class is named exactly as the name of the configuration. And when we have gotten that, we're going to turn it into the actual type. So we're going to say .get service settings. There. So with that, we are deserializing the value of service settings that has already been loaded into the .NET configuration system into this service settings variable here. The next thing we're going to do is to construct our MongoDB client. To do that, we're going to be using our services collection. So we will do services, which is we received in the as a parameter to configure services. We're going to say add singleton. Add singleton allows us to register a type or an object, and makes sure that there will be only one instance of this object across the entire microservice in this case. So any class that needs it will get this one instance so they can use it. So here we're going to receive the service provider. Okay, so now we'll open an expression here, and I'll close this with that. And just like we did with service settings, we're going to now define or retrieve our MongoDB settings. So I'm actually going to copy this section here, and we're going to say this is going to be MongoDB settings. Okay, so is configuration get section name of MongoDB settings, and then we will again convert it into the actual MongoDB settings type. Now that we have the settings, we are able to construct the Mongo client, which, like I said before, is the class that we need to use to actually connect to MongoDB. So we will say Mongo client is a new Mongo client, and I'll import MongoDB driver here. And here, what we want to pass is the connection string. So to pass the connection string, we will do MongoDB settings connection string. And finally, now that we have the Mongo client, we can get the instance of the database object that we care about. So we will do return Mongo client get database. And then what's the name of our database? Well, the name of our database is going to be the one that we define for the service name. Service name is catalog. Our database will be just catalog. So service settings service name, and that's it. So with this section, we have defined a singleton object that represents an iMongo database that's going to be injected, as you remember, into items repository over here. Is going to be landing over here, iMongo database. So here's where we're constructing and registering it with the service container. And then one more thing that we need here is to also register the items repository dependency. So we're going to be doing services add singleton, and then we will use our new items repository interface, and then I'll import the play catalog service repositories namespace, and then the concrete type is going to be items repository. Right, so this registration is a bit different than the previous one, because in the previous one we're explicitly constructing our Mongo client and the Mongo database before registering it with the service container, while in this case we're just declaring which is the type that we want to register and which interface it implements, and the ASP.NET Core runtime will take care of constructing that instance whenever it is needed. So we should be ready to try this out, but what I'll do is I'll place a few breakpoints so we can see how things start lighting up as they do. So I'll put a free breakpoint. So I'll put one over here. Then I'll go to items repository and I'll put one in the constructor over here. And I'll also go to our items controller and I'll put another breakpoint here. And now I'll hit F5. Okay, so we can go to our Swagger UI page. I'll go /Swagger. And of course, we don't have anything in our database right now, but regardless, our service will need to construct all these dependencies to be able to figure out that there's actually no items right now. So I'll open up our get all items operation. I'll click on try it out, and then I'll click on execute. Now back in VS Code, and I'll collapse this a bit. We are now in our startup file. And notice that right away we are entering into the add singleton section here. This is because so there is one or more services that need these MongoDB objects. So if we inspect the value of MongoDB settings, we can see that we already have defined the host port, and the calculated connection string is right there. And that's what we are using to feed into the Mongo client connection string. We should also have a value for service name here. From service settings, has been read from configuration, and it's been used to get the database that we're going to be using. This database will be constructed the first time, and the next time it will be just reused. So I'll hit continue here. And now we are into items repository, which now is able to retrieve that instance of the iMongo database object that has been constructed, and it's been injected here. And it is via that one that is going to be able to retrieve the items collection that's going to be used across the items repository. Then I'll click continue. And now we are in the items controller, which is now able to receive that injected items repository that is going to also be used for all the operations. So I click continue. And we're back into play catalog service, the Swagger UI, which of course it says that there's no items right now, but we know we can easily go ahead and start creating items, updating items, and all these things with the Swagger UI. But yeah, so dependency injection is configured and the configuration system is enabled too. So we have reached the end of this model with a fully working, decoupled, and configurable microservice that is able to store and query for our catalog items in a MongoDB database. In the next module, we will introduce our second microservice, and we'll be learning about the multiple challenges of having microservices talk to each other. This module is an intermediate step to get ready to build our future microservices. We will learn about a few new tools that will help you as you start working with more microservices. And we will build a useful library that we will use in future models. Here's what you will achieve after finishing this module. You will learn how to use Postman as an alternative to Swagger UI to interact with your microservices. You will generalize the items repository so that it can be used with any future entity. You will create a NuGet package where you will place all common classes that you would like to reuse in future microservices. And finally, you will use Docker Compose to simplify how to run MongoDB and the multiple infrastructure services to be used in future models. Let's get started. In this lesson, we will learn about Postman, which is a popular API client that we will be using starting with this module. Postman will allow us to interact with our microservices REST APIs without having to open a browser to navigate to the Swagger UI page of each of the services. In addition, it will offer us a few additional capabilities that will prove useful across this course. The only additional tool required starting with this module is the Postman client, which you can get at this location. Let's get started. Let's go ahead and install Postman. I'll go to the Postman download page at postman.com/downloads. And here I'll just scroll down a little bit. I'll click on download the app. I'll pick my operating system, and that will start the download. In the same way, depending on your operating system, you can choose the Mac OS or Linux version. This should take just a few seconds. Okay, so it's downloaded. I'll click on the installer. And yeah, the way that the installer works for Postman is that it will just pop up this screen here. So it's already installing the application. It will take a few seconds, and then the Postman UI will just pop up in your screen. Yep. And here it is. And so at this point, you have the option to create an account with Postman if you want to keep track of your collection, settings, and a bunch of things that you may be interested in. But in our case, we really don't care about that at this point. So I'll just click that link at the bottom side here, skip signing in, and take me straight to the app. So I'll just click on that. And then we are in the Postman user interface. The first thing that I'll do here, just because I don't like this theme at all, so I'll just go to settings over here, settings, themes, and then I'll switch to the dark mode setting. Okay, so now that we have Postman available, let's go back to our catalog service in VS Code, and let's start querying for its several APIs. So I'll minimize this, I'll close this browser, and yeah, here we are in the catalog service. And then, yeah, I'll just do F5. All right, so as usual, the browser opens, but this time we're not going to be using the browser. We're going to go straight into Postman over here. And here, what you can do to start querying your REST API is if you have the Launchpad open, like me, you can click on Create a Request over here. Or if you don't have it open, you can click on this plus button to open a brand new tab. In this tab, what you want to do, the first thing you want to do is figure out which is the verb that you're going to use for your REST API. If you click on this dropdown, you're going to find a bunch of HTTP verbs for the different operations. So let's say that we want to start by doing a get. So I'll click on get, so that we want to get the list of items in our catalog API. So then you want to type here the URL of the REST API. And if you don't remember the host where you're running your web server, you can easily find that out by going back to Visual Studio Code. And here you can find that, that URL either right here in the debug log, where it says now listening on, is right here. Or you can also find it if I scroll down this a bit, and then you open properties, launch settings.json, is right here close to the bottom, where it says application URL is over here. So HTTPS localhost 5001. So I'm going to copy that and back into Postman. And so I'm going to paste that over here. And then what you want to do is add the route for our controller. So once again, back in Visual Studio Code, if you open controllers, items controller, you're going to find our route right here. So route is items. To copy that, back into Postman, and I'll say /items. And with that, you can just hit send, and that's going to query the REST API. Now, if you get an error, like the one that I'm getting down here, which says SSL error, unable to verify the first certificate, this is actually expected. It's a default verification for the certificate of your web server. Since we are using a self-signed certificate that comes bundled with ASP.NET Core, that's not really a friendly certificate for Postman, but it is okay to get past that verification because it's just a local web server for development purposes. So what I'll do is I'll just click on disable SSL verification. And that's going to go ahead, I'll just close this, that goes ahead and queries the REST API without issues. Of course, we don't have any items available in the database right now, so that's why we see an empty array over here. But we can actually try out to create a brand new item. And to do that, what I'll do is I'll click on the plus icon over here, which opens a new tab. And I'll switch from get into post. And once again, I'll paste our entire route here. So I'll copy from get, I'll paste it here in post. And then what we want to do is go to the body section over here. And we want to choose raw. And at the end of this section, I'll pick JSON. So I'll open up this. And here we can define the body that we want to send to this post request. So I'll open up a section, a JSON section here, and I'll start typing the elements for creating, in this case, an item. So if you remember, the elements are a name. So we need a name. And let's say we go back to our potion example. So I'll just say potion. Then we need a description. So description is going to be restores a small amount of HP. And finally, we'll set up a price, which is going to be, let's say, 5. Okay, so with that done, I'll do this. I'll go ahead and hit send. And as you can see, the item has been created. Okay, we have an ID. And if we wanted to, we can now go back to the get tab here, and we can query for items once again. So I'll click on send, and now we can get items. So just like this, you can keep going on and using the rest of our REST API operations by opening new tabs and opening and using the different verbs over here. However, each of these times you'll have to remember what to put exactly on both on the URL and, in the case of post, for instance, the body and the elements that you want to use for the payload to send in that body, right? So what if you don't remember exactly what to put in all of these cases? So what I'd like to do is just show you another way to do this to simplify a little bit this overall process. So what I'll do is I'll just right click here and I'll close all tabs. So actually I'll say cancel. Let me close this, don't save, close that. So one thing that you can do if we go back into our browser over here is we can go ahead and find the OpenAPI specification for our API. So if I go to /swagger, hit enter, we're back into our Swagger UI page, but this time we're not going to use any of these methods. What we're going to do is click on this, if you can see this swagger.json link over here. I'll click on it, and this opens the OpenAPI specification. So this describes the entire REST API in a standard way. So what I'll do is I'll copy this entire URL, and then I'll go back to Postman, and I'll go into the import button over here. I'll click the link section, and then I'll paste that URL over here. Click continue, and finally I'll just say import. And now if we go into the collection section over here, you're going to see that now we have a description of our play catalog service listed here with all the requests. So if I open this, and there's the items route, and if I open that, you can see that we have routes for get and for post, and also if we want to go by ID, we can go ahead and get an item by ID. We can do the put, which requires an ID, and we can do also the delete. So this time, if you wanted to get all items, what I can do is just click on get items, and then that's going to open a tab with an already filled in verb and URL to go ahead and request the items. However, you're going to notice one new thing here, which is the base URL. So the base URL represents really the root of where you're hosting your REST API at this point. So this is the localhost 5001 section. So Postman just doesn't know that information just yet. It just knows about the routes and the payloads. So to fill in this variable here, base URL, what you can do is go back to play catalog service over here, click on these three dots, click on edit, and then you go to the variable section here, and then you want to put a value for current value. So what I'll do is I'll just put HTTPS localhost 5001. Okay, I'll also put that in initial value. This is what somebody else that wanted to reuse your Postman collection would have as an initial value if they wanted to. So I'll just keep the same value for both of them. So then I'll just hit update. And now if we hover over base URL, you can see that now we have a result value being pop up there for our REST API. So now I can go ahead and hit send. And once again, I get my items. But more interestingly, if I wanted to do a post this time, I can click on post. And then again, the URL, the verb is filled, the URL is right there, and the body is already pre-populated with all the elements required for this API. Let's actually try to do a put. So I'll go ahead now into put. And again, the URL is pre-filled in there. And what we want to do is to, in this case, first we need the ID of the item, which we can get from the get items tab here. So I'll just copy that ID, back to put, and I can put the ID right there. And then in terms of the body, I can go to the body section, and like I said, it is pre-filled, so I just have to put the elements for this body. So I'll actually just copy those elements from here. Okay, and I'll do proper indentation. And so here's where we can go ahead and update something about this potion. So I'll just update the price again. So I'll say 7. And then we're going to click on send. And we got our response, 204 no content, meaning that it succeeded. And so now we can actually try, let me copy the ID of this item. We can try our get by ID API. And then again, the URL is pre-filled. I'll just paste the ID over here. I'll hit send. And there it is. We got our potion. So as you can see, it is pretty handy to just import the open API specification into Postman and be able to very quickly start working with your REST API in Postman. Now, a few other things that are available in Postman as opposed to our previous Swagger UI page is things like, for instance, of course, we have the concept of these collections, which in fact you can actually export if you wanted to and share this with somebody else in your team or some of your teammates. You can easily export this collection. And you will do that by clicking these 3 dots, and you can click on export, and there's going to be a few options for you to export this for somebody else. Then also you have this tab over here that says history. This will show you the history of all the previous invocations of your REST API. So if you wanted to go back to something that you did in the past with the specific payload that you did and URL, you can do that. So this is going to keep a long list of all the queries that you made to your REST API across your different sessions. There's also this concept of environments over here, which you can use to define the different environments where you want to invoke your REST API. So if eventually you're not just running in your localhost machine, but perhaps you have deployed this to some cloud environment, you can define variables over there so that you don't have, so that for instance, the base URL automatically changes as you change the environment that you're specifying over here. That way you don't have to keep opening more and more tabs for the different environments. There's also the ability to specify authorization options over here for the different authorization types, so that you can, for instance, generate and use authorization tokens to call your REST API if your REST API is enabled for that. That's actually something that we will look at in a future model. Okay, so now that we have done that, one more thing that we want to do is to, since we are now going to be using Postman, we don't really want to be opening browsers all the time. So how can we prevent the browser from keep opening every single time? So I'll just go back to the browser and I'll just close this. And then I'll go back to Visual Studio Code. And well, I'll stop and close this. What you can do is you go back to, we go to Explorer, and we're going to go to .vs Code, launch.json, and you want to look for this section that says server ready action. So this section here is the one that Visual Studio Code uses to define if they wanted to open a browser after something happens with the web server. In this case, it's just looking for the message that says now listening on. So when it finds that, it knows that it needs to open the browser. So in our case, we don't want to open browsers anymore. We'll find with Postman. So we're just going to remove this section. Delete. And now if I do F5, okay, no browser is going to open. We just stay here. But as always, you can just go to Postman and start querying the API like we already did. Okay, so that's it for this lesson. And in the next lesson, we will start extracting a few of the classes that we are using in Catalog Microservice into some shared components that we can use in our future microservices. In this lesson, we will learn about the need to reuse common code across microservices and how the NuGet package manager can be used to package and share code across services in a straightforward way. One of the things that you will likely realize as you start building more than one microservice is how much code starts getting repeated between each service implementation. For instance, our catalog microservice currently has a repository implementation for querying and storing data in its MongoDB database. It also has a couple of settings classes to more easily use the different service configurations that are stored in our app settings.json file. Eventually, we will also add classes to interact with our service broker, code to add instrumentation to the services, and likely some more code that is not directly related to the purpose of the microservice. The problem with this is that as soon as we bring in our second microservice, the inventory service, we would likely need to copy to it that same code with very little modifications. This is time consuming and goes against the don't repeat yourself principle, which states that every piece of knowledge must have a single, unambiguous, authoritative representation within a system, which in our case means that our common code should live and be maintained in a single place. Therefore, we could be tempted to keep our common code in one of our microservices and have all the other services simply reference that project to get access to the common code. However, this is not a good idea, because microservices should be independent of each other to ensure each of them can evolve quickly and have no ties to the internal implementation of others. We can solve this problem by introducing a new library project that we will call the common library, and then we can extract all the common code into it. The common library becomes the single place where we have all the code that is not specific to any microservice, and therefore is the single place where we will perform any updates to it when needed. But then, how can we make the code in this new common library available to our microservices? We could have our microservices add a direct reference to the library project file. But that's not a good idea, because as new members join our team, each of them might want to work on one microservice or the other, or even in the common library, and therefore they will only grab the code base for the project they are interested in, but not the code bases of all projects all the time. Plus, eventually, each microservice and the common library should get their own independent source control repository where they can be tracked and built independently. So, if the microservice projects can access the common project directly, what can they do? Here is where we can use NuGet, which is the package manager for .NET. With NuGet, we can execute a simple command like .NET pack to bundle all the output files from the common project into a NuGet package. A NuGet package is nothing more than a zip file with a NuPKG extension that contains all the files that are to be shared with other projects. Now, each of our microservices can reference the NuGet package to get access to everything that the common library has to offer. And the good thing is that microservice projects don't need to know where these NuGet packages are hosted. We will initially place the package in our local machine, but eventually you will likely want to host them in a cloud-based location, either accessible just by your team or by anybody on the web. The important thing is that regardless of the location, you won't have to change how the microservices access the common code. With our new common NuGet package, our common code is now maintained in a single place, and the time to build new microservices is significantly reduced. In the next lesson, we will extract our current common code into a new common library, and we will produce our first NuGet package that the catalog microservice and every future service will be able to reference to get quick access to the common code. If we take a look at our items repository class over at repositories, items repository, we will notice that there's a lot of code here that we will need to reuse in future microservices. And the same goes for our settings classes over in the settings directory, MongoDB settings, service settings. We can certainly reuse these in future microservices. But before we can move anything to a new shared library, we will need to do some good refactoring to keep the generic pieces separated from what's really needed in the catalog microservice. So let's start by looking at our items repository. And if we take a closer look at what's going on here, there's one piece that's really repeated a lot across this class, and that is the use of the item entity. The item entity is being used in several cases, like for instance in getAllAsync is being used to return the items that are going to be queried. And we are also filtering by the ID of this item in both in getAsync method and also in the updateAsync method. We'll filter in by ID and also in the removeAsync method. So we need to find a way to generalize the use of this entity so that it can be used in, like I said, in a more general way in this repository. So let's actually go to the item entity. So right click, go to definition. What we're going to do here is to actually extract an interface out of this item class to narrow down the pieces that we really need to generalize about the item. So what we're going to do is just click on the light bulb and say extract interface. And now we have the item interface here that our item class is implementing. However, we don't want to call this interface item. We actually want to call it iEntity. And this iEntity is what our item class is going to implement. But also, we don't want to have all these properties in the interface, but only the ID. Having the ID will be good enough to be used in the repository class that we're going to implement. Now, we also want to move this interface into a different file. So I'm going to click on the light bulb, and I'm going to move the type to iEntity.cs. Okay, so now we have the item entity that implements iEntity that is in the iEntity.cs file over here. Now what we're going to do is before going back to the items repository, let's go to the items repository class and see how we can generalize this. So to start with, we don't want this class to be about just items anymore, but about a generic type. And the way that we can do this is by renaming this interface into, instead of iTems repository, it's going to be iRepository. And it is going to be of a generic type that we're going to just name T, where T represents the actual entity that's going to be used in a specific microservice. So this T, we'll add a constraint here, where T has to be and iEntity, the interface that we just defined. So whatever we use for T, it has to be a class that implements the iEntity interface. So now that we have that generalization, we can say that all of our methods actually use this T type. So for instance, instead of having item here, we're going to name it as T. And the same way we're going to do for the item that's going to be returned in getAllAsync, the item that's returned in getAsync, and also the item, the entity that's received in updateAsync. Okay, so with that, there's no longer a mention of the item type anywhere in this interface. So with that done, we can now go back to our items repository and also generalize it to represent a more generic repository. So instead of being an items repository, this is now going to be a Mongo repository that is going to be of some type. So again, we're going to use type T to represent the actual entity that's going to be managed by this repository. And also, our repository class now needs to implement the iRepository of T interface. Again, where T is an iEntity. Okay, so let's also rename the constructor to be Mongo repository. And let's start changing this so that it actually, to start removing everything related to item from this class. So one of the things that we have to get rid of is this constant that is the collection name, items. Since this is not going to be just about items anymore, let's remove it. And what I'm going to do is just copy collection name, just the name of the constant, and remove it. And now we are going to receive that collection name as a parameter in the constructor. So we're going to receive string collection name. So that's a collection name that's going to be used when we try to retrieve a collection from MongoDB from here on. Okay, and so now we need to start moving forward and start generalizing things. So let me just get a copy of T. And so anywhere where we find item, we want to replace it with T. So this is a DB collection of T, filter builder of T, builders of T that filter. And we get a collection of a T entity. When we do getAllAsync, we have to do T again. And again, when we do the filtering, so getAsync of T over here is all generic. Also createAsync should be T. UpdateAsync should be also T. Filter definition of T. And notice that since our interface has the ID property, it doesn't really care that it doesn't know what's a real item, as long as that the real entity, as long as that entity implements iEntity, it is able. We know that there's going to be an ID property, a GUID ID property that we can filter by. And finally, let's change our remove async to also deal with just with T. right? So just to confirm, let's make sure we don't have item anywhere in this file anymore. Yep, there's no more item here. So let's also rename the file, by the way. So this should be Mongo repository, and this other file here should be iRepository. And with that done, it is time to start fixing all the references to our repositories. So let's start by going to our controllers class, items controller, and let's fix things, right? So this is no longer an iItems repository, it's just an iRepository of type item. And that is what we are going to be receiving in the items controller, in the constructor here. Okay. Next thing that we need to do is to fix the way that we are registering the repository in startup. So let's open up startup. And let's see how we are registering the repository over here. So this is what we're doing today at singleton, item repository, item repository. So we will switch to a more concrete way of defining this singleton, because now we need to specify a parameter as an input to the repository. So remember, in Mongo repository, now we are receiving a collection name. So we cannot just expect all parameters to be injected automatically by the service container for us. So we need to be more explicit. So let's update the repository registration. To start with, we are no longer using the iItems repository interface. We are using iRepository of type item. And let's see if we're missing something. So let's add the service entities namespace. So it's an iRepository of item. We will not be specifying an actual class as a second parameter here. And then we have to specify the service provider. Service provider, just like we did in the other at singleton call. Open braces here. And now, before we can create the instance of the Mongo repository, first we need an instance of the iMongo database. Because remember, we actually registered an iMongo database in the previous at singleton call. So how can we get an instance of such a registered service? So that's where you can use the getService method of the service provider. So just like this. So var database equals service provider that getService iMongo database. Okay, so anytime that you need to get an instance of a service already registered in the service container, like we did with iMongo database, you just need to call getService on service provider, and this will work as long as that service has been registered before the call that you're going to make here. And then, having that iMongo database instance, we can now return our new Mongo repository of type item. And then we need to provide two parameters. The first one, the database, the one that we just got, and then the collection name that so far is been just items. Okay, so that should do it. Let's make sure everything is building successfully. So I'll do Ctrl+Shift+B. And indeed, everything is building just fine. So at this point, we have generalized our repository class so that it can be used with any type of entity. However, it feels like we're writing too much code on startup to register the MongoDB related classes, because look at this. We have to do register serializers. We have to do the singleton registration for the Mongo client, for the Mongo database, and then the other singleton for the repository. So in the next lesson, we will introduce a couple of hand extension methods that will simplify things quite a bit for this and for future microservices. So let's take a quick look at everything that we have to do in order to use our Mongo repository so far. So here I am in the startup class, and the first thing that we have to do is register the bson serializers in order to change the way that we store GUIDs and datetimes. Then we have to get the MongoDB settings, the MongoDB settings section from app settings.json in order to construct our Mongo client. And then we can create our iMongo database that we registered as another singleton. And then finally, when we have that, we are able to retrieve that iMongo database and then construct our Mongo repository for the items collection. So let's see how can we simplify all these lines to make the life of future microservices much easier. What I'm going to do is create a new extensions class inside the repositories directory. So I'm just going to right click here. I'm going to create extensions.cs. not to be confused with the other extensions that we have over here. This is a new class. Let's give it a namespace. Play catalog service repositories. So let's name this class public static class extensions. And let's declare a function here. So it's going to be public static iService collection, because we're going to be extending iService collection here. And let's name it @Mongo. And it's going to receive, or it's going to extend the iService collection object. Okay, so it receives iService collection and it will return an iService collection. Let's see if we're missing a namespace. So let's add the dependency injection namespace there. And here, let's go ahead and grab a few lines from startup. So let's grab these lines over here. And let's go ahead and add missing namespaces. So I'll do bison serialization. I'll do serialization serializers, and then MongoDB bison. Okay. And then we will need service settings, but we will not receive them here. We will get them over here as a var service settings. But one thing that you can notice is that we don't have an instance of configuration here, just like we had in startup, where it was a property that we received as part of the constructor. So what we can do is use a service provider to explicitly request an instance of a service that has a variable register. So configuration is registered already by ASP.NET Core infrastructure, so we should be able to request it at this point. What I'm going to do is just say var configuration is service provider dot get service, and the type of service is going to be just iConfiguration, okay, which needs the extensions configuration namespace. So now we can flip this configuration into just configuration with small caps C. And then we are also missing another namespace here, which is a service settings namespace. Okay, so we get the configuration, we retrieve service settings, MongoDB settings, we construct the Mongo client. Let's add the missing namespace here too. And that allows us to return the iMongo database. Finally, we're going to return the services collection just to enable the fluent use of this extension method. So that will register the iMongo database instance. And now let's add another method to register the repository itself. So I'll open up another method here. Let's call it public static iService collections, going to return @Mongo repository. It's going to be the name. And then we'll specify a constraint of T for the actual entity type that's going to be used. And then it's going to extend iService collection. The name is going to be services. And then remember, we have to specify a collection name in order to create a repository. So let's receive collection name as a parameter. We also need to specify a constraint for that for that T parameter. So T, the T type that's going to be used, has to be a type that implements iEntity. Okay, so we may need another namespace. Let's first expand this. Save it. Let's send this to the other line. And let's add the service entities namespace. Okay, so this will be useful to register a repository with any type of entity, but that entity has to implement the iEntity interface. So now what we can do is go back to startup and grab these few lines for the iRepository registration. We'll copy that here. And then to make it generic, we're no longer going to be using item here, but just T. And then this also registers as T. And we no longer hard code the collection name. We're going to be using the collection name parameter. And finally, to keep it fluent, we return services once again. So with that, we should be ready to start using this extension method. So let's go back to startup. Okay, so we're going to go ahead and remove this serializer registration. Let's keep service settings for now in case we need it later, but we definitely don't need any of this stuff. So now what we can do is just say services at Mongo that registers our Mongo client and the iMongo database. And then since this is fluent, we can say at Mongo repository. We need to specify a type. In our case, type is item. And then we provide the name of the collection, which is still items. So with that done, let's just make sure things are keep working properly. So I'm going to hit F5 to start a web server. And I'm going to go into Postman. And I'll do, again, our simple get all items request. I'll hit send. And yeah, it keeps working just fine. But as you can see, the code in startup is way simplified. In the next lesson, we will see how to move all of these common classes into a new shared library that can be used by all of our microservices. It's time to move the common code we refactored from our catalog microservice to a new shared class library that can be used by both catalog and any future microservice. So to start with, I have opened a new Visual Studio Code instance. I have opened my terminal and I am in the D projects directory. So here's where I'm going to create a new directory. Let's call it play.common. And now I'm going to open that directory in Visual Studio Code. Right. Now, as usual, I'm going to create a new sources directory, src. And here's where I'm going to open a new terminal. To create a class library, not a web API project, but just a class library as we need, what we can do is use .NET CLI by doing .NET new classlib, and then we will give the name of play.common. So that generates the files that we can see on the left. And then the first thing that I'd like to do is to generate the files that Visual Studio Code needs to build our project. But before we can do that, we have to make sure that the OmniSharp server is running. The OmniSharp server is the component of the C# extension for Visual Studio Code that takes care of a bunch of productivity improvements in Visual Studio Code, like the generation of these files. So what I'll do is, just to kick off the OmniSharp server, I'll just click on class1.cs. And as you can see on the bottom here, OmniSharp server is starting already. And so with that, I can now go to View, Command Palette, that then generate assets for build and debug. So that will go ahead and generates our .vs code folder with the dash.json file inside it. And now that we have it, I'll click on it, and I'll go to this section to make the build action, the default action for building our project. So I'll just add our group folder, just like we did with the catalog microservice. I'll select build is default true and save. Okay, so with that, I'll go ahead and close this. And I'll delete this class1 file, we don't need it. And now it's time to add a few NuGet packages that our shared libraries or shared classes are going to need. So first I'm going to switch to play.common. Here I'm going to start adding a bunch of packages. So I'll do .NET add package, mongodb.driver. Okay, so that's for MongoDB. Now we need a couple of packages for the configuration related classes. So .NET add package, Microsoft extensions, configuration. Okay, we'll do that one, and configuration.binder. And lastly, we have to add the extensions.dependency injection and NuGet package, which is going to be used for everything related to the service container that we're going to be using for dependency injection in this library. With that done, let's go ahead and start creating folders to bring in our files. So the first folder I'm going to create, right click in play.common, new folder. The folder is going to be settings. And here's where we're going to place the settings files that we have in catalog. So I'm going to go back to catalog folder, the catalog directory, right here. And I will open settings, and I'm going to copy these two files, MongoDB settings, settings, copy. And back in common, I'm going to paste those files here. And I'm going to close the terminal for now. And now that we have them here, let's fix the namespace so that it matches our current project. So this is going to be play.common.settings. So both for MongoDB settings and for service settings. Okay, with those files done, let's go back to catalog and let's bring in our identity interface. I'll copy that. I'm going to place it just at the root of play.common. Identity. And let's also bring our iRepository interface. iRepository, copy, into play.common at the root. Okay, so these two should have also the namespaces fixed. So they're just going to be in play.common. So play.common, that one, and play.common on this one. Let's also get rid of any unneeded namespaces like this one here. Get rid of that one, and we're good. Now I'm going to add a new folder for our MongoDB related classes. So I'm going to create a new folder here in play.common called MongoDB. And in this folder, we're going to add, let's go back to catalog. We're going to add the extensions file and the Mongo repository file. Copy those ones, back in common, MongoDB, paste. So for these ones, the namespace is going to be play.common.mongodb. And on this one, again, play.common.mongodb. I'll also remove any unneeded namespaces from here and from here. And in the case of extensions, we also need to tell it the new namespace for the settings files. So I'll go to service settings, control dot, and I'll use play.common.settings. Okay, so now we have all of these common classes in our new common project, and that should be good to start building our NuGet package. But since we are here, let's actually take advantage of the opportunity to expand a little bit our Mongo repository class with a couple of new functions that our future microservices are going to be using for querying entities based on a filter. So let's go ahead and go to our iRepository interface. So let's start here. And what we're going to do is add a couple of new functions similar to our overloads to get all async and get async, but that are going to be able to receive an expression as a filter to filter which entities are going to be returned. So let's start by get all async. I'm just going to copy this function. I'll add a new one here. And the way that we're going to specify the filter is going to be via an expression, a link expression. So it's going to be an expression. Let's add a missing namespace, link expressions. And the signature we're going to use is the one that MongoDB is expecting from us. So it's going to be a func of type T, so whichever type is the entity, and bool filter. Okay, so again, so this is the way to specify a filter so that eventually when we want to retrieve entities based on some features, let's say, give me all the items that are owned by a specific user, in the case of inventory, we will be able to use such a filter here. So you can pass a query expression here, and then MongoDB will be able to handle that filter and return the correct items for us. The same way that we did that, let's go ahead and do get async, another overload that is also going to receive expression. So in this case, you don't need to specify just an ID to get one item or one entity, but you can specify a filter to retrieve any entity that matches that filter. Yeah, and when we get to our new microservice, our embedded microservice, we'll see how both of these functions can be used. So now that we have that in the interface, let's now go to Mongo repository and actually implement these new methods. So I'll go ahead, I'll click on iRepository, control dot, implement interface. So that brings in our new methods at the bottom. I'm just going to relocate them next to their other overloads just to keep them close to each other. So I'll put that there. I'll grab get async. and I'll put it next to our other getAsync overload. There. And really this is very straightforward. So what I'll do is I'll copy the last line of our other other getAllAsync method. I'll put here, this line, and I'll copy it to our new getAllAsync overload. And really the only thing that we have to do is pass the filter there. Because let's see, if you go to find, you're going to see that it can receive a filter definition, but in another overload, it can receive an expression of the type that we have defined. So that's the overload that we're going to be using from MongoDB to be able to filter. So I'm just going to pass the filter here, and I'm going to make this method also async. That will be enough to retrieve all the items based on a filter. And for the other overload, the getAsync, again, I'll copy the code from the other overload over here, and here the filter is already there, so it's ready to receive the filter. But let's make it async, and that will do it. So we can retrieve one entity based on specified filter. And like I said, these methods are going to be very handy as we move to the future microservices. So with that done, let's go ahead and build everything, make sure everything is built in correctly. So I'll do Ctrl+Shift+B. Okay, so everything builds just fine. And what I'll do now is I'll switch to my PowerShell terminal so that we can create this NuGet package. And how do you create a NuGet package? Very straightforward. You just use .NET CLI with the .NET pack operation. So we will do .NET pack, and then you have to specify the output directory with -o. And then given my current file structure, what I'd like to do is to place the package in a packages directory under the D projects folder. So what I'll do is -o // I'll go up 3 directories, and then I'll specify packages / and that should be enough. Hit enter, and that's it. The NuGet package has been created under the packages, and we can confirm that by going to here. We have a packages directory now, and if I go to packages, the package is right there. So this package contains everything compiled out of our play.common library. So now it's time to go back to catalog and start using this new NuGet package. So I'll switch to catalog. Here we are. And before we can get a reference to that, to our play.common NuGet package from catalog, there are two things that we have to do. The first one is to specify a NuGet package source for our current NuGet installation. So remember that NuGet packages can live in multiple locations. They could live somewhere in your intranet. They could live somewhere in the cloud, in a public location like NuGet.org, or in a private feed library, or they could live in your local machine, as it is our case. But NuGet doesn't know about that. So you have to tell your NuGet installation which are the possible package sources where it can find the NuGet packages. So we're going to tell it right now that our NuGet packages are in our D project package location. So to do that, I'll open our terminal right here. And what I'll do is I'll use again .NET CLI with the .NET NuGet command, .NET NuGet add source, and here I have to specify the location of my packages. So in my case, that's going to be the projects packages, and then I'll give it a name -n just to have for easier of reference. I'll name it Play Economy. Okay, so it's been added successfully, and just make sure that you update this location depending on where you send your packages in the previous step. The next thing that I'd like to do, and I'll collapse this a bit, is to go to our Play Catalog Service CS prog. And what I'm doing is I'll actually remove this MongoDB driver reference, because now everything MongoDB is actually being referenced and brought in via the NuGet package. So we will not need to have an explicit reference to MongoDB driver here. So I'll just remove that. And now save this project. And now we can go ahead and add our play.common reference. So to do that, let me switch to SRC. Let's go to play.catalog service. And then we can do .NET add package play.common. Enter. And the reference has been added, as you can see right here. So with that, it is time to start cleaning up things. So I'll go ahead and close my terminal, and I'll close this. And a bunch of things that we can remove now are the identity interface. We can remove. Our entire repositories directory can be removed. And our settings directory can also be removed. Okay, so now it's time to fix our imports. So let's go to item.cs and make sure it can find that identity now lives under play.common from NuGet package. In our controller, also the iRepository interface now is coming from play.common, and we'll remove this old namespace. And finally, in startup, let's get rid of these old namespaces. Exactly clean up the entire thing. Remove all necessary usings. And service settings is now going to be coming from play.common.settings. Also, our @mongo extension method is also coming now from play.common.mongodb. And that's all it is. So we are now completely using our NuGet package. I'll make sure everything is building via Ctrl+Shift+P. Yep, it's building just fine. And now let's test if the service is running properly. So I'll do F5 to run our service. And I'll go to Postman. And I'll just go ahead and do a simple query for all the items in the database via our items operation in the REST API. I'll hit send. And here we are. We are retrieving items from the database. So everything is working properly. So it works just as before. But now, as you can see, and I'll just stop this. Our code base is much simpler. So we don't have the entities interface here. We don't have the repositories folder. We don't have the settings folder anymore. And yeah, our startup looks very clean. And so this is going to help us a lot for the construction of our future microservices. In the next lesson, we will learn about Docker Compose and how it can help us simplify the way we configure and start our infrastructure services. In this lesson, we will learn about Docker Compose and how it can help us simplify the way we run our infrastructure services. We already started using Docker to run our MongoDB database, and we are doing this via a simple docker run command. However, starting with the next model, we will need to start bringing in many other infrastructure services to support our microservices. For instance, in the next model, we will use RabbitMQ as our message broker. And in future models, we will use Sec, Prometheus, and Grafana to enable a series of observability-related components. So, if we keep just using Docker run to execute our infrastructure services, we will have to perform too many steps to set up them, and we will need to remember too many arguments for each of them, like the right environment variables, ports, and volumes. Also, some of our containers might need to talk to each other, like Grafana and Prometheus, and some of them might not be able to work at all without another container be up and running first, which again is the case of Grafana, which won't be able to do much without Prometheus being available first. That's where Docker Compose comes into play. Compose is a tool for defining and running multi-container Docker applications. We will now be able to define all of our infrastructure services in a single file called the Docker Compose YAML file. This will include the definition of the container to use in each case, environment variables, ports, and even dependencies between them. Then, we will execute a single Docker Compose up command, and all the containers will start in the right order with the correct configurations. Also, Compose provides a default network that all containers are joined to in case they need to talk to each other. So, with Docker Compose, we are able to document the way to configure all of our infrastructure services in a single file, and we get to start all of them with just one line, as opposed to multiple commands. Also, they all join a default network. In the next lesson, we will create our Docker Compose file and move our current MongoDB configuration over there. Before we start using Docker Compose, let's first create a new directory where we can place the Compose YAML file and any future infrastructure-related files. So here I am in a new Visual Studio Code instance. I have opened my terminal and I am switched into the projects directory. So in this directory, I'm going to create a new folder. I'm going to call it play.infra. And now I'm going to open it in Visual Studio Code. And the first thing that I'd like to do here is to take advantage of the another extension for Visual Studio Code, which is the Docker extension, which we can find if we go to extensions. Let's just type Docker. It's this one here, because this one is going to provide us some good recommendations as we start working in our Docker Compose file. So I'm going to install this extension, click install, and that will show up a new icon on the left side, Docker. So let's close this and let's go back to our Explorer. Now what we can do is just go back here and let's create a new file. Let's call it docker compose.yaml. And before writing any code here, what I'd like to do is to bring in that previous docker run command line that we've been using, just to keep it as a reference as we start writing this docker compose file. Okay, so remember this line that I just pasted. This is what we've been using so far to kick off our Mongo container. So the first thing that we want to do in this Docker Compose file is to define a version for it. The version determines what features you're going to have available in Docker Compose, because different versions of the Docker Compose engine support different versions. So you have to define what version is this file for. So I'll say version. It's going to be 3.8 is the latest one available as I'm recording this lesson. And the next section is what we call services. The services will determine, each of these services is really one of our Docker containers. So I'll define a services section. And under services, you want to define our first service, which is, in our case, is going to be MongoDB. So I'll just name it Mongo. And as I start writing this, notice the indentation that I'm setting between each of these elements. Indentation is important because it defines which elements go inside other elements. But to make this more easier to see for you, what I'll do is I'll enable another setting in Visual Studio Code so we can see the white spaces that are happening across the place. So I'll go to File, Preferences, Settings, and I'll look for render white space. Yeah, so it's this one here. So I'll switch from selection into all. Then I'll close this. And now we can see the white space right there. Yeah, so as you work on this file, just make sure that you're leaving the same amount of white spaces or indentation with the different elements that we're going to write. I will also collapse this left side, the navigation pane, since we don't need it for now, so we can have more space. So inside the Mongo element, we're going to open yet another element. We have to define the properties for this service. So first thing we're going to define is the image. And as you remember from the command line on the top, the image is Mongo. So I'll grab that. Then we have to give a name to this container. So the container is going to start up. So I'll say container name, and the name that we've been giving over here is Mongo. So let's use the same name. It's going to be Mongo. The next thing is the ports. So ports is actually an array of ports. So the array you can define by placing a dash first, and then you specify the port mapping. So I'll grab that port mapping from here. As you remember, port is 27017, external port on the left side, internal port on the right side. And the next thing that we have to define is a section for our volumes, because remember that we need to map the /data/db directory inside the MongoDB container into a location outside of the host where the files are actually going to be written. That's what we call a volume. So to define volumes, I'm going to go all the way here at the same level as our services section over there. Here we're going to declare a section called volumes. And under volumes, I'm going to define our MongoDB data section, which I'm actually going to copy over here. MongoDB data, column. And that's really all you have to do to define one volume in your machine. And now we have to associate that volume to our Mongo service over there. So I'm going to open yet another section here called volumes under ports. And under volumes, you have to define an array of all the volumes that you want for this service. So an array starts with dash, and then you define that volume mapping. So I'm going to copy this again, there. So that defines so /data/db is mapped into MongoDB data. Remember that we have to do this because otherwise our database files will be lost if we restart the container. So from here on, anytime that the MongoDB container tries to write to /data/db, those files are actually going to be written into the MongoDB data volume that's outside of the container and into our host machine. Okay, so now I'll save this file. And it's time to start running this container via Docker Compose. So I'll open my terminal, Ctrl-J. And the first thing I'd like to do here is make sure that I am not running MongoDB container already. So let's see, Docker PS. Docker PS. And so we are indeed running it already. We don't want to have it running there because that could cause conflicts. So I'll just go ahead and stop it. Docker stop Mongo. Okay, and now it has been stopped. So with that done, we can go ahead and start our Docker container via Docker Compose, and we can do Docker Compose up, hit enter, and then that starts running the container. And what you're seeing now is just the output of the MongoDB container being generated directly into the terminal. So now that we have a Docker Compose running our MongoDB Docker container, let's see how is our catalog API working with this new way of running the container. So I'm going to go back to our catalog microservice, and I'm just going to hit F5 to get things started. Okay, with the host up and running, let's go ahead and open Postman, and let's go ahead and try to get all of items in the database. So here I am in my get operation for the REST API. So I'll hit send. And interestingly, I'm not getting any items, which is interesting because as per our previous lessons, we did have at least one item already stored in the database. So what's going on? Let's see, let's go back quickly to Visual Studio Code, catalog, and let's explore our database at this point in time. So I'll collapse this a little bit, and let's go to the MongoDB extension, and here's our localhost 27017. I'll connect to it, and the interesting piece here, and I'll collapse these other pieces, is that we don't have a catalog database anymore. And this is happening because as we moved into Docker Compose, a new volume has been created for our database files. So technically, this is a brand new database, which has no items yet, right? So there's actually nothing in there, so there has not been any need to create a database yet. So that's why you don't see any database here. So just keep that in mind as you switch from a raw Docker execution into Docker Compose, a new volume will be created. So let's actually come up with something for our catalog database. So I'll go back to Postman, and I'll go to my Post tab, body. Okay, and so let's again define something here. We'll go again to our potion example. So it's a potion, and it stores a small amount of HP, and the price is going to be just 5. So go ahead and send this, and the item has been created. So if we go back to our get items API once again, hit send, the item is there. And if we go back to Visual Studio Code to catalog and we refresh this, you can see that now we have our catalog database with our items collection and the one document already created in there. And one last tip that I want to give you as you start working with Docker Compose is how to prevent, let me actually open Docker Compose, how to prevent all this output to be shown here. So in case that you don't want to see all this output from the database all the time, you can see things in a much cleaner way by doing the following. So I'll go back here to my terminal, I'll just hit Ctrl-C to stop Docker Compose. And what you can do is, you can do Docker Compose up, but you can append the -d parameter to run in detached mode. So if I do enter now, the only thing that you're going to see is that it's starting Mongo, and then it says done. So the container is running in the background, but you don't have to be looking at all the output all the time. So it's running in a detached mode. And still, if you go back to Postman and you query, you can see that the container is actually running. So we have reached the end of this module with a few improvements to our developer workflow and with a reusable library that will speed up the construction of our future microservices. In the next module, we will introduce our second microservice and we will learn about the multiple challenges of having microservices talk to each other. In this module, you will learn about the different microservice communication styles, and then you will learn about a few techniques to properly implement synchronous inter-service communication between the existing catalog service and a new inventory service. By the end of this module, you will have a solid understanding of the following: the different microservice communication styles, how to implement synchronous communication between two services via REST and the HTTP protocol, what kind of partial failures could impact your microservices and why you should design for them, how to set timeouts to fail fast when doing inter-service communication, what is and how to implement the retries with exponential backoff technique, and when to use and how to implement the circuit breaker pattern. In this lesson, we will create our inventory microservice, which owns the player's inventory of purchased items. Just like we did with the catalog service, we will define a REST API for inventory with a couple of operations, which are post items, which will be used to add an item to the player's inventory bag, and get items by user ID, which should retrieve all the items for the specified player or user. Talking about users, you may have noticed that we have not properly introduced the concept of players or in general users into our system. This is fine. The management of the actual users database will be the responsibility of the identity service, which we will create in a future module, along with all the microservices security infrastructure. For now, we will use random GUIDs to identify the users that own the inventory items. Let's get started. Let's create our inventory microservice. I have started by opening a new Visual Studio Code instance. I have opened my terminal and I have switched to the projects directory. So I'll create a brand new directory for this new microservice. So let's call it play.inventory. And then let's switch to that directory in the terminal. And then what I'll do is I'll use this command line to ask the current instance of Visual Studio Code to open this new folder. So I'll just do code dat for the current directory, and then I'll do -r to reuse the current window. So I'll hit enter. That will be the equivalent to use the file open folder menu, but it's much faster. Now I'll create, as usual, our source directory. And in that one, I'll right click. I'll say open integrated terminal to open a new terminal in that location. And then I'll go ahead and use .NET CLI to create the new project. So .NET new web API -n play.inventory.service is going to be the name. Okay, so that generates a bunch of files on the left side, and I'll get the OmniShard server started by clicking on any of our C# files. So click there, that kicks in OmniShard server, and that prompts us to add the task.json and launch.json files so that Visual Studio Code can build and debug our project. So I'll say yes. That adds our files on the left side over here, and then I'll go right away to our task.json file to add our group section, where we can say that this is the section that by default builds the project. I'll save that. Okay, so now I'll also close our terminal for now, and then I'll go to launch.json, and I will remove this section just like we did with catalog, so that anytime we start the server, it doesn't open up web browser by default. So I'll just remove that. And what I'll do next is I'll go to under properties, I'll go to launch settings.json, because we want to specify which is going to be the ports that we're going to use for inventory. So remember, we are already using the default ports for catalog, 5001, 5000, and 5000. So we have to use new ports for inventory. They cannot be the same port. So I'll go for 5005 and 5004, for our HTTPS and HTTP port for inventory. You could use any other port really here, as long as they are not being used by any other application in your computer. Next, I'll go ahead and I'll delete what we don't need from this project. So I'll delete weather forecast controller, and I'll delete the weather forecast class over here. So now I'll get started by creating our DTOs. So the DTOs that are going to be used by our controller class and our REST API. So just like we did before, I'll right click in Play Inventory Service. I'll say new file. I'll create DTOs.cs. Here I'll declare our namespace. The namespace is going to be play.inventory.service.dtos. And so we're going to define two DTOs at this point. The first one is going to be the DTO used to grant items to a user. And the other one is going to be the DTO used to return the series of items that a user already has in their inventory. So let's start by defining public record grant items DTO. And to grant an item to a user, we obviously need to specify the ID of the user. So it's going to be a GUID user ID. Let's add the system namespace there. We also have to specify which is the item, the catalog item that's going to be assigned. So we will define that as catalog item ID. And lastly, we have to specify how much of the item is going to be assigned to the user. So that's going to be the quantity. Let's now define the other DTO as public record. This is going to be inventory item DTO. Like I said, this is the DTO used to return items, the items that are assigned to a user in the user's inventory. So for this, we're going to be returning the catalog item ID, the quantity, and also let's define the acquired date. So this is the date when the item was put into the user's inventory. So now that we have our DTOs, it is time to start defining the entities that we're going to be using to store the inventory items into the database. However, before we can do that, we have to bring in our play.com NuGet package so that we can start using the bunch of classes and types that we have defined there, including our iItems, our iEntity interface. So to do that, I'll go ahead and do Ctrl-J to open my terminal. And I'll go to play.inventory service. And then I'll just do .NET add package play.common. Okay. So if we go now to Play Inventory Service, we'll see that we have the NuGet package added here. Now we can go ahead and right click in Play Inventory Service, new folder, entities. And let's go ahead and define a new file. It's going to be inventory item.cs. Let's define our namespace. It's going to be play.inventory service entities. Let's define the class, public class inventory item. And let's make this class right away implement our iEntity interface. Let's make it use play.common namespace. And as we're implementing that interface, let's do Ctrl dot implement interface. So we have to define a GUID. So public GUID ID. We'll make it define just a get. It will use a get and set, just like that. Okay, so each inventory item will have an ID. Then it should know to which user it belongs to. So let's do prop GUID. It's going to be user ID. Next, let's define which catalog item this inventory item corresponds to, a reference to the catalog item. So it's going to be prop GUID catalog item ID. Next, we'll define the quantity. It's going to be the quantity, how much of this item we have. Let me also close this terminal now. And lastly, let's define datetime of set is going to be the acquired date. the date when the item was assigned to the user in the inventory. Save that. And just like we did with catalog, let's define an extension method so that we can transform one of these inventory items into the inventory item DTO. So I'll go ahead to the root, play inventory service, I'll add a new file, I'll call it extensions. Let's add a namespace, play that inventory, that service, and let's add public static class extensions. And let's define our method here. So public static is going to return an inventory item DTO. Let's call it as DTO, and let's import the missing namespace. And it is going to be extending inventory item. It's inventory item. Let's import that. It's going to be the item. And here it is just about creating a brand new item DTO out of this item. So we will say return new inventory item DTO with item that catalog item ID, item dot quantity, and item that acquire date. So that's all we have to do to transform the item entity into an item DTO. Now we can go ahead and create our controller. So let's go to the controllers folder, right click, new file. We'll name it items controller, just like we did in catalog. Let's define a namespace for it. Play inventory service controllers. It's going to be a public class items controller. And remember, each of our items controllers should be marked with the API controller attribute. It should derive from controller base. And it should define the base route that is going to be mapped to. So route, this route, just like with catalog, is also going to be items, just because it also manages items. So route items. So now we're going to need one class level variable here, which is going to be the repository that we're going to be using to store and retrieve items. So let's define a private read-only. It's going to be a repository of type inventory item. And let's just name it items repository. So let's import play common here. And let's import play inventory service entities. Let's also collapse this navigation pane for now, since we are not going to be using it for a bit. And now we have to do dependency injection to actually receive this items repository into the controller. So let's define a constructor. Okay, so this constructor is going to receive again our repository. So I'll just copy that here, item repository. And let's assign it to our local instance, item repository. So now it's time to define our two operations. Remember, we need an operation to get all the items in the inventory and one operation to put an item or to create an item into the inventory. So let's start with the get operation. Let's define that as public async task of action result. And this is going to be of an IEnumerable of inventory item DTO. And then we'll name it just getAsync. GetAsync, and the parameter is going to be the user ID. So we want to get all the items in a user's inventory. So we're going to receive GUID user ID. Okay, let's see, let's add any missing namespaces, reading tasks, systems collection generic, and service DTOs, and for the GUID using system. let's also define the verb that is associated to this API, which is going to be HTTP GET. And so the way that this API is going to work, this operation is going to work, is we just need to go ahead and get all the items based on the user. So, but before we can do that, let's do a quick check. Let's make sure that this user ID is not empty. So if it is a GUID empty, we're going to return a bad request. Bad request, a simple validation in there. And so to get the items, we're going to do this. So we'll say, so the items is going to be, and we're going to open a braces here. We're going to do an async call to items repository, get all async. And here's where we can start using our expression, our filter based on an expression. So in this case, what we want to say is that we want to get any item where item.userID equals the user ID that we got as a parameter over here. Okay, so that's how we can filter items based on a user in this case. And then when we have that, we can do a select. Let's see if I'm missing another namespace, system link, where we're going to specify that we want to take each of these items that we found in the database and transform them as into a DTO with our extension method. And finally, we'll go ahead and just say return the items. Let's also transform this. Let's wrap this into the OK, into the OK action result. And that's all we have to do. So that will return all the items in the user's inventory. The next method is the one that we're going to use to assign one item to the inventory. This is going to be a post operation. So let's see, let's define it as public async task. We will just do action result. We're not returning really anything out of this method. Going to be post async, and it's going to be receiving our grant items DTO. Items DTO. Let's mark this with the HTTP post verb. Here what we're going to do is we will try to find if we have that inventory item already assigned in the inventory, because it could already have it. So in which case we just need to increase the quantity, or in the other case where we don't have it, we just have to create it for the first time in the inventory. So let's try to find it. So we'll do, so it's going to be inventory item equals, oh wait, items repository, get async. And again, here's where we can use the expression filter, where we're going to say that the item that we're going to try to find has to be one where the item that user ID has to match the grant items DTO user ID. And also the item that catalog item ID has to match grant items DTO catalog item ID. Let me see if I can put this in the next line. So that will find the item if it is there. So, but if the inventory item happens to be null, this is the first time that we assign this item to the user. So in that case, we will go ahead and say inventory item equals new inventory item. And we will set its catalog item ID is grant items DTO.catalog item ID. The user ID is grant items DTO.user ID. The quantity is that quantity. And for acquired date, we will just set our current datetime offset. So it's going to be datetime offset.UTC now. And finally, we will call our method in items repository to create an item. So create async inventory item. Okay, let's add this missing semicolon there. And then let's go for the other branch. So else, we did find the item, so we just need to increase the quantity. So for that, we will do inventory item dot quantity plus equals and items DTO dot quantity, and then we will do await items repository dot update async with the inventory item. And finally, we will just return OK. Yep. And that's pretty much for the controller operation. So we have two operations to retrieve the items in the inventory and to put an item into the inventory. So with that done, it is time to start doing the basic configuration of a startup. So I'll go back to our Explorer here. And first, let's go to app-settings.json. Here we have to define the settings for our, in order to define the service name and the MongoDB connection. So to save time, what I'll do is I'll go back to catalog actually, and I'll open my app-settings.json file over there, and I'll just copy these two sections from the app-settings.json. I'll go back to inventory, and I'll paste that right here. Really, the only thing that we have to change here is that this is not the catalog service anymore. This is the inventory service. Remember that this is what's going to define the name of the database that's going to be created in MongoDB. Save that. And now I'm going to go to startup. I'll actually clean up a bit these namespaces. I'll do control dot here, remove unnecessary usings. And now I'll go to the start of configure services. And I'll add the services for MongoDB and the repository. So I'll do services.add Mongo, and that may need another import, paycom MongoDB. And then I'll add a Mongo repository of type inventory item. Let's add a using there. And here we have to specify the name of the collection here. So the name that we're going to give it is inventory items. Save that. And so with that, we have registered everything related to MongoDB. And we actually are ready to start trying out this microservice. So I'll go ahead and hit F5. Okay. And then what I like to do is actually import the specification of our API into Postman to make our lives a bit easier. What I'll do is I'll copy the URL of our service, localhost 5005. And then I'll go to our browser just for this time, paste that there, and then let's go to Swagger. So this defines, as you can see, this is the Swagger UI page for our REST API. Then I'll click in the swagger.json link here, and I'll copy that. And then I'll just close this browser. Now I'll go to Postman. And here what I'll do is I'll just click on import link. I'll paste that, click continue, and I'll just say import. So now if we go to collections, we have now not just a catalog service section, but also a collection, but also a plain inventory service collection with our two items related operations. So what I'd like to do is to go ahead and try out our post to assign an item to a user. But of course, before that, we have to define the base URL for for this collection. So let's go to let's go to edit, variables. And in this case, our base URL is, as you remember, let's go to inventory. Base URL is localhost 5005. Put that here. I'll put it for current value and for initial value. Update that. Okay, so it knows the base URL. Now, being in post, we go to body, and here's the three things that we need: user ID, catalog item, and quantity. Now, for the user ID, like I said in the introduction, we don't have actual users so far, so we just generate a random one. And one handy way that we can do that in Postman is by using the GUID function that's built into Postman. So what you can do is just this. So open two sets of curly braces, and then you're going to do just GUID. So that will on the fly generate a GUID for us. And for the catalog item ID, we want to know the ID of one of our items in the catalog. So to do that, let's actually query our catalog items. But before doing that, let's go back to catalog and just hit F5 to actually start the web server so that we can query the catalog. And then I'll go back to Postman. Into our play catalog service collection, I'll expand this. I'll go to get items and I'll just hit send. And here is the one item that we have in the catalog, the potion. So I'll copy this ID. And I'll go back to our post operation, paste it there. And let's say that we want to assign just one of these potion into the user's inventory. So now I'll go ahead and hit send. And we got 200 OK, meaning it was a success. And so to verify that this actually worked, let's actually try out our get all items in the inventory operation. So I'll click on this new operation. And in this case, the first thing that we're going to need is to specify which is the user ID, right? So which user was that item assigned to, which if you go back to post, it was an automatically generated user. We actually don't know yet, but we can figure that out via our console. So I'll click on the console down here. And you open the post operation and we expand the body, the request body. You see that the user ID is right here. So the console records everything that's going on behind the scenes. So it's pretty handy in these cases. So I'll just copy the user ID and I'll close this. Then I'll go back to our get items from the inventory service and I'll paste that right here. So with that, I'll go ahead and hit send. And here it is. So this user has one of the catalog item of this ID and with this acquired date. The date was assigned. And so let's say that we wanted to increase the quantity of that item for this user and we want to actually test this other code path. So let's go back to post body and let's say that we want to add perhaps 4 more potions to this user's inventory. So I'll just do that. We want to change now, we don't want to generate yet another GUID. So I'll replace user ID with the ID that we just copied for our user. So then I'll go ahead and hit send, 200 OK. And then if we get items for this user in inventory, I'll hit send. And now the quantity is 5. So now the user has 5 items in his inventory. Okay. So at this point, our inventory service can store and report the items that each user has in his inventory bag. However, notice that this DTO that we have returned by the get operation only provides the IDs of the items in the user inventory. So since we don't have any names or descriptions, it is a bit hard to tell which items are in the user inventory, which are the actual. So what does 4E9C means really? So in the next lesson, we will learn about microservice communication styles and how our inventory service can use them to retrieve more details about each of these items from the catalog service. In this lesson, we will learn about the different microservice communication styles and how to implement the synchronous communication style via REST and the HTTP protocol. There are basically 2 ways you can communicate with microservices. The synchronous style, where the client sends a request and waits for a response from the service, and the asynchronous style, where the client sends a request to the service, but the response, if there's any response, will not be sent immediately. So far, we have been using the synchronous communication style when interacting with our services via Swagger UI and Postman. And in this lesson, we will explore how to use it for inter-service communication. We will learn about the asynchronous communication style in a future lesson. When using the synchronous communication style, the client sends a request and waits for a response from the service, which means that the client cannot proceed without a response. You may make this more evident with any of our services if you put a breakpoint in one of our service controller actions, like getAsync in the catalog items controller, start a debug session in VS Code, and then try sending a GET request to it via Postman. You will notice that Postman waits indefinitely for our service to respond. It can't continue until the service responds. Many times, this type of communication uses a blocking thread, meaning that the client is unable to receive any other inputs or perform any other task until the response arrives. But it could also use a non-blocking thread where the client just offers a callback method to the service, so the service can call the client back when the response is available. In this case, the client thread does not block, even when it still waits for a response. There are 2 approaches currently to use the synchronous communication style: REST with the HTTP protocol, which is a traditional approach and the one that we have been using so far. In REST, the business objects are modeled as resources, and HTTP verbs are used to manipulate them. Also, you usually use XML or JSON to represent the resources. Most clients support REST. The other approach is gRPC, which is a binary message-based protocol in which clients and servers exchange messages in the protocol buffers format. gRPC is becoming increasingly popular because it supports HTTP2 and is more efficient than REST. However, not all clients support HTTP2, which is why in a microservices architecture, gRPC is used mostly internally between the API gateway and the services, or between the services. In the next lesson, we will be implementing synchronous communication between catalog and inventory microservices using REST and HTTP. At this point, when the client requests the items in the inventory back for a user, the inventory service queries its database and retrieves an array that has basic info about each item, including the catalog item ID and the quantity. However, having a list of item IDs does not tell much to our client in terms of what actual items the user has on inventory. Ideally, we would like to get at least the name of each item and hopefully also its description. However, inventory doesn't know such details about the items since that information is owned by the catalog service. One way to address this is to have the inventory service send a GET request to the catalog service to retrieve the details of all the items. Inventory can then combine this additional info with the details it has in its own database to send back the desired more detailed payload to the client. Let's go ahead and implement this approach. Our inventory microservice needs to receive data from the catalog microservice. But before it can do that, it first needs to define the DTO that represents the retrieved catalog items. Now it turns to be that we already have such a DTO that represents catalog items. And if we go to our catalog project, our catalog microservice, and if we go to DTOs.cs, we're going to see that such a DTO is right here. So this is the DTO, item DTO, that represents catalog items when you query for them. So what I'll do is I'll just copy this DTO, copy this, and then I'll go to inventory. Here we are in inventory, and I'll open DTOs.cs, and I'm just going to paste that as initial DTO for the inventory. Now in the case of inventory, we're going to rename this into catalog item DTO, just to not confuse it with inventory item DTO. And for the case of inventory, again, we don't need that many properties when we're querying for catalog items, and you don't have to retrieve everything, or at least serialize everything into inventory. The only thing that we're going to need in this case is the ID of the item, the name, and the description. We don't need price and created date for our purposes, so I'll remove those. Save this. And now that we have this DTO, we can actually build a client that is going to be able to query for these items from catalog. So I'm going to right click in Play Inventory Service. I'll create a new folder. Let's call it clients. And in this one, I'm going to create a new file that I'm going to name catalog client.cs. Let's give it a namespace. Let's Play Inventory Service clients. Public class catalog client. So in order for our catalog client to be able to talk to any external HTTP endpoint, it needs to use the .NET HttpClient class. So we're going to define that as a class level variable here, private read-only, HTTP client, and I'll import the system.net.http namespace. And now we're going to do dependency injection of this client into our class. So public catalog client, HTTP client, and we'll take that reference. Now that we have that client available, we're going to define the function that's going to actually retrieve the items from catalog. So this is going to be an async function. So let's define it as async task. And what we're going to return is a collection of catalog item DTO. Since the consumer is not expected to modify this collection in any way, we're just going to return a read-only collection of type catalog item DTO, and we'll name it get catalog items async. Let's import missing namespaces for task and for read-only collection and for catalog item DTO. To retrieve the items, we can do that really easily with one line. So we'll do items equals, we'll do await HTTP get from JSON, let's change this, get from JSON async. May need to import another namespace, systemnet HTTP.json, and we'll deserialize as I read-only collection of type catalog item DTO. And then here is where you put the route that you want to access in the invoked REST API. In our case, in the cases of catalog, the route would be under items. And with that, we can go ahead and return the items. That's all you have to do to invoke another a REST API in another service. With that done, it is time to update our inventory item DTO to have this additional information that we're going to collect from catalog. So let's go back to DTOs. And in inventory item DTO, we're going to add a name and a description. But as we do that, as we can see, extension is complaining, and it's because we need to provide those additional members to the construction of inventory item DTO as we transform the inventory item entities. So what we'll do is we're going to receive additional parameters into this method, which are going to be the name and the description. And we'll feed those two into inventory item DTO constructor. There. With that done, we are ready to go to our controller to actually take advantage of this new information. So I'll go to items controller. And the first thing I'll do is I'll get a reference, or I'll define a class level variable for our catalog client. So I'll define private read-only catalog client. Okay, let's import the missing namespace. And let's receive that as a dependency injection into items controller. I receive the catalog client, and we'll get the reference. And now that we have that, let's change a little bit how we do our getAsync method. So we'll get rid of these lines for now. And the first thing that we're going to do is to actually retrieve the catalog items. So how do we get the catalog items? Very easily. Now we can do catalog items equals await catalog client dot get catalog items async. That's all it is. Okay, so that gives us all the catalog items in the catalogs microservice. Now we want to get the list of all the inventory items that we have currently in the inventory microservice. So we'll do that via inventory item entities. Is going to be await item repository get all async, where the item.user ID equals the user ID that we got as a parameter. Okay, so now we have all the catalog items, and then we have all the entities, the inventory item entities for the current user. Now we need to combine these two pieces of information to produce the DTO that we want to return. So to do that, we'll do this. So inventory item DTOs equals inventory item entities. Select, so we're going to do a projection here for each inventory item. We will do this. Let me close that. First, we will look into the collection of catalog items, and we will find the catalog item that corresponds to the current inventory item. So catalog item equals catalog items. That's single. There should be one and only one catalog item, where the catalog item that ID should match exactly the inventory item that catalog item ID. And once we have that, we can do the conversion of the inventory item into a DTO. So we will do inventory item, return inventory item as DTO, and then we have to provide the catalog item .name and the catalog item .description. And finally, now that we have the inventory item DTOs, we will return those as opposed to this all items collection. So inventory item DTOs. So our getAsync method is ready to retrieve an improved set of items with name and description. And now it is time to do the proper registration in a startup to let our application know about this new catalog client that we're going to be using. So let's go to startup. And what I'll do is I'll open a little section just under our Mongo registration. So I'll do services.add/HTTP_client, and our client is going to be catalog client. Let's import missing namespace. And then I'll specify a parameter here. It's going to be the client. Okay, let's open that expression there. And here really the only thing that we have to specify for now is the base address of this other microservice, because otherwise how would it know? So we're going to say that the client base address equals a URI. Let's import a missing namespace. And then if you remember, the URI where our catalog microservice lives so far is a localhost 5001. So that's what you have to specify here, HTTPS localhost 5001. Okay, so this is a handy way to register our catalog client so that it can be used by dependency injection in other classes like in the controller, right? So you say add HTTP client, catalog client, and then you specify the base address. And then when that client is instantiated, it will automatically receive an instance of the HTTP client that you're going to be using to query for items. Okay, so with that done, let's go ahead and hit F5. Let's see this in action. Let's not forget to also do an F5 in our catalog microservice. So I'll go ahead and start also. Here's catalog. I'll start it F5. And with the two services up and running, we can go ahead and go to Postman. And here in Postman, I am already in the tab for the operation that can retrieve all the inventory items for the specified user ID. So this is user ID that we used in the previous lesson. So let's see what information we can get now that we query the API. So we'll go ahead and hit send. And as you can see, we are able to retrieve the catalog item, but this time we not just have the ID of the item. We also have the name and the description of the catalog item. Okay, so this seems to be working pretty well. However, think about what would happen if the catalog service starts having issues, at least temporarily, or what happens if it's completely down. In the next lesson, we will learn about the problems that we might find when having a service communicate with another service. In this lesson, we will learn about partial failures in microservices and how to deal with them using timeouts and the exponential backoff technique. Even after placing our best efforts to ensure we have a healthy system, it is a matter of fact that in distributed systems, partial failures will happen. This could be due to multiple reasons, including network outages, hardware failures, dependency failures, and even routine things like having a deployment in progress. Regardless of the cause of the partial failure, when calling a dependent service, it could certainly cause our microservice to fail, which will end up in a bad experience for our clients. So, whenever a service makes a synchronous request to another service, there is an ever-present risk of partial failures, and so you must design your service to be resilient to them. One of the first things to consider when making requests to a dependent service is setting appropriate timeouts. A service client should be designed not to block indefinitely and use timeouts. Think about the experience of our client when the catalog service takes a long time to come back to our inventory service, if it ever comes back. Now the inventory service is also taking forever to respond to the client, leaving our users with a bad experience. And not only that, at least one of the threads of inventory is now busy not being able to serve any other requests, which reduces the amount of available resources in the service. Instead of this, you can set a timeout of, say, no more than 1 second, so that if catalog service takes more than that to respond, the request immediately fails, and the inventory service can in turn return the appropriate request to the client, even if it's a failure. This enables a more responsive experience and also ensures that resources are never tied up indefinitely. Like we mentioned, it is not uncommon for transient failures to occur in a distributed environment. Therefore, you usually want to give the dependent service one more chance to come back with a successful reply. However, you don't want to keep retrying at a constant rate, since that could overwhelm the dependency. A good strategy that you can use for retries is the one called retries with exponential backoff. This strategy performs call retries a certain amount of times with a longer wait between each retry. And here's how it works. As usual, the client will make a request to our service, and this one in turn will make a request to its dependent service. If this second request fails, instead of failing right away, our service will wait some time, and then it will try again. If the request fails again, we will now wait a longer amount of time before trying the request. If it keeps failing, we will wait a yet longer amount of time before one more try. And eventually, if we have tried enough times with no successful response, we will let the call fail. As you see, this strategy lets a failing dependency have an increasing amount of time to recover. It also avoids overwhelming the dependency. Let's see how to implement timeouts and retries with exponential backoff in our inventory microservice. Let's see our inventory and catalog microservices in action once again. So here I am in catalog, and I'll just hit F5 to start a web server. And then I'll go to inventory, and I'll do the same thing, hit F5. And now I'll go to Postman, and I'll try to get all the inventory items for this user ID. So I'll just go ahead and hit send. And here's what we expected to get, right? So the list of inventory items with name and description. Now, to simulate the effects of partial failures, let's first add a few temporal modifications to our getAllItems operation in catalog microservice. So I'll go to our catalog Visual Studio Code instance, and I'll stop it for now, close terminal, and I'll go to items controller. And what I'll do is I'll modify our getAsync method, the one that retrieves all the items, so that it introduces a few temporal failures for our inventory client. So before doing that, I'm going to add a little variable to track how many requests we have received from the client at this point. So I'll just add private static int. I'm making it static so that it doesn't reset after every request. Let's just call it request counter. Start with 0. And now in getAsync, I'm going to open space here. Let's go down. And I'll do the following. The first thing that I'll do is I'll just increase the counter. And then let's add a log line just after this. Console.writeLine. We'll just say string interpolation, request counter, starting. So that's what it tells us that it's starting a new request. Then what we're going to do is for the first two requests, we will actually increase, we'll add a delay to simulate the timeout scenarios. So if request counter less than or equals to 2, we're going to say, I'm going to copy this line here, console write line. We will say delaying, and I'm going to say await task.delay. This is how you can introduce a delay in the current request in an asynchronous way. Time span that from seconds will say 10 seconds. So the first two requests will be delayed 10 seconds. Then I'll copy this block here, down here, and we will say that if the request counter is less than or equals to 4, what we're going to do is just return an internal server error, right? So to simulate that kind of error. So request counter, we will say 500 internal server error. And we will return status code 500. Now at this point, we are introducing this capability of returning either one result here or another type of result here. And in order to do that, remember that we have to switch from just returning the IEnumerable into returning an actual iAction result. So I'll say action result of IEnumerable of item DTO, and I'll close this. So that gives us the ability to return more than one type of result. And also we'll have to modify our final return clause here so that it returns something that can be mapped to outcome result, like the OK result. And lastly, what we're going to add here, just over here, let me copy this console write line. This is going to be the happy path where we finally return something. And we're going to say request counter. We will just say 200. OK. Okay, so for a quick review, we have a static request counter. So every time a request comes in, it increases the counter. The first two requests are going to have a 10 seconds delay. The next two requests are going to end up in a 500 error. And then if we get past that, we'll get a 200 OK. And so at this point, I'll go back to our inventory. This is our inventory Visual Studio Code instance. I'll just stop it, close. And what I'll do is I'll first go ahead and collapse our navigation pane for now. I'll open my terminal over here. I'll open a new PowerShell terminal. And what I'd like to do is actually have two terminals in this window so we can see the interactions between microservices. So I'll use the split terminal icon here to open a second terminal. And in this one, I'll actually switch back to play the catalog directory. Okay. Play that catalog service. And here I'll do .NET run so that we can see the outputs that are coming out of catalog. And then on the left side, I'll start up our inventory microservice. Same way, I'll do .NET run. Okay, so with that done, let me go back to Postman and I'll try the query once again. So I'll hit send. And back in VS Code, you can see that now this first request is getting delayed. And now our inventory client is experiencing this significant timeout. If we try it again, for the point of view of Postman, so look at this. It just keeps waiting, waiting, and waiting. We're giving a really bad experience to our clients, right? Okay, so what can we do about this? So the first thing, as we mentioned, is to introduce a proper timeout to avoid this kind of situation. So let's go back to Visual Studio Code. And what I'll do now is I'll stop both web servers. So I'll go to my inventory terminal. I'll do Ctrl+C, stop server, catalog, Ctrl+C, stop server. And what I'd like to do now is to add our reference to the poly NuGet package. So this is the package that you can use in your .NET applications to properly handle transient error failures in a very easy way. So being in play inventory service, I'll do .NET add package Microsoft.extensions.http.poly, enter. Okay, and then perhaps I'll put this back into place, and then I'll just do Ctrl+J to hide our terminals for a moment. Then I'll go to our Explorer and I'll go to startup.cs and I'll collapse this once again. We don't need it. And let's go into configure services. And yeah, so let's find the section where we are adding the HTTP client right here. And here what we're going to do is we're going to append yet another call to another method here that's called add policy handler. And here's where we can define a policy. So poly has this concept of policies that different policies that can be used to handle different transient errors when you're invoking an external API. So we're going to use policy, and then let's import any missing namespace using poly. So we will say policy.timeout async. And then we have to specify a type here, and that type is going to be HTTP response message. And let's add the system.net namespace, because this is the type of response I will get when you invoke the external client. So, and in this parameter, we want to specify how many seconds we want to wait maximum after calling an external API and before just failing. So I'll say 1 second in our case, and I'll close this. So just by doing this, you're saying that anytime we invoke anything under localhost 5001, we're going to wait at much 1 second before giving up. So let's see now how this works. I'll bring in back my terminals via Ctrl-J, and then I'll do .NET run in both cases. Okay, perhaps I'll move this a little bit to the right. And then let's go to Postman and try the request once again. As you can see, it now took just a little bit more than 1 second to complete the request. So instead of waiting for all those 10 seconds, wasting resources. Let's try again. Yep, and once again, it just took just a bit more than 1 second. If we go back to Postman, we can also see we tried the 2 requests on the right side, but then they actually took more time to respond. But regardless, we had already failed on the left side, on the inventory side. So that would at least help us fail fast to avoid the long delay and avoid consuming inventory resources unnecessarily. However, we note that transient errors are not uncommon in distributed systems. So we would like to not just fail right away, but instead try a few times, hoping for the catalog service recovery. In the next lesson, we will implement the retries with exponential backoff technique to improve our chances of succeeding in the presence of transient errors. In the last lesson, we introduced a 1-second timeout policy to our inventory microservice. Let's now use the retries with exponential backoff technique to let inventory retry the calls to catalog a few times before giving up. So here I am once again in the play.inventory microservice, and here's a line where in the last lesson we added our timeout policy. What we want to do here is add yet another policy to specify what to do in the presence of transient errors and how to retry. So now I'm going to be adding that policy handler right here, just between the @HttpClient call and the @policyHandler call. And just pay attention of the location of this, because we want to make sure that we can combine the timeouts with the transient error handling, so that anytime that we retry, we actually wait just 1 second, like specified in this policy. We wait 1 second between tries. If you don't do things in the order that are going to be shown here, that combination is not going to work properly. So at this location, I'm going to say add transient HTTP error policy. And let's actually go into the definition of this method for 1 second. So go to definition. So just so that you can see what this method is handling. So this method is taking care of network failures. It's also taking care of 500 errors, server errors, and 408 status codes, so request timeout. So this method we're going to use is very handy, because it can handle all these situations by itself automatically. I'll close this. And again, notice the location where I added this. So now what I'll do is I'll say builder. And then we'll say builder dot wait and retry async. And here we're going to open parentheses, and we need to specify a series of parameters for this policy. And the first parameter is going to be the retry count. So this is how many times we want to retry in the presence of transient error failures. So for our case, let's say we're going to go for 5 retries. The next parameter is the sleep duration provider. So this is just a function that determines how much time to wait between each retry. So for this, we're going to say retry attempt, and then we'll use a time span class to specify a duration in seconds. But here is where the exponential backoff part comes into place. We're not going to just specify one specific amount of seconds. We're going to say mat.pow, so that we can say, let's go for 2, and then we'll raise that into retry attempt. So this means that every time we're going to wait, we're going to be waiting an increasing amount of time that depends on the retry attempt. So for like the first time it's going to take 2, raise it into 1, the first retry attempt. So 2 at 1 is going to be 2, so 2 seconds. So next time it's going to be 2, raise at 2, so it's going to be 4 seconds. Then next time 8 seconds. It will keep going that way in an exponential way, so that every time we just wait a little bit more. So that's exponential backoff piece of this technique. And then next, we're going to specify yet another parameter that you don't really need it, but we're going to use it just for the purposes of demonstrating what happens between the different calls. So you can totally skip this if you don't want to see what's going on behind the scenes. So I'm going to say on retry, and then we need to specify 3 parameters. It's going to be outcome, time span, and retry attempt. So I'll open this, and then here we can specify what we want to do each time that a retry happens. What we want to do is just present a log message in the console, and we can do we can use iLogger for this. Now, to do that, at this point, we need to actually get an instance of the iLogger class, but we don't have an easy way to do that right now. So what we're going to do is to, as an instance of the service provider, we're going to create a service provider, and from that one, we're going to get that service. This is not ideal, and that's actually going to present a warning message in the console, but we're doing this just for demonstration purposes, so totally avoid this technique in production code. So let's see, we'll say service provider equals services dot build service provider, and then we will say service provider dot get service. We want an iLogger of catalog client. Okay, let's see if we're missing a namespace. The extensions logging. Okay, so if you're able to get that service instance, so we'll use this question mark there, we'll say dot log warning, and here's where we're going to specify that message. And the message is going to be, and we'll do string interpolation here, we'll say delaying for so many seconds, and those seconds are going to come from time span, the total seconds, and then making retry, and that's going to be retry attempt. Okay, close that, save. And one more thing that we have to do here is make sure that we combine both of these policies so that they can work together. And to do that, what we have to do is go back to this builder declaration here. So and then we have to say builder.or, and then we specify the exception that will be coming out of the timeout async call over here. So in that case, that exception is going to be timeout rejected exception. And then let's see if we're missing a namespace using poly timeout. Okay, so that's how you can say that if the actual, and let's add missing parentheses, if we fail because of a timeout produced by the timeout policy, then it will fire a timeout exception. Let's go ahead and also retry. Okay, so that's the right way to combine both policies. Okay, so now let's just save this, and I'll open my terminals, and left side is inventory. I'll do .NET run, right side is catalog, .NET run. Let's expand this a bit, and notice the warning that I was mentioning before, and this happens, like I said, because of the way that we're doing the service provider construction here. There's already a service provider built into the ASP.NET Core runtime. We're creating a second one. That's not ideal, but like I said, it's just for demonstration purposes. Feel free to remove this section in your production code. So now that we have both services up and running, let's go back to Postman, and let's go ahead and do a send to see what happens. So it starts, and going back here, you can see that first time we tried, and then we waited 2 seconds, then we waited 4 seconds, then we waited 8 seconds. We're trying to wait 8 seconds. On the right side, you can see that the multiple requests that are coming in, now they're firing internal server errors. And now we are in what's probably the last wait for 16 seconds. And so the client in Postman, as you can see, it just keeps waiting. It doesn't fail right away, but we are trying to get a chance to actually succeed. And yeah, eventually that happened. The client succeeded, and we no longer see an error. If we see back into Postman, we can see that, yeah, indeed, eventually we got a 200 OK for the last request, and it's looking great. Now, the one issue with this is that if you have multiple instances of your, in this case, of an inventory service calling a catalog, and they are all waiting exactly 4 seconds, exactly 8 seconds, 16 seconds between retries, that can actually cause a kind of bursts of calls into catalog service at the very same time, right? Because they're waiting for exactly the same time between retries. So to avoid overwhelming our catalog service, what we can do is introduce a little bit of randomness so that it is not exactly 4 seconds or exactly 8 seconds and stuff like that. So how can we do that? I'll do Ctrl+C in both of my terminals to stop those processes and do Ctrl+J to close the terminals. What we're going to do is add what we call a jitter. So this is it's going to be the way to add that randomness here. So I'll go up, and just over here, I'll introduce a random jitter. It's going to be new random. And then let's go back to the section where we're defining the retry attempt over here. What we're going to do is just go to next line, and we will say plus time span dot from milliseconds, and we will say jitter dot next. And so we want to add is some number of milliseconds to those seconds. So we will say any number from 0 to 1000 should be fine. So this time we should see that it's not just a specific amount of seconds, but those seconds plus some milliseconds that are going to be generated at random. So I'll save that, open terminals again, Ctrl+J, .NET run, and .NET run. Okay, and let's go back to Postman and try this again. So I'll hit send. Let's go back here. And as you can see now, we are not waiting just 2 seconds, but 2.523 seconds. And the next time we're waiting for that 338 seconds, and so on and so on. Yeah. So with that, the different instances will be invoking back to a client at slightly different times, which lets a catalog not get overwhelmed. And so this is much better and would certainly help us handle temporal glitches when reaching out to the catalog service. However, imagine that a widespread network outage is preventing us from reaching catalog, or perhaps is preventing catalog from reaching its dependencies. So such outage would likely last, let's say, a half an hour. And if we have all of our inventory service threads retrying that much time, we may end up exhausting its resources. In the next lesson, we will learn more about resource exhaustion and how to deal with it via the circuit breaker technique. In this lesson, we will learn about resource exhaustion in microservices and how to deal with it using the circuit breaker pattern. Having a retry policy in place is good, but you also must be mindful about the limited resources available to your service. Imagine once again a situation where there is an ongoing issue with your service dependency. This might not be just a transient issue, but instead some prolonged downtime caused perhaps by a broad network outage. Now the client calls our service, and this one in turn invokes the already failing dependency, which will hopelessly start waiting for a reply. While this is happening, more clients keep sending requests to our service, and this results in more requests being sent to the failing service. One thing you have to realize is that each of these requests are making use of your service threads, of which there is only a limited amount. Once enough threads are in use, there are no more resources available, and you can reach what we call resource exhaustion. When this happens, your entire service becomes unavailable for any future requests, potentially causing a lot of trouble in the system. One approach we can use to properly handle this issue is implementing the circuit breaker pattern. A circuit breaker prevents a service from performing an operation that's likely to fail. Here's how it works. Once again, we are in a situation where our dependent service is already in a bad state, unable to provide successful replies. Our client then makes a request to our service. However, this time, instead of invoking the failing dependency directly, there is an intermediary that we will call the circuit breaker. The circuit breaker will now start monitoring the results of each of the requests that go through it to the external dependency. And when it detects that the rate of failure goes beyond the configured threshold, it will immediately stop letting any more requests go out and will fail them right away. This is what we call opening the circuit. After this, requests will just keep failing immediately during the configured wait time, which would hopefully give the dependent service enough time to go back to a healthy state. Eventually, the circuit breaker will let some requests go out to verify if they succeed. And if that is the case, it will close the circuit again, letting all further requests reach the dependent service. That's how the circuit breaker prevents our service from reaching resource exhaustion, while at the same time avoids overwhelming dependent services until they get a chance to recover. Let's go ahead and implement the circuit breaker pattern in our inventory microservice. To implement the circuit breaker pattern, all that we have to do is add a new transient HTTP record policy, just like we did for the wait and retry policy. So here we are again in the inventory microservice in the startup class, configure services method, and I'm going to scroll down a little bit here. And remember, we have already added a policy for wait and retries, and we have a policy for timeouts. So what I'll do now is I'll open yet another section here to add our next HTTP record policy. So I'll do add transient HTTP record policy. Remember that we want to do this just before the timeout and not after, so that this policy can also wrap the benefits of the timeout policy. So I'll open parentheses here, and what I'll do is I'll just copy this little section here so that we are properly combining this policy with the exceptions that could come out of the timeout policy. But then what I'll do is I'll invoke the circuit breaker async method here, and I'll open parentheses. And here we have to specify the parameters for circuit breaker. So the first parameter that we have to specify here is how many tries we're going to allow, or how many requests we're going to allow through the circuit breaker before the circuit has to open, right? So in our case, let's say that's going to be 3. So 3 failed requests are going to go through the circuit breaker before the circuit breaker actually notices that, yeah, there's a problem and we have to open the circuit. Next comes the duration of or time span of the break. So this is how much time we will keep the circuit open. So let's say this is going to be time span from seconds, let's say 15. And that's really most of what you have to do. You don't have to do more than that to enable the circuit breaker. But just like we did with our retries, let's add a couple of functions here to get an insight of what's going on behind the scenes. So what I'll do is I'll say onBreak. So this is a function that will be used when the circuit opens. So I'll say outcome and time span. Okay, so in this case, we want to add a log message and stating that the circuit breaker is opening. So this is going to be really very similar to what we did for our wait and retry. So I'm actually going to copy these 3 lines from here. I'll copy them over here for our onBreak function, and I'll just change the message the following way. So I'll delete this and I'll say opening the circuit for, and this is going to be time span that total seconds. Okay, so that's what's going to happen when the circuit breaker opens. And then next, we're going to add another one for the onReset function. That's not going to receive any parameters. And in this one, we're going to do something very similar. So I'll copy again those lines, paste them there. And in this case, we're just going to say closing the circuit. Okay, so that's really all you have to do to enable circuit breaker. So again, we are waiting. We will allow 3 requests to go into a circuit breaker, and if those 3 are failing, the circuit is going to open. Then it's going to wait 15 seconds before allowing any new request to actually try to reach the other end. During those 15 seconds, things are going to just fail right away. And then we have functions to log what's happening when the circuit opens and when the circuit closes. So now I'll go ahead and I'll open my terminal. So I'll save this file. I'll open the 2 terminals. Just like in previous lessons, I have 2 terminals. Inventory service on left side, catalog service on right side. I'll do .NET run in both sides. Okay. Notice we keep getting these warnings about the build service provider issue that we talked before. But like I said, this is just for demonstration purposes. So now I'll get back into Postman and we'll try out that inventory API to get all the items in the user's inventory. See what happens. So I'll just go ahead and hit send. And notice the left side that we failed. So we waited for 2.002 seconds. Then we tried, failed, waited for 4.644 seconds. And then at that point, the circuit actually opens for 15 seconds. So we're waiting 8.71 seconds for the next try. But the moment that we try this again, things failed right away, as you can see on the left side. And if we see what's happening in Postman, yeah, we're getting that error. The circuit is not open, is not allowing any further calls. And if we try once again, it may take 1 or 2 seconds, but it will fail because the circuit is open. And if we just keep trying and keep trying, we're getting an immediate result. So this is the effect of having the circuit open. So any new requests that are coming here from any client into our service are going to fail right away. However, eventually the circuit lets us go through one more request. And if it notices that it's successful, it opens the circuit like it happened right here. If we go back to Postman, we can see that it allowed one more request just to see if things are healthy once again. And it got a 200 result. And then it said, yeah, closing the circuit, and it allowed things to keep working once again. So that's how the circuit breaker works, and that's how it can help us prevent overwhelming other services or having to waste resources and cause resource exhaustion in our microservice. At this point, we are doing a fairly good job at handling partial failures between our inventory and catalog services. However, could there be a better way to have inventory get all the information it needs from catalog without having to rely on catalog to be available most of the time? In the next module, we will learn about the asynchronous communication style and how it can help us enable a much more resilient communication between our services. In this module, you will learn about the asynchronous inter-service communication style, the challenges it can help solve, how to implement it via RabbitMQ and MassTransit, and how to enable eventual data consistency between our 2 microservices. By the end of this module, you will have a solid understanding of the following: the basics of and when to use asynchronous communication between microservices, how to enable microservices autonomy and the impact to the SLA, how to use a message broker for asynchronous data propagation, how to stand up a RabbitMQ message broker via Docker Compose, how to publish messages to RabbitMQ via the MassTransit framework, how to consume messages from RabbitMQ using MassTransit, and how to implement eventual consistency of data propagated across microservices. In this lesson, we will learn about the asynchronous communication style and how it can help us enable much more resilient communication between our services. Imagine a scenario where after receiving a request from a client, our microservice needs to reach out to 2 other microservices. Also, each of these services need to get in touch with other services, which in turn might need to further reach to more services. There may also be services that depend on the services that our service depends on. We originally fine-tuned our service so that it never takes more than 300 milliseconds to respond to our client requests. However, when we started making synchronous calls to one of our dependent microservices, we had to add to our time the 200 milliseconds that service can take to respond. That was still okay in the beginning, but unfortunately, when that dependency eventually started calling another dependency, and that one yet to another one, our overall average latency bumped to 1450 milliseconds, which is bad. On top of that, if one of our deeper indirect dependencies starts failing, even if temporarily, it can cause all of the services that depend on it to also start failing. And the effect keeps cascading until potentially most of our system becomes unavailable. One important concept that you should keep in mind as you embrace microservices is the Service Level Agreement, or SLA. The SLA is basically a commitment between you as a service provider and the client. For instance, as part of our SLA, we could have defined that our service can be expected to be up and running 99.9% of the time. So, when our clients choose to use our service, they should expect it to be down approximately 44 minutes during the month, which the owners of the client will have to decide if it's acceptable. However, when using synchronous communication, calculating such numbers for our service SLA gets more complicated. Our deepest dependency is also advertising a 99.9% uptime in their SLA. And let's say that all of the services initially advertise that same value. However, in our scenario, when dependency 4 fails, it impacts the SLA of dependency 3, which now sets its SLA down to 99.8%. This in turn impacts the SLA of dependency 1, and ultimately impacts our own SLA. Now, with an SLA of 99.6% uptime, our clients would be subject to about 175 minutes of downtime across the month, which is way below of what we wanted to provide initially. So the synchronous communication style suffers from an increase of latency due to the chain of calls. It can significantly amplify the impact of partial failures and can potentially reduce the SLA of our service. Now, let's look at the asynchronous communication style. Here, the client does not have to wait for a response in a timely manner. And in fact, depending on how the communication has been set up, there might not be any response at all. To enable such communication, there is usually an intermediary called the message broker, which is pretty dumb in nature, meaning that it has no business logic on it, and it is also highly available. With the message broker in place, the service client sends messages to the broker, and the broker forwards the messages to receivers as soon as possible. The messages can be received by two types of receivers. A single receiver, in which case we think of the message as a command via which the client requests an action on the receiving service. For instance, when a purchase operation starts, our trading service will send a command to our inventory service asking it to grant items to the user's inventory, and another command to our identity service asking it to debit yield from the user. We could also have multiple receivers, where there are multiple services that subscribe to the events published by the client service. This would be the case if, for instance, our catalog service would like to publish any updates to its catalog of items so that other services can be informed about the changes. One of the key benefits of using asynchronous communication is that it enforces a microservice's autonomy. Let's see how it's enabled. In a single receiver scenario, we would have again our client talking to our service, but our service will not talk to its dependent service. It will instead send an asynchronous message to a broker, and it will immediately acknowledge to the client the successful reception of the request. The dependent service will consume this message from the message broker as soon as possible and will eventually provide a reply via the same broker. At that point, the client can request the status of its initial request to our service, or our service can notify the client of the response. All of the services in our system would follow the same message-based approach, including cases where a reply is not required from the called service. The great thing about this kind of layout is that when one of the dependent services fail, it would not cause any impact on the other services, since all of them have been decoupled from each other and only talk to the message broker. So the same SLA that one of the services presents can be honored across the entire system, assuming that the message broker offers high availability. So, with asynchronous communication, partial failures are no longer propagated. Each service has its own independent SLA, and best of all, the autonomy of all microservices is enforced given the lack of coupling between them. One of the nice things that asynchronous communication provides is the ability to asynchronously propagate data across services. In the synchronous communication scenario, when the client requests the user's inventory, and since the inventory service only has the data that's relevant to it, inventory has to first talk to the catalog service in order to retrieve additional details about each item. How can asynchronous communication help here? Well, thanks to the presence of the message broker, what we can do now is have the catalog service publish an event each time a catalog item is created, or updated or deleted. Such event doesn't have to have all the details of each item, but only the ones of interest to client services. We can then have our inventory service listen to these events and create its own collection of catalog items in its own database. As long as we have a highly available message broker, the list of catalog items in the inventory database should be eventually consistent with regards to what's in the catalog service. Now, when the client requests the user's inventory has no need to go out into any dependent service to request item details. It has everything it needs in its own database, and it can immediately provide a reply to the client with no additional latency. So, thanks to asynchronous communication, we can enable eventual consistency across our system, the autonomy of our services is preserved, and the previous inter-service latency is reduced or completely removed. In the next lesson, we will start implementing asynchronous communication between our two microservices. We will introduce RabbitMQ as our message broker of choice, given that it supports the AMQP protocol, it is lightweight, easy to run locally, and is very popular in the open source community. RabbitMQ introduces the concept of exchanges, which you can compare to a mailbox. When a service like Catalog needs to publish a message, it will send it to an exchange in RabbitMQ. And with the appropriate bindings in place, the exchange will distribute the message to any of the configured queues. From there, RabbitMQ will take care of delivering the message to any subscribed services like inventory. We could use RabbitMQ directly in our code, but we would first need to create the exchanges and queues and configure the bindings to ensure messages are properly routed. Also, our code will be tied to RabbitMQ, and if we ever wanted to move to another message broker, we would need to rewrite a good part of our services code. For this and a few other reasons, we will instead use MassTransit on top of RabbitMQ. MassTransit is a popular open-source distributed application framework for .NET. MassTransit can take care of doing most of the RabbitMQ configuration for us and is able to integrate with multiple other message brokers while allowing our services to stick with a higher layer of broker-agnostic APIs. As part of this, MassTransit introduces the concept of a publisher and a consumer, which is what our service code will focus on. Let's start coding. Just like we need to define DTOs to establish contracts between our REST API and our API consumers, we also need to define the contracts that define the messages to exchange between services that use asynchronous communication. However, this time we will define the contracts in a separate project, mainly because we will later package and share the contracts with other services so they can easily use them. So let's start by defining the contracts that our catalog service will use to send events asynchronously anytime an item is created, updated, or deleted. So here we are once again in our catalog microservice project. And what I'll do is I'll open my terminal via Ctrl+J, and then I'll switch to the source directory, and I'll go ahead and create a new class library. So I'll do .NET new class lib, and the name we're going to give it is play.catalog.contracts. Okay, so now we have a new contracts project over here. And before we forget, let's make sure we get a reference from the catalog project into the contracts project. So what I'll do is I'll go into play that catalog.service, and then I'll do .NET add reference, and it's going to go into play that catalog.contracts, play that catalog.contract.csproc. So make sure that we can use these contracts from the catalog service. Now let's go to our, let's collapse this and let's go to our contracts project, and let's actually collapse this terminal. And let's delete this class 1, we are not going to need it. And let's actually bring in a brand new file into the contracts project. We will call it just contracts.cs. Let's give it a namespace. It's going to be play that catalog.contracts. And here we're going to declare 3 records that are going to represent these contracts for items that are getting created, updated, and deleted. So let's start with the created case. So public record, catalog, item created. So here we need to specify not everything about the catalog item, but really the stuff that our consumers are interested in. So in this case, what our consumer needs, in this case inventory needs to know, is the item ID, the name, and the description. So let's specify that. So GUID item ID. Let's import the missing namespace. The name and the description. And then we need to specify the event for when items are getting updated. So I'll just copy the one for created, since these are very similar. I'll say updated. Okay, it's really the same information we're going to emit anytime an item has been updated. And then lastly, let's define catalog item deleted. And in this case, the only thing that we need to communicate is the ID of the item. So in this case, it's just going to be GUID item ID. So with that, we have defined all the contracts that we need. And in the next lesson, we will update the catalog service to start using these contracts and a few new NuGet packages to start publishing messages to a service broker. It's time to update our catalog microservice so that it starts publishing messages anytime an item is created, updated, or deleted. So I'll start by opening a terminal so that we can bring in a couple of NuGet packages that we're going to need. So here I am in the play.catalog directory. I'll switch to src and to play.catalog.service, not the contract, but the service one. And here I'll add .NET add package MassTransit.ASP.NET Core. Okay, so this one brings in a bunch of functions that we're going to use in order to interact with the MassTransit libraries. And the next package is going to be MassTransit.RabbitMQ. So this one introduces a couple of additional APIs so that we can explicitly use the RabbitMQ service bus. Okay, so with those added, let me close this terminal. And I'll go to Play Catalog Service and into our items controller. And perhaps I'll close the navigation pane for now. And here we're going to do a few things. First, let's get rid of this temporal code that we added in previous lessons to simulate temporal failures. So we don't need really any of this anymore. Remove that, and I'll also remove this request counter that we had added. Now, the first thing that we're going to need here in order to be able to publish messages is what we call a publish endpoint. So this is the class that allows us to really communicate that we want to send messages to some location. So I'm going to declare a variable of type iPublish endpoint. Let's call it just publish endpoint. And for this, we're going to need to import the MassTransit namespace. And then we're going to receive this variable as via dependency injection into the constructor. And then we will grab that instance into our publish endpoint variable. Now we can go to each of our controller actions, operations, where we want to publish a message and start sending those messages. So I'm scrolling down into our post async method. And what we're going to do is that just after creating the item in our database, we're going to publish a message announcing that the item has been created. So I'll do await publish endpoint dot publish, and here we're going to use our new set of contracts, and we will start with our catalog item created contract. And let's see, control dot, we need to import the play catalog contract namespace, and here we have to provide, of course, the item.id, item.name, and item.description. And that's really all you have to do to publish a message. And I'll copy this line, because now it's time to go to our put async method and do something very similar. So just after updating the item into the database over here, let's add and paste that line. But in this case, the method is going to be catalog item updated. And we will use the existing item variable that we have here. We'll use the ID, the name, and the description. I'll copy this once again. And let's go to our delete async method. And again, just after removing the item, we will go ahead and publish a message saying that we have a catalog item deleted, which is going to be just the ID that we received from the parameter. So yeah, so that's all you have to do. And so now any consumer of these messages that is listening to the queue, to the right queue, will be notified that an item has been created, updated, or deleted. Now what we have to do is to do the proper registration in startup to configure and to register the classes that we need for MassTransit and for RabbitMQ. So I'll open my Explorer here, and I'll go first to app-settings.json. Here, just like we did with MongoDB, we need to add a little section for our RabbitMQ settings. So I'll open a section here. Let's name it RabbitMQ settings. Open a section here. And here, the only thing that we're going to declare at this point is the host. So where is this RabbitMQ server living? And in our case, since it's all local machine, it's just going to be localhost. You could specify more details like username, password, and a bunch of other settings. But for now, for local purposes, we will just accept the defaults and we will go with localhost. Save that. Now, just like we did with the other settings classes, we need to introduce a class that represents the RabbitMQ settings so that we can use that in startup. So I'll create a new settings directory here now. And of course, we will move this later into our shared common library. But for now, let's just do it here, and we will do the refactoring later on. So I'll add a new file into the settings directory. Let's call it RabbitMQ settings.cs. Let's add a namespace. Play that catalog, that service, that settings. And then let's declare our class, public class, RabbitMQ settings. And as we know, the only thing that we need here is the host. So I'll declare our string host. And as with any other settings class, we will use this as an init as opposed to set, because nobody should be setting these properties after they have been deserialized from the configuration file. I'll save that. And now it's time to go to startup to register what the services that we're going to need. So I'll go to startup, and again, I'll collapse this navigation pane. So here in startup, I'll locate our configure services method right here. And then we will add the MassTransit classes just before the controllers. Let's do it here. So we're going to say services.add MassTransit. And we will receive a variable here that we're going to be using to configure things. I'll open a section here. Close this. Let's see if we're missing something. Yeah, so we need to import the MassTransit namespace. And then we will use this X variable here, that we call the configurator, to specify the type of transport that we want to use. In our case, that transport is going to be RabbitMQ. So we have to say x dot using RabbitMQ. And then we need to specify a function to configure the RabbitMQ. So in this function, we're going to declare two parameters, which are going to be the context and the configurator. And then let's give this function a body. Let's close that, save. And the first thing we're going to do here is to get an instance of those RabbitMQ settings so that we can figure out what's the host that we're going to use. So we will just say RabbitMQ settings is going to be configuration, get section, and then the section that it should have the name of RabbitMQ settings. RabbitMQ settings class. And let's see if we're missing something. Yeah, we need to import the play catalog service settings namespace. And when we have that, we can say, okay, so now get it as a RabbitMQ settings type. Okay, so we have the settings, and now what we can do is use the configurator to set the host where our RabbitMQ instance lives. And that's going to be in RabbitMQ settings.host. And now we'll add one more line. This is not necessary, but I think it's very handy. And this line is going to help us define or modify a little bit how the queues are created in RabbitMQ. So I'll do configurator.configure endpoints. And here we're going to receive the context and a formatter. And what we're going to use is the kebab case endpoint name formatter. See if we're missing something. Yeah, we need MassTransit definition. And in this formatter, we're going to define first the prefix that we're going to be using for our queues, and that's going to be service settings dot service name. And then we will not need to include the full namespace of our classes in those queues. So we'll just say false here. And lastly, we'll add one more line just after this one to start the MassTransit the hosted service. So we'll say services.add MassTransit hosted service. This is the service that actually starts the RabbitMQ bus so that messages can be published to the different exchanges and queues in RabbitMQ. So I'll save that. And for one last change, I'll go to our Explorer, and I'll go to app settings.development.json. And this is something that I like to do more for demonstration purposes than for anything else. But this is changing the default login level from information to debug. So I found that this is going to be very handy for us to understand what's going on behind the scenes when messages start flowing between services. So we'll do that over here. And at this point, the catalog microservice is ready to publish messages to RabbitMQ, but we don't have a RabbitMQ instance available just yet. In the next lesson, we will expand our Docker Compose file to also stand up a RabbitMQ Docker container that our catalog service can communicate with. It's time to stand up our RabbitMQ message broker. And of course, we'll use Docker for that. So here I am in Visual Studio Code. And what I'll do is I'll open our play.infra directory. So play.infra, and then I'll do code.-r. And here, I'll just go ahead and close this, close that, and I'll open our Docker Compose YAML file. And perhaps I'll collapse this. So the first thing that I'll do is I'll go ahead and remove this comment that we had at the top. And now we can go ahead and start declaring our RabbitMQ service. So just like we did with Mongo, we'll come here and we will declare a service for RabbitMQ. Let's name it RabbitMQ. And then, as usual, the first thing that we want to declare here is the image that we're going to use. That image is in this case is going to be the standard RabbitMQ image that includes also a portal to manage the RabbitMQ infrastructure. So that will be RabbitMQ management. Then we will mention the container name, the name that we're going to give to this container, and it's just going to be RabbitMQ. Then we'll go for the ports section. We're going to open 2 ports. One port for our services to communicate with RabbitMQ, and then another port for us to be able to navigate to the RabbitMQ portal. So the first port is going to be 5672, maps to the same one internally, and the other port is going to be 15672, which maps to the same port internally too. So the first one is going to be used by the services to publish messages to, or to consume messages from RabbitMQ, and the second one is going to be used to be able to go to the portal, to the RabbitMQ portal. Then we're going to go to the volume section, and we're going to declare a volume also for RabbitMQ, which is important because we don't want to be missing those messages if the RabbitMQ container goes down. So I'll just declare RabbitMQ data. And now we have to map that volume into some location in our RabbitMQ image or container. So I'll declare volumes. I will copy RabbitMQ data. And the location that you want to map inside RabbitMQ is going to be var lib RabbitMQ. And one more thing that we have to specify here, which is pretty important, is the host name. So host name, and we will give it the value of RabbitMQ. So this one here is pretty important because this is associated to how RabbitMQ stores data internally. And if you don't specify it, then it gets a random value. And then each time we restart the container, RabbitMQ would store data in a different place, which is not going to help us really a lot. So keep in mind, you always want to specify here. It doesn't matter what value you use here, but you have to specify some value. Okay, so with that done, I'll do Ctrl S to save this file. And then I'll open the terminal. And it's time to start this container via docker compose up-d. Hit enter. And since this is the first time that I'm pulling in the RabbitMQ image, so you have to download it to my machine. Like I said, next time it will be faster. So yeah, now we have RabbitMQ up and running over here. And with that, we can start trying this out. So I'll go back to our catalog project. And here we're going to start the catalog web server, but we'll do it via .NET Run so that we can take a closer look at what's happening behind the scenes. So I have opened the terminal, Ctrl J, then I'll do src, and then I'll do catalog.service. And then let's just do .NET Run here. I'm going to collapse this also. And so a couple of things to notice here is that, MassTransit is doing its job. It's starting the bus, and then it has connected to RabbitMQ in port 5672 using the protocol AMQP. So here's where you can see the actual address of RabbitMQ in the Docker container. Like I said, this is the one port to connect to the queues. And so things are looking ready on this side. So now we'll go to Postman. And what I'll do is I'll go ahead and I will create an item in our catalog. So I'll go to our catalog API and I'll open the post one. And here I'll create some new item. Let's say this time we're going to create an antidote. So antidote, cures poison, and then price is going to be 7. And I'll hit send. So that then got created in the database. But now let's see what else happened. So if we see now here, the item got created, but also an exchange was created in RabbitMQ. So MassTransit created this exchange in RabbitMQ for us. That's one of the nice things about MassTransit, so we don't have to create it manually. And it got the name play catalog contracts, and then the name would be catalog item created. So an exchange will be created for each of the messages that we publish from catalog. And you can see that after creating the exchange, it also sent the message to that exchange. The message was sent over there. And so if you want to see how this looks like in RabbitMQ, actually, we can go ahead and check out the RabbitMQ portal. So let's open that portal now. Here we are in the browser. Let's go to localhost 15672 is the place. And here we're going to use just the default username and password for RabbitMQ. So that's going to be guest, and it's exactly the same password, just guest, login. And in this UI, you can see a bunch of things, but really the one thing that I wanted to show you now is the exchanges. And as you can see, there is a exchange created here, catalog item created, and is of type fan out, meaning that anybody listening to this exchange will be able to get the messages. And then catalog item created, I'll go in there, and then there's not much to see here because the exchange just takes messages from one place to the other. It's not going to store the messages. And then as you can see, the exchange right here in binding section, it is not connected to any, it doesn't have any bindings just yet. And that's because we don't have a consumer of these messages yet, which is going to be inventory. And but it's not there yet, so the queue has not been created. And so there's no destination for these messages just yet. And so at this point, we are able to publish messages from our catalog service anytime our items database is updated. So in the next lesson, we will generalize some of the code that we have added here into our common library in preparation for having inventory start consuming the published messages. Let's move the code that configures MassTransit and RabbitMQ into our common library so that things get easier and cleaner for catalog and any future microservices. So here I am back in our catalog project, and I'll start by going to our settings folder, and I will copy our RabbitMQ settings file, copy that, and then I'll switch to our common project, our common library. I'll open our settings folder and I'll paste the copied class. And I'll grab the namespace from some other of our settings classes. I'll just fix that namespace here. Save. And now before adding the MassTransit classes, let's bring in the NuGet packages that we're going to need over here. So I'll do Ctrl J. Let's go into source, rated common, and let's add the same NuGet packages that we already added into catalog. So .NET add package, MassTransit.ASP.NET Core. And then let's do MassTransit.RabbitMQ. All right. So with that done, let's go ahead and create a new folder. Let's call it MassTransit. And perhaps let's close this terminal for now. And just like we did with MongoDB, let's add an extensions file here, where we're going to add our handy extension method. So let's first declare a namespace. Rated common .MassTransit. And now let's create our class. This should be a static class. And now we'll bring in our extension method. So this is going to be public static iService collection add MassTransit with RabbitMQ. So that way we can do all the registration for MassTransit and RabbitMQ in one location. Let's add the missing namespace and let's extend iService collection services. And here is where we're going to bring that code from the catalog service. So I'm going back to catalog, into the startup class, scrolling down, I'll copy these lines, copy that into common, and I'll paste them over here. And now let's start fixing all these missing namespaces. So at MassTransit, we need to import using MassTransit. And then for RabbitMQ settings, we'll need to import play.common.settings. Kvat case endpoint name formatter will need MassTransit.definition. Okay, and just as before, we also will need an actual instance of the configuration class and an instance of our service settings class. Now these are very similar to what we did in MongoDB. So let's see if we can get something from there. So MongoDB extensions. Let's see. Let's grab these two lines. Let's close this and into this spot there. And let me collapse this navigation pane now. So here we also need an import for iConfiguration. Let's grab that, extensions configuration. And you can notice that there's no service provider variable available here. However, we do have a service provider, and that is this context class that's over here. This iBus registration context is actually a service provider. So we'll use that as the class that can give us an instance of iConfiguration. We can also fix this other configuration member here. And let's also rename this X variable here to something more meaningful. Let's name it configure. And since we are here, one more thing that we can do is to perform the consumers registration. The consumers are the classes that are in charge of consuming messages from the RabbitMQ message queues. We have not created these classes just yet for catalog because catalog is not consuming but just publishing messages, but we will create these classes in inventory. So since inventory will be using this method, we might as well just add that registration over here. So I'll open a couple of lines here. And what I'll do is I'll just say configure.add consumers. And there's a few ways to register consumers. The way we're going to do it is that we're going to specify the assembly that should have all the consumers already defined. And that's going to be the entry assembly for whichever microservice is invoking this class. So to get that, we're going to say assembly, and we need another import here using system reflection that get entry assembly, and that should do it. Okay, so any consumer classes that are in that assembly will be registered by this method. And finally, let's go ahead and return our services instance to complete this method. Okay, so with that, let's make sure everything is building. So I'll do Ctrl+Shift+B. And yep, everything builds just fine. And now let's go ahead and package all these new changes into a new version of our NuGet package. So let's go back into our PowerShell terminal, and perhaps I'll clean this. And just like we did before, we're going to do .NET pack. But this time we're going to specify a version. Last time we didn't do it, and that generated version 1.0.0 for package. This time we need to increase the version so that our consumers can actually notice that there's something new available in the package. So to specify a version, what you can do is use the -p parameter, and then you specify package version, and then you specify the version. So I'll say 1.0.1. And then just like before, we'll specify an output directory. It's going to be the same location as before. Packages, enter. And we got a new NuGet package created right there. So now let's go back to our catalog project and start taking advantage of this package. And first thing I'll do is I'll delete our settings directory once again. We don't need it. Get rid of it. Then I'll go to our project file. And since we're bringing in this NuGet package that has all the MassTransit stuff, we should not need these two references. So I'm going to get rid of them. Save. And now what I'll do is I'll just go to our play.common dependency, and I'm going to bump the version number here. This is 1.0.0, bumping it to 1.0.1. I'll hit save. This pop-up dialog shows up asking us to resolve the updated dependencies. So I'll click on restore. And that's going to bring in the updated package into catalog. So I'll close this, and I'll close that. And now it's time to update our startup class to take advantage of the new package. First, let's get rid of this unneeded import at the top. And now what we can do is just, since it's Fluent, let's expand on top of our @mongo repository. So let's just do add MassTransit with RabbitMQ. We may be missing a namespace. So we need to import play.common.MassTransit. And then that becomes the one line that we have to run to execute all this stuff that we were doing before. So I'll get rid of all these lines, save, and that should be good enough. I'll do a Ctrl+Shift+V to make sure that things are compiling. Yep, it's looking good. So let's go back, let's open a new terminal here, and let's verify that things keep working properly. So I'll go to src, oops, not into contracts, we want to go into service, and then I'll do .NET run. Yep. So yeah, we are connected. We have connected to RabbitMQ. So it's time to do something about messaging. So let's go back to Postman. And last time we had created this antidote item. And so instead of creating a new one, why not let's try an update operation. So a put. So I'm going to just copy this. And then let's go into put. And then in the body, we're going to just paste this. So it's the same antidote, curse poison, but let's say that the price is now 9. And then let's bring the ID. Hopefully it's the same ID that we used before. So I'll copy this ID into the URL for the put operation. And then I'll hit send. So we got 204, so it was a success. And now let's go back to VS Code. And yeah, just like before, the exchange was declared. And the message was sent to the exchange, as you can see. But this time we should have a new exchange. So let's go back to RabbitMQ briefly. And here, let's go now to exchanges. And as you can see, there's a new exchange here, catalog item updated. So things are working properly. And one last thing that we have to do here is to actually publish the catalog contracts as a NuGet package so that inventory can use it in the next lesson. So let's go ahead and go back to catalog. And here I am. I'm going to do Ctrl+C in my terminal so that the host stops. And then I'll switch to our play.catalog.contracts directory. And here I'll do what we did before. So .NET pack, and then output directory, packages. That should go ahead and produce our contracts package. Hit enter, and there it is. So now we have a contracts package that inventory service will be able to use to consume the messages. In the next lesson, we will update our inventory service so that it can consume the messages published by catalog. The whole point of moving inventory to using asynchronous communication is to have its own database of catalog items that it can use without ever having to get in touch with the catalog service API. Therefore, let's start by defining the entity that represents catalog items in the inventory microservice. So here I am back in our play.inventory microservice, and I'll open our entities directory. Now this new entity that we're going to create has some similarities with inventory items, so I'm actually going to start by getting a copy of inventory item. So I'll just copy this and I'll paste it right there. And let's rename this into catalog item. Catalog item, and we rename this as catalog item, which also implements iEntity. But in this case, it's not going to have most of these properties, but it's only going to reuse the ID. Now, as you remember, the catalog item has a bunch of properties in the catalog service, but here we will only introduce the properties that make sense for inventory. So in this case, this is going to be, we'll start with the name, and then we will also need description. Okay, so keep in mind that as you're bringing in these entities from other microservices, you don't have to have everything that these entities have in the other service. It's only the version that the new microservice needs. In this case, just ID, name, and description. With that done, let's go ahead and start bringing in the NuGet packages that we need for this. So I'll go to play.inventory.service csprog, and then I'll open my terminal. So let's go to src inventory service, play inventory service, and let's get a reference to our new catalog contracts NuGet package. So .NET add package, play.catalog.contracts. Remember, this has all the contracts that we can use to consume messages from catalog. Okay, with that done, let me close this. And now you can see that we have play catalog contracts here. But we also need to bump the version of play.com because remember we added some new classes in there. So I'll bump from version 1.0.0 to version 1.0.1. I'll save that. Let's go ahead and restore the new NuGet package. And now we can close this. Close these files. Now it is time to define the consumers. And like I said before, the consumers are the classes in charge of consuming the messages that have been published by any other microservice. So to define the consumers, let's go ahead and create a new folder. Let's call it consumers. And we have to create one consumer for each of the different operations that happen in catalog. So that's for creation, update, and delete of catalog items. So I'll go ahead and create a new file. Let's name this one catalog item created consumer. I'll copy the name. Let's give it a namespace. Service consumers. Okay, so this is our catalog item created consumer. And the first thing that you have to do about this consumers class is to make sure that they are actually consumers. And to do that, you have to implement the iConsumer interface, which is part of MassTransit. And I'll do control dot, so using MassTransit. And here you also have to specify what is the type of message that this consumer is going to handle. And that type of message is actually coming from the contracts that we're bringing in from catalog. So in this case, it's going to be catalog item created. See if we're missing something, using play.catalog.contracts. So then let's go ahead and implement this interface. So I'll do control dot here, implement interface. And as you can see, we just have to implement one method which is the consume method. So which is where we're going to actually perform the action of consuming the message. And so what we want to do when we consume the message is actually store it in our local catalog items database. So to do that, let's first introduce a repository that we can use for that. So I'll declare read-only iRepository of type catalog item. Okay, so this is the new entity we just introduced for catalog items in inventory. All right, see if we're missing something. Play.common for iRepository. And play.inventory service entities. And now we need to inject this repository in the constructor of this class. So let's define a constructor. So public catalog item created consumer. And so here's where the repository comes in. Okay, so let's say this.repository equals repository. Let's now go ahead and implement the consume method for this class. So I'll get rid of this, and let's first get a copy of the message. So the message that we're receiving is available in the context variable as the message property. So let's grab that copy there. And then what we want to do as we consume this message is probably first make sure that we have not consumed this already, right? We may have already consumed a message of the creation of an item with the ID that we're going to get in this message. And if we did, we already would have that into the database. So let's make sure that we don't have it. And if we do have it, let's just return. There's nothing else to do. But if we don't have it, we'll go ahead and create it. So let's see. Item is await repository .get async. And that's going to be in message dot item ID. Let's also make sure that this method is async. And then if item is not null, then we'll go ahead and return. Okay, because in this case, it happens to be that we already created this item in our local database, so why would we create it again? If not, we will say new catalog item, and then we'll say all these message.itemID, name is message.name, and description is message.description. Finally, we'll go ahead and do repository.createAsync of this item. Okay, so that's all you have to do to consume a message that represents a new item that has been created in the catalog. Like I said, we just verify if the item is already here, because it could happen in the cases where for some reason the publisher publishes the same message twice. And so we don't want to be having errors here because we already have the item in our catalog items database. So if we don't have it, we go ahead and define it and create it into our local database. Let's go ahead and do something similar for our updates. So when a catalog item has been updated. So I'll get a copy of the consumer, and let's just rename it into catalog item updated consumer. Okay, so I'll do this, and then the message is catalog item updated. Okay, so let's fix a couple of things. Constructor there. Okay, so we are consuming now catalog item updated, and here the logic is going to be a little bit different. So for an update, it could be that we already have this inventory item in our local database. So in which case we'll need to go ahead and just update the properties. Or it could be that this is the first time that we receive this the message for this item, in which case we'll go ahead and create it. So now in the case that, so first, just as before, we can go ahead and get the item, but if the item is null, so we'll change this, if item equals null, then we will go ahead and define these lines that we had over here. There. So if the item is null, we don't have it in the database, so let's go ahead and create it. Otherwise, let's just update the properties that make sense. In this case, it's going to be item.name equals message.name, and item.description equals message.description. And in this case, let's go ahead and call await repository.updateAsync item. Okay, so quick recap, for an update operation, we go ahead, find the item. If we cannot find it, we will go ahead and create it into the database. And if we find it, we update name and description and update it into the database. Now let's go ahead and implement our third consumer, which is going to be for deleted items. So again, I'll get a copy of this last consumer, paste here, and let's rename it into catalog item deleted consumer. I'll copy this name. So I'll update the name of the class, the constructor, and then let's make sure we also update the message that we're handling here. This is catalog item deleted. Here and there. And in this case, things are even easier. And so we will go ahead, we'll try to find the item, and if we cannot find it, it means that for some reason it does not exist in our local database, so there's really not much more to do in our case. So we will go ahead and just return. We don't have it, just go ahead and return. And if we have the item, then we can go ahead and say await repository remove async message.itemID. Okay, so with that, we have our three consumers defined. And now it's time to perform the proper registration in Startup. And before we can do that, let me go to app-settings.json, and we need to declare those RabbitMQ settings so that we know how to communicate to RabbitMQ. So I'll actually go back to catalog, our catalog service over here, and I'll just grab those three lines for RabbitMQ settings from app-settings.json, and then back to inventory, we will add that over here. Same thing, we're talking to localhost for RabbitMQ. Now let's go to Startup. Okay, perhaps I'll collapse this for a moment. So let's do a few things here. So as you see, we still have this logic to use the catalog client to talk to the catalog service. We will not be using this anymore, but let's keep this logic around in case you want to reference it later. But what we're going to do is we're just going to refactor it into another method so we don't have to have all this stuff hanging around here. So I just selected all this logic to use the the retries and the configuration of the client. I'll do control dot and I'll say extract method. So we'll name this method add catalog client, and I'll take this method and just send it to the end of the file so that we don't have to see it frequently. And now a couple of things that we have to do here for our new catalog items repository and MassTransit. So first, we need to introduce a new repository here for the catalog items. So I'll say add Mongo repository, catalog of catalog item. And then we need to give a new name for this new collection of items. In this case, it's going to be catalog items. Okay, so keep in mind that both of these are going to live in the same database, the same inventory database, but it's two collections, one collection for inventory items and one collection for catalog items. And then we also need to add the MassTransit registration. So I'll say add MassTransit with RabbitMQ. Let's add a missing namespace. And that's pretty much it on startup. Then let's go back to our Explorer. One more thing that I'll do is just like we did in catalog, let's flip the default log level so that we can see also what's going on regarding all these message exchanges. So I'll change this to debug. And with that, our inventory service is ready to start consuming messages. But one more thing that I'd like to do is to actually clean up our databases. And I'll like to do this because at this point, we do have some data, both in inventory and in catalog side, but that data has never been synchronized at all. So it will be better to just start clean in a situation where both sides are actually synchronized from the start. So I'll go back to MongoDB, the MongoDB extension. I'll expand this. And as you can see, we do have the catalog and inventory databases. So to clean them up, I'll just right click and say drop database. I'll drop catalog. And then I'll drop inventory. You may choose to not delete them, but that could cause issues as you start moving forward. So it's better to just start clean in this case. At this point, I'll start our microservices. So I'll do Ctrl-J to open the terminal. I'll go to my terminal. And perhaps I'll do clean. And just so that we can see things better, what I'll do is I'll collapse this and I'll bring in yet another terminal with the split terminal button here so that we can see services in both sides. So perhaps what I'll do is I'll switch to a catalog on the left side. So I'll go to play that catalog and then play catalog service. And on the right side, I'll stay in inventory. So I'll do play inventory service. Okay, so let's clean both sides. And now we can start both services. I'll do .NET run both sides. And now notice in the right side that a few new things are happening. And perhaps I'll move this around a little bit. And yeah, it may be a bit hard to see, but exchanges has been declared for the consumers that we declared here. You can see we have exchanges for a catalog item created, updated, and deleted. And if we scroll down a little bit, let's see. These exchanges are now connected to the queues. So you can see that this exchange is now connected to our new inventory catalog item updated queue, same for created and deleted. And the consumers are reporting that they are okay. So they're ready to start consuming messages. Okay, so let's move this over here. So now let's see this in action. So let's go to Postman. And what I'll do is I'll start by creating a brand new item. So I'll go to our post item API in play catalog service, body. And let's define our classic potion example again. So let's say potion stores a small amount of HP and the price is going to be 5. I'll go ahead and hit send. The item has been created. And then let's go back to our terminals and see what happened. So as you can see on the left side, the exchange was declared, catalog item created, and the message was sent, right? So catalog item created was sent. And then on the right side, we can see that now we actually received the message. and that was handled by the catalog item created consumer. So if things went correctly, we should now have a copy of the catalog item in our local catalog items collection in the inventory side, inventory database. So let's go to MongoDB. And let's see what we have. So I'll expand this. So we have the catalog database with this item created here. And then we'll expand inventory. And then you can see that we do have now our catalog items collection with that item created over here. So the item has been replicated from catalog into inventory. We can now take a look also the activity that happened in RabbitMQ. So let me go to the RabbitMQ portal over here. And let's take a look at exchanges. So see that we now have the 3 exchanges for catalog item created, deleted, and updated from the catalog side. And then also the exchanges from the inventory side. Created, deleted, and updated. And then if we go to queues, you can see that now we have the 3 queues for the 3 types of events. And if we go to catalog item created, we could see here any activity that goes across this queue. Now the item has been already consumed, so there's not much to see here. But let's see what happens in a case where, let's say that our catalog service is not running, right? So actually our inventory service is not running. So our catalog service publishes some message, but inventory is not running. Now that the queue is up and running, things are going to work in a bit of a different way. So let's go back to inventory. And I'm going to stop the terminal on the right side. Just going to do Ctrl+C. Inventory is stopped now. And let's go back to Postman and create yet another item. So I'll create an antidote, which cures poison, and price is going to be 7. So I'll go ahead and post this. And then if we go back to RabbitMQ, let's see, catalog item created. You can see that now there is one item in the queue, as reflected by this. As you can see, it's one item, which is waiting to be consumed by somebody. So here is where the nice thing about asynchronous communication starts happening. So there's no need for catalog to be up and running all the time. Inventory can nicely just keep publishing these updates to their items, and then whenever inventory comes back, it should be able to consume the message. And in fact, let's go back to our terminals over here. You can see that the catalog item was created on the left side. And now let's go ahead and start a terminal on the right side. Let me collapse this once again. Okay, so on the right side, I'm going to do .NET run again. And then you can see that right away, inventory is able to consume the new message. So the databases should be in sync again. We can see that there's no more messages here waiting. The message was consumed. And our databases should be once again in sync. Let me refresh this. So yeah, we have 2 documents here, and we have 2 documents over there. So things are in sync. So our inventories microservice now have a nice way to stay in sync with any updates to the items managed by the catalog microservice. In the next lesson, we will update inventory so that it starts taking advantage of this new capability anytime it needs to present data that is partially coming from catalog. Now that our inventory microservice has its own copy of the catalog items, it no longer needs to query the catalog microservice to gather additional information about the items of inventory. So let's update our inventory controller to take advantage of its new catalog items collection. So here we're back in our inventory project, and I'll go ahead and open our controllers folder, and I'll go to items controller. Let's collapse the navigation pane to get more space, and let me scroll down a little bit. And the first thing that we'll do is to get rid of our catalog client, because we will no longer need to invoke the catalog service anymore. Instead of that, we're going to declare another variable here, which is going to be just another iRepository. But in this case, it's going to be of catalog item. So this is going to be our catalog items repository. As we're introducing this new repository, let's also rename the previous one so that it better resembles its purpose. So this is going to be our inventory items repository. Let's also rename this the variables in constructor. So this items repository becomes inventory items repository, And then it's time to inject also our new catalog items repository as opposed to the catalog client. Here we will capture that. So with that, let's go down into our getAsync method. And here's what we're going to do. The first thing is that we definitely don't need to call catalog client anymore. So we're going to get rid of this. We still need to get the list of all the inventory item entities that represent the items in the user's inventory. So this stays. But after that, what we want to get is from our local catalog items collection, we want to get all the corresponding catalog items that, the ones that correspond to the inventory items on inventory, to the items on inventory. So to get that, let's first get all the list of all the catalog item IDs that are involved in the inventory items collection that we have here. So to do that, let's do this. So item IDs equals inventory item entities, select, let's do a little projection here, where item.catalog item ID. Those gives us the list of all the catalog items that we have in inventory, the IDs specifically. And with that, we can go ahead and get the actual catalog items. So let's do catalog item entities is await catalog items repository, get all async, where item. And here what we're going to say is that we want to get all the items that are in the item IDs collection. So I'm going to say item IDs contains item.id. So now here we have all the catalog items that match the items that we have in inventory for the current user. Having that, we can go ahead and update this little function here so that I take advantages of this new items collection. So now I'll say catalog item entities is going to go here. So now we can go ahead and say, okay, so as we go through all the inventory items, first we're going to look at the catalog item entities, and we're going to find the catalog item whose ID matches the ID of the catalog item ID of the inventory that we're looking at. So that's the catalog item. And then we'll keep moving forward as usual. And we say, okay, so now that we found the inventory item, and now that we have the catalog item, let's go ahead and turn it into a DTO, adding the catalog item name and the catalog item description. Okay, so I don't think we need to make more changes to post async. So we should be ready to start using this. So I'll save this. I'll go back to catalog. I'll just going to hit F5 to start the service. And I'll go back to inventory, and I'll do the same, F5 to start the service. And now let's go ahead and go back to Postman, and let's grant one item to our user. So the first thing that we'll do is actually get the list of current items in our catalog to know what to grant. So I'll just open our get operation in the catalog service, and I'll hit send. Here we are. We have currently a potion and an antidote. So let's say we want to do the potion. So I'll copy the ID of the potion. And now let's go to the inventory collection. Let's expand this, and I'll go to our post operation where we can assign one item to a user. So I'll go to body. I'll paste the catalog item ID that we just copied over here. So this is the item to assign. And then just like before, we need a user ID. So just as we did before, let's use a Postman function, GUID, to generate a random user ID. And finally, let's get some quantity. Let's say we're going to assign one potion to this user. Okay. And so with that, I'll go ahead and post that, send. And it's done. And if it worked, now our user should have one potion, right? So I'll go ahead, and first we need to figure out what's the ID of the user that was generated. And we can do that from the console. So I'll click on the console, and I'll go down to our post operation, request body, and it's right here. This is the user ID that was generated. I'll copy that, close console, and then we can go to our get operation to get all the users in the all the items in the user's inventory. And so we'll get the items for this user. I'll hit send. And as you can see, now we can see that this user has a potion, has one potion, but more interestingly, it is able to show the name and the description of the potion from the local catalog items collection. So it no longer needed to go ahead and talk to the catalog microservice to retrieve the additional information. So things are much more resilient and faster now because we don't need to go out and ask for this additional info. Now, what would happen if we go ahead and update the description of this catalog item in the catalog microservice? How would that look like here? Let's try that out. So first, I'll go back to our get items results, and I'll copy a few details about the potion. I'll just copy that, and then I'll go to the catalog collection, and I'll go to the put operation. Here's where we can make updates to our item. So I'll just come here, paste that, fix indentation, and let's say that instead of having this description, it just says restores some HP. That's going to be the new description. Also, the ID of this item is this one here. So let me grab it, go back to put, I'll paste that here. And so let's go ahead and update this item in the catalog microservice. So I'll go ahead and do that. And then I'll go back to our query for the inventory items of the user, and let's see what happens with the description of this item. So I'll hit send, and as you can see, the description is already updated. And this is because as soon as we updated the item in catalog microservice, a message was published into RabbitMQ, and then our inventory service grabbed that update into its local database and is ready to present the updated description as we query for items. So this is great. But now, what would happen if our catalog microservice is having issues? Actually, what happens if it's completely down, right? So it has a major problem. What would happen with an inventory microservice? Can it still keep working just fine? Let's see. I'll go back to catalog. Here's catalog. I'm just going to stop the service. So the service is completely down. And in fact, if we go back to Postman and we try to get items again, let's see what happens. Yep, connection refused because the service is completely down. But then let's try to get all the items on the user's inventory. So I'll hit send, and it still works. Even more, I can try granting yet another item to the user's inventory. So just to test this out, I'm going to start catalog once again, hit F5, back to Postman. Let's go ahead and get the list of items. And now I'm going to grant the antidote to that same user. So let's do antidote into the post operation body. So let's grant the antidote. Let's make sure we use the same user ID. It's right here. The user ID. And then again, like I said, catalog is having problems. I'll just stop it. It's completely down. It's not working. Yet I'm going to go ahead and grant an item to the user. I'll hit send. 200 OK, so it looks like it was successful. And then let's get all the items in inventory now. So I'll hit send again over here. And as you can see, we can query for all the items, and all the items are showing name and description, regardless of the fact that the catalog microservice is completely down. So this is the power of asynchronous communication, and this is how you enable very resilient communication between microservices. Both services are now really autonomous because they don't rely on each other to be available at any given time. One more thing to consider is the case where one of our consumers is not able to consume the message properly, perhaps due to some issue when trying to talk to its local database. So for instance, let's go to our inventory service over here, and I'm going to stop this for now and close terminal. And I'll go here into our consumers, let's say catalog item created consumer, and what would happen if this line here is having trouble, right? So when we go into the consumer, all this logic happens because we are consuming the message. But if we fail, if an exception is thrown in this case, the message is going to be sent into some error queue, and you will not be able to consume it anymore. So at that point, you missed an update from the catalog microservice. So is there a good way to handle this? So it turns to be that, yeah, there's a way to do that. So if you go back to our common library, so here we are back in common library. I'm going to go to the MassTransit extension that we created before and scroll down a bit. And what we can do is to enable, and I'll close this, we can do is enable message retries for the consumption of the messages. So you can go here and say configurator that use message retry, and then here we're going to define our retry configurator. Okay, let's open this section. And then you can say retry configurator that interval. And then the first item, the first parameter you're going to specify is how many times you want to retry. So anytime the consumer is not able to consume the message, how many times you want to retry that consumption. So let's say we want to say 3. And then you have to specify the time span or our time between retries. Let's say that's going to be time span. Let's import missing namespace from seconds, and that's going to be 5 seconds. Let's also import another missing namespace. We need to use using green pipes here, and that's all it is. So with that logic, anytime a message is not able to be consumed by the consumer, it will be retried 3 times, and with a 5 seconds delay in there. And there's a bunch of different ways to configure this depending on how you want to do your retries. And with that, let's just save extensions. And then if you wanted to consume this in your microservices, as usual, you will go ahead and generate another version of the NuGet package. So in this case, it would be, you would just do .NET pack. It would be package version. Let's say in this case would be 102. And then we send it to the same location as before. Packages, package generated, and then you would just go back to catalog and update its version over here to play.common 102, save, restore dependencies, and then we would go back to inventory and do the same thing, 102, save. And then we'll not exercise this really in this lesson and restore, but that's how you do it. So from here on, both microservices have this capability to retry the consumption of the messages. So that marks the end of this lesson and of this model. You now have 2 independent and resilient microservices that can collaborate asynchronously to manage a catalog of items and to grant and query for items in a user's inventory bag. You also have a reusable common library that any of your future microservices can take advantage of and that you can keep improving according to your needs. In this model, you will connect the provided front-end project to your microservices to enable basic end-to-end scenarios from a modern single-page application. By the end of this model, you will have a solid understanding of the following: how to get and build the front-end project in your box, how to host the front-end project in a Node.js server, what is the structure of the React-based front-end, what is CORS and how to configure it in your microservices, and how to debug the communication between the front-end and your microservices. In this lesson, you will install Node.js, which is a JavaScript runtime that will host the front-end portal, and that also includes npm, the package manager that provides all the dependencies required by the portal. The only additional tool required to build and launch the front-end portal is Node.js, which you can get in the Node.js.org website. Let's see how to install Node.js and verify the installation afterwards. Before installing Node.js, just keep in mind that the pages that you will see next will likely look a bit different depending on your operating system and the versions available at the time that you're taking this course. But regardless, the overall download and installation process should be mostly the same. So let's now browse to the Node.js website. And here, the first thing that you're going to see is right away a few download buttons for your current operating system version and architecture. In my case, that will be for Windows 10 x64. These are the 2 versions. The one on the left is the most stable version available, and the one on the right is the latest version available, which may not be the most stable one, but has the latest features. I would recommend going for the most stable version, the LTS version, since that's a recommended one for most users. Now, if the version that you would like to download is not here, you can always go to the other downloads link over here. And here you can pick the right version for your operating system. And you also have a few other download options. Now, in my case, I'm going to go back to the first page, and I'm going to download 14.17.0 LTS. So I'll just click there. And now I'll go ahead and start the installer. So I'll click here. Here's the installer. So I'll just click next, accept, next, next, and next. And at least for this course, I have not seen the need to install any additional tools here. So I'll just click next and install to get installation started. Say yes. And so with that, Node.js is installed in the box. So I'll click finish. And what we want to do now is to verify that the installation has completed properly. So what I'll do is I'll just close the browser now, and I'll open my Visual Studio Code instance here. And here in Visual Studio Code, what I'll do is I'll open my terminal by pressing Ctrl J. And I'll just type a couple of commands to verify that the tools are installed properly. So I'll just type node-v to get the version of Node.js, which you can see right there, 14.17.0. And now also verify the version of npm, which is the package manager that comes with Node.js. So I'll do npm-v, and I can see the version right there also. So with this, we know that Node.js has been properly installed and we're ready to move on. In this lesson, you will explore the structure of the front-end code base, how to install its dependencies, and how to build and run the portal. Before exploring the front-end code base, let me give you a few details about it. The front-end is a simple, single-page application that demonstrates one way to interact with all the play economy microservices. A single-page application is a web application that dynamically rewrites the current web page with new data from a server, instead of constantly loading new pages. It is built using React, which is a JavaScript library for building interactive user interfaces. I chose React because at the time of creating the course, it was one of the most popular front-end frameworks and is easy to learn, assuming that you have worked with JavaScript before. It uses Create React App to simplify how you do local development, how you build and debug the code in your box, and how you package everything in preparation for deployment. Finally, it is hosted in a Node.js server, a very popular runtime for JavaScript applications. There are a few things that I'd like you to keep in mind as you work with the provided front-end portal in this and the next lessons. This is not a course about front-end development, and certainly not about React. As a back-end developer myself, I only know enough React to build this simple portal. However, I'm probably making lots of beginner mistakes, and I'm probably not following client-side best practices in many places. So please don't use this code as a template for the production level application, but more as a basic example of one way you could interact with the microservices from a modern client. You won't be coding this front end in this course. There is both not enough time, and I'm not qualified to teach you how to build a front end step by step. Instead, I'm providing you the finished portal so you can use it as is. It should work with no issues and no changes required, provided that you make a small update to the microservices, as I'll explain in the next lesson. In this lesson, I'll give you a quick overview of the structure of the front-end code base, with a focus on the areas that interact with your microservices, as opposed to the many components that handle layout, rendering, and many other things. Finally, please check out the links below if you would like to know more about the tech used in the front-end project. So here I am in a new Visual Studio Code instance, and I have already opened my terminal into the projects directory where I have all my files. And as you can see, I have already downloaded and extracted the front-end project files into this directory, play.frontend. And what I'm going to do now is just switch to that directory. And I'm going to open this instance of code into that directory by doing code.in-r to reuse the window, enter. And here you can see the structure of the project files on the left side. And what I'm going to do is first close this terminal for a moment. I'd like to point you to the readme.md file. So this is a file that will give you a description of what this project is about and a few other things. And in fact, what you can do is just open this preview window with this button that opens a preview on the right side. I'll close the original one. So this gives you a nice view of the README file. So as you can see, this describes the project. It describes the prerequisites of the project. And then it tells you how to build the project, how to run it locally. And also it provides a bunch of other scripts that are also available. Now, what we're going to do is to actually follow these couple of first lines in this file to get started with the frontend. So as it says, what you can do to install all the dependencies of this frontend is run just npm install. So I'll open my terminal once again. Right here, scroll down a bit. And what you want to type just at the root of this project is npm install. Hit enter. What this is going to do is to bring in a bunch of node models that represent all the dependencies that this portal depends on, including React, Bootstrap, and a bunch of other things. This is going to take a while depending on your internet speed because there's a lot of stuff that needs to get downloaded. So just give it a moment. Okay, so the dependencies have been installed, and as you can see, there's now a node models folder on the left side. If you expand it, you're going to find a bunch of directories have been created. Right? So now that we have that, we are ready to run the portal. So to do that, if you scroll down in the README, you can see that you can just do npm start, and that's what I'm going to do here. Npm start, enter. So this is going to compile the entire code base, and then it's going to start the Node.js host. Okay, so it compiles successfully, and as you can see, we get an address here to browse locally to it. So I'm going to copy this address, localhost 3000, and I'm going to go to my browser. I'm going to paste that there and hit enter. And there it is. The portal is up and running in this box. Now in the home page here, what we have is just a few basic things like the description of the project, and then a couple of links, both to go to the catalog section to get the list of the catalog items, and the inventory section so that you can inspect which are the items that are in the inventory bag of a user. Notice that we also have a navigation bar at the top that takes you either to the home or to the catalog and inventory sections. There's also links here to go to the RabbitMQ portal if you wanted to explore what's going on with the queues. And there's also links here to explore the Swagger UI OpenAPI documentation for both catalog and inventory service. And also a few other things, general links to the different technologies that were used to create the whole system. Now, before we go and dive into the catalog and inventory sections, which are, of course, the most important parts of this portal at this point, let's go back to Visual Studio Code for a moment. And let's explore briefly the files that are available here, just so that you get an idea of how this project is structured. So what I'm going to do is just close this terminal for now and close the README. And the first file that I'm going to show you is package.json. This one here describes all dependencies of this project, which are all the node models that are installed by now. And like I said, these include things like React, being used for all the components, interactive and dynamic components used across the portal, Bootstrap for layout, and a bunch of things for being able to do routes in the client side, the React scripts, which are the ones that we can use to start the portal, and a few other things. And yeah, many other dependencies. Now let me close this, and then take a look at the public folder here. This one is the one that defines index.html, which is what we call the page template. So in a single page application, like I think I mentioned before, there's not really a navigation into different pages of a portal. There's no reload of pages. There's just one page, in this case, index.html, where all of these dynamic components are loaded and refreshed constantly. And in fact, in this section here, in this div, root, here is where all the JavaScript files or JavaScript content is injected with all the React components. Now this file also references config.js, which happens to be over here. And this is a file where if you're asking where is the addresses of all the microservices, this is the file. So this is where you're going to see the address of the catalog microservice and the address of the inventory microservice right there, as well as the address of the RabbitMQ portal and a few other derived addresses for the items APIs in catalog and inventory. Now the most important directory actually here is the source directory, because this is the one that contains all the React components. So this is pretty much is the heart of the project. This is where the system logic happens. And in this file, if you go to index.js, this is the root where we start rendering React components, and we are asking it to start rendering them in the root div that we just saw in the HTML. This one here, we saw that there's a root div, and that root div is where index.js will get rendered, as you can see right here. And so the first React component that we actually start rendering is this app component over here, which is coming from app.js. This app component defines our app by using first the layout component, which is in charge of rendering the basic layout of the system. As you can see over here, if you expand components, layout.js, this is the one that defines the navigation menu at the top, the container for all the other components in the middle, and then the footer at the bottom. Back to app.js. As you can see, we have layout, and layout defines that inside of layout, we're going to have a component for the home, a component for the catalog, and a component for inventory. So then if we just go into the components directory, we have our catalog file, and this is the one where you can start really seeing interesting things, because this file allows you to communicate to the catalog microservice. If you go down into the populate items method over here, you can see that here is where we are actually talking to the catalog microservice, and then we're getting a response from it, and that's the one that we are collecting and setting it into the client-side state that later on, if you see at the bottom, is being rendered as a list, as a table into the page. Okay, and it's the same idea with the inventory.js, which is able to render the items in the inventory bag of a user. We also have a few model files and form files like item model, which is the one that is used to render the model dialog. So you can go ahead and either create or update an item, and the item form, which is the one that actually shows the form inside that model. And the same way, we have a model for granting items for a user so that it can go into his inventory bag. So a model and a form for that same purpose. And lastly, we have the .vs Code folder, which you should be very familiar with at this point, where we also have a launch.json file, where we define different configurations that you can use to start debugging either the server side or the client side of this portal. So you can see we have a configuration for the server. We have named it server. This is going to be the one that can launch the npm server or the Node.js server, and one configuration for launching the client at the location of the client in the browser. There's also a compound configuration, which I named server client, that can be used to launch both the server and the client at the same time in your local box. Okay, so I'll just close this. So now let's go ahead and try that catalog section. So I'm going to open the terminal once again here. So our frontend is still running, but what we may not be running right now is the catalog service. So let me go back to catalog, Here's my catalog code base. So I'll just switch to src, play.catalog service, and then I'll do .NET run. So catalog is now up and running. So let's go back to the portal, the browser. And in order to see the list of catalog items, what you can do is either click in catalog in the navigation bar over there, or you can click in this catalog link right here. And I'll click on it. And this should display the list of catalog items, but as you can see, that is not working right now. So we cannot load the items. So there's some problem happening here. And so on the client side, one way that you can tell what's going on is by using the browser developer tools, which usually you can go to by pressing the F12 key, which I'm going to do now, F12. And this opens the developer tools section. Now on this one, there's a bunch of tabs, but the one that you're interested in is in the console tab. So click on console, and this is going to show you what's going on. So as you can see, there's an error, access to fetch at HTTPS localhost 5001 items, which is the address of the catalog microservice, from the origin HTTP localhost 3000, which is the address of this of the frontend, has been blocked by CORS, the CORS policy. So no access control allowed origin header is present in the request resource. So what is this CORS thing about? That is going to be actually the focus of the next lesson. So in the next lesson, we will learn about cross-origin resource sharing, also named as CORS, and how it can help us enable the communication between the front end and our microservices. In this lesson, you will learn about cross-origin resource sharing, also known as CORS, what problem it solves, and how it can help us enable the communication between our front-end portal and our microservices. To understand CORS, let's first understand what a cross-origin request is. Let's put our catalog microservice to the side for a moment, and let's imagine that the Node.js web server that is hosting our front end is also the server that hosts the REST APIs to interact with the Mongo database that owns the catalog data. In this scenario, the browser initially navigates to the web server URL to load the front-end homepage. And then, when the catalog section is requested, the browser makes a GET request to the catalog REST API to the same web server URL, to which the server will reply with a JSON representation of the catalog data. The address from which the browser calls the REST API is known as the origin, and is made of the combination of protocol, host, and port, which in this case is HTTP localhost 3000. Notice how the origin in the browser matches exactly the origin of the server that provides the REST API. Let's now go back to our actual scenario, where our catalog microservice hosted in ASP.NET Core's Kestrel web server is the one providing the REST API. Now, when the catalog section is requested in the browser makes a GET request to the REST API at the origin of the catalog microservice, which is HTTPS localhost 5001. Since both the protocol and port of the catalog microservice are different than the one in the browser, this is known as a cross-origin request. The microservice will return the catalog data just as before. But by now, the browser knows that this response comes from a different origin, since it had set the origin header in the request. Therefore, it rejects the response data with a CORS error. This happens because browsers follow what is known as the same origin policy, which states that a web application can only request resources from the same origin the application was loaded from. Browsers enforce this to prevent malicious websites from reading confidential information from other websites. Unfortunately, this is also preventing our front end from reaching the catalog microservice. So how can we fix this? Here's where CORS comes into place. CORS allows a server to indicate any other origins than its own from which a browser should permit loading of resources. Here's how it works. Once again, the browser has loaded the front-end page. Now, the catalog section is requested and a GET request is sent to the catalog microservice. And since catalog is hosted in a different origin, the browser appends the origin header. The difference this time is that the catalog microservice has been configured with the access control allow origin header, which indicates all the other origins that are allowed to call the REST API. In this case, this header has been configured with the origin where the front end is hosted, HTTP localhost 3000. Once catalog sends the item's data back to the browser, it appends this header to the response. The browser now compares the value in the origin header it sent to the value in the received access control allow origin header. Since they match, the browser now allows the response data to reach the front end. This works for simple requests like gets, but for post, put, and other methods, things work a bit differently. When a cross-origin request may perform some sort of write operation on the resources owned by the server, like is the case when performing a post, put, or delete request, the request needs to be first pre-flighted. This means that an additional initial request needs to be sent to the server to determine if the actual request is safe to send. Going back to our scenario, imagine we now want to create a new item in the catalog, and therefore our front end will send a post request to the REST API. However, since this is a post of JSON data across origins, the browser automatically sends first a request with the options method. This time not just adding the origin header, but also two other headers called access control request headers and access control request method. Access control request method indicates that when the actual request is sent, it will be a post. And access control request headers tells the server that the request will come with a content type header, in this case. The server should have been configured to respond with corresponding headers to indicate what it allows. The headers returned by the server are access control allow origin, access control allow headers, and access control allow methods. If the values returned in these headers match the values in the headers sent in the request, the browser accepts the post request and submits this original request to the server with the JSON payload of the new item to create. The catalog microservice creates the item and returns the expected 201 status code. As you can see, the key to a successful cross-origin request is in the appropriate course configuration on the microservice that exposes the REST API, since only the microservice can declare the allowed origins. But how do we properly configure cores in ASP.NET Core? That's the focus of the next lesson, where we will add the missing course configuration to both the catalog and inventory microservices. Let's now fix the course-related errors we are getting in the browser by configuring the course middleware in the request pipeline of our microservices. And let's start with the catalog microservice. So I have the catalog codebase open here in Visual Studio Code, and what I'm going to do is open app-settings.development.json first. Here I'm going to declare the origin of the front end so that we can properly configure it in startup later. I'm using app-settings.development.json and not app-settings.json because the origin of the front end is just a development server at this point, and we will not need a course policy for that origin in production. So what I'll do is I'll just open another section here. This is just going to say allowed origin, and that's going to be the address of our front end. So this is HTTP localhost 3000. Now that we have that, let's go into our startup file. And here's where I'm going to collapse the Explorer for a moment. Let's scroll down a bit. And what I'm going to do is define first a constant to represent the name of that setting that we just created. So this is going to be private const string allowed origin setting is going to be the name that we just created over here. I'm going to copy it, allowed origin, right there. And now that we have that, we can actually configure cores. So to configure cores, what you want to do is go down into the configure method, which is where you configure the request processing pipeline. And so, like I said, this is mostly for development scenario at this point, because the front end is a development web server. So what I'm going to do is take advantage of this m.isDevelopment section, which only happens for development scenarios. And I'm going to add another piece over here. So I'm going to say app.useCores. And here we're going to provide the function that configures the course configuration. So I'll do builder, and I'll do this. And then we're going to say builder dot with origins. And here's where we're going to specify that origin, which at this point comes from the configuration data. So it's going to be configuration. And here we're going to pick the right key from the configuration, which in this case is allowed origin setting. So remember that this configuration is the configuration object that has been declared here, right here, configuration object, which is populated automatically by the ASP.NET Core runtime. So that configuration object contains all the data at this point of app settings.json and app settings.development.json, including the allowed origin setting. So you can use this to just go ahead and get the key that corresponds to the allowed origin setting that we just declared. So configuration, and then allowed origin setting. So that allows the origin, but we also have to tell it which headers and which methods are allowed from the client side. So to do that, what I'm going to do is just say dot allow any header to allow any of the headers that the client wants to send. And we will say allow any method to allow any of the methods used from the client side, including get, post, put, and all these other verbs. Okay. So with that, we have allowed the front-end origin, and we have said any header and any method should be allowed. Okay, so with that, we should be able to properly invoke the methods in the microservice from the client side. So let me open up my terminal once again, and I'll do .NET run. And then I'll go back to the browser, where, as you remember last time, we did have this course error. So now I'll just refresh the page. And as you can see, things are loading properly. And in fact, if we inspect briefly the network section here, and we inspect the items request that we made right here, you can see that the browser did send the origin header in the request for localhost 3000, and the catalog microservice responded with the access control allow origin header over there, which is why the browser allowed the response. So that's how you configure cores. And since we did this for the catalog microservice, we should do the same thing for the inventory microservice. So let me go back now to our inventory code base, which I have opened here in this other Visual Studio Code instance. And I'm going to do just pretty much the same thing that we just did. So here, and in fact, I'm going to copy a few sections here. So from catalog, I'm going to close the terminal for a moment. I'm just going to copy this allow origin section into inventory, allowed origin. Then back to catalog, I'm going to copy the allowed origin setting from startup. Back into inventory, in startup, at the top, I'm going to place that constant. And then finally, back to catalog, into the configure section, I'm going to copy the use course section here, and back into inventory. I'll collapse this for a moment. In configure, I'm going to add this right there. Okay, so this enables the same configuration for inventory as the one that we have in catalog. So both microservices are properly configured now. So in the next lesson, we will explore in more detail all the scenarios enabled in the front end and how its React components are interacting with the microservices. Let's now explore in more detail all the scenarios enabled in the front end and how its different React components are interacting with the catalog and inventory microservices. So I have stopped all the web servers at this point, both for microservices and for the front end. They're all stopped because I want to restart them in debug mode. That way we can jump from client to server and see line by line what's going on. So here I am in the catalog microservice codebase, and I'm just going to go ahead and hit F5 to start the web server, and then I'll go to the inventory microservice code instance, and I'll do the same thing, F5. Okay, and now I'll go to our front end, And in this case, instead of typing npm start from the terminal, I'll take advantage of the debug configuration that we have set here. So I'll go to the run and debug section on the activity pane there. And as you can see, we have a few options here. We can debug either server, client, or server client. Server client is the one that I'm actually going to pick so that both the client and the server are started at the same time. So I'll click there. And this is going to bring up the browser right away. However, it may take a while to load while the server is compiling the source code and starting the Node.js server. If we head back here, you can see that the server is getting started, but it may take a while to start. Okay, so as you can see, the server has compiled the source code properly, and it has started a debugging session of the front end in localhost 3000. So now we can go back to the browser, and here we can go ahead and navigate into the catalog section. So I just click there, and then things are loading properly. But how is this communication from the client happening to the server side? So to understand that, what we can do is just head back to play the front end. And what I'll do is I'll open my Explorer on the left side, and I'll collapse the terminal for a moment. And then I'll go into src, components, catalog.js. I'll collapse that. So here, the communication happens in this populate items method over there. First, we call the fetch function, where we talk to the URL of the catalog items API. So I'll talk to the catalog microservice, and then we get a response back from it. The response will tell us the status code if we wanted to inspect that. But this is actually a promise in the JavaScript land. Is called a promise, which means that we will have to invoke the JSON method to actually get the items in this other .10 that we can then take and then put into what we call the state of this page. And then that state is going to later be used into the in the render items table. The items are going to be taken from the state into this method, are received as items, and then we will just render them in a normal HTML table. So let me put a few breakpoints back into populate items so that we can see things as they go. So I'll place these breakpoints over there. And let's also go to the catalog microservice so that we can put a breakpoint on the server side. So I'll collapse this, and I'll go to items controller, collapse that. And then here we can go into the get async method, put a breakpoint there. So now let's go back to the browser and let's just refresh this page. And sure enough, here back into the front end, we have hit the breakpoint. And as you can see, here's where we have the location of the catalog microservice in the items API. So if I say continue, that's going to talk immediately to the catalog microservice. As you can see, now we are in the catalog microservice. Let me collapse this a bit. And here's where we're going to go ahead and talk to our repository to talk to the MongoDB database and then return the items. So I'll just say continue. And now we are back into the front end where we have received that response, which we can briefly inspect on the left side. Let me collapse this and that and that. And as you can see, we got a 200 status code, which is great. And then we need to convert that promise into the actual set of items. So for that, I'll just hit continue. And now we have our list of items over here in this returned items variable, where you can see we have collected the items from the server side with the date, the description, the ID, and the name as an array. And then if we just hit continue, then we go back to the browser, we can see that the items are right there. Now, how about creating a brand new item? So let's go ahead and click the add button here. And this is the form where you can go ahead and actually create an item. So again, how is this form working? So going back to play the front end, go to the code base, you're going to find the code for that under form, in item form, right here. If we go back up, there's a method called createItem. So this is the one that's going to be in charge of sending the post request to the catalog microservice to create the item. And we can do the same exercise by just placing a breakpoint over here, and then we're going to get a response over there. Same way, we can go back to the catalog microservice, and we can place a breakpoint into the post async method over here. Now back to the browser, let's go ahead and create an item. So let's say we're going to create, in this case, a shield. And let's call it actually bronze shield. And this is going to be a basic shield. Now, what happens if I just don't put a price here? So I'll go ahead and hit save, and you can see that this is going to happen. So we have enabled client-side validation via React into the client side. So here it is making sure that I have a name and that I have a price. If I don't have a price, then this happens. So sure enough, I can put a price and that should work. But before we do that, what happens if I do something a bit different, like putting an invalid price, like a -5? If you remember, the catalog microservice has been configured with validations, and it should not allow a negative price here. I have intentionally not enabled client-side validation for a negative number here, so that it just let it go. But how would that look like in the over here when the validation actually comes from the server side? To figure that out, I'll actually go back to front end, and I'll put yet another breakpoint into the catch section over here. So now let's go back to the browser and try to save that. So now we are back into front end. So as you can see, we will send a request to the catalog items microservice. I'll hit continue, and as you can see, we already got a response here. We didn't even get to reach the controller on the microservice because the ASP.NET Core validation runtime verified that this is not an allowed thing. Like the DTO that we sent did not pass the validations. So as you can see, the response here is already telling us that this is a 400 bad request because we have sent an invalid value. And in fact, if we want to know more about what happened here, what we can do is just, let me put another breakpoint over here, and I'll hit continue. And now we can inspect this error data section here. And it says here, yeah, one or more validation errors occur, which by the way is the exact same validation that we were seeing before in Postman for this kind of invalid inputs. And if we expand the error section here, you can see that we have all the errors that are coming back from the microservice, like the field price must be between 0 and 1,000. So this is one way that if you wanted to, you can show that error with that specific error into the client. In our case, we are only showing the error data, that title property. That's as much information we want to show to the client at this point. So I'll just say continue. Then we reach the catch section, which will catch all the errors either from validations or for any other kind of communication errors from the client and the server. And that's going to show an alert. We say continue, and then back to the client. This is what we're going to see. Could not add the item, one or more validation errors occurred. So to fix this, let's actually put a correct price. Let's say 6. Then I'll hit save. So back to front end, we'll send the fetch request. And now we hit the catalog microservice because the validation succeeded. So the controller is actually being hit now. So this will go ahead and, as you know, it will execute the logic to create the item and then publish that item into the message broker in RabbitMQ so that the other microservices can get notice of this. So I'll hit continue. Then we're back into the front end. And this time, if we expand the response, we can see that we got the expected 201. And then we hit continue, and back into the browser, the item has been created. Bronze shield, basic shield with price 6. Okay, so what about editing an existing item? So to edit an item, all you have to do is click on the edit button here, and this will allow you to perform the edit. But before actually going through the edit scenario, let me actually just go ahead and remove all these breakpoints, since I think we get the idea now of how communication is flowing across places. So let me go to the breakpoints and just remove all of them over here, and also in the catalog microservice. So I'm going to go ahead and remove all breakpoints. Okay, so now back to the front end. The edit logic is happening if we go back into in item form. So that is happening in the update adding method. So here's where again we call the fetch method with the URL of the REST API plus the ID of the current item. So that will go ahead, do the fetch operation, and then later we'll get a response over here. So let's see how that works in real life. Over here, I'm going to just bump the price from 6 to 8, and then I'll just hit save, and the edit has been performed. Notice how things never reload here, like the page is never really reloading. It's just a React component that's fetching the updated data and putting it dynamically into the same page that we were always working on. Then we can also try the delete scenario, and that happens if we go back into Frontend. That is happening directly into the catalog.js file. There is a section called delete item that's invoked by that red delete button. See, there's going to be a confirmation, then it invokes the catalog API with the ID of the item, and then it performs the delete, and also it removes it from the client state. So to see that in action, let's go back to the client. And then I'll actually like to keep this bronze shield and the other items. So what I'll do is I'll create quickly another one. Let's just call it delete me description, and then I'll say price for, right? So I'll save this item is created, and for a delete operation, all you have to do is click on delete. There's going to be a delete confirmation box here. Click OK, and the item is gone. And you can always confirm that these are actually happening in the server side by refreshing the browser, and you can see that the items are actually gone. And of course, you can also take a look at the database. Now, how about granting an item to a user, which touches bases with the inventory side? So to do that, what you can do is use this grant button over here. So let's say I'm going to grant this bronze shield to a user. So I'll click on grant, and this pops up this model dialog to grant an item. Now in this dialog, what I have done is I have made it so that anytime you open it, it's going to populate some random GUID for some random user ID. Remember, we don't have the concept of the users really here, so it's just a random user ID. So just like we did a random user in Postman, now this page is presenting a random user ID, random GUID here. And also there's a quantity that you can increase or decrease as needed. Now this here is happening back in the front end, is happening in the grant item form JS file over here. Here is where we can actually do a breakpoint for this one. This is where we will invoke the inventory items API with the data that we have about this item, and then the inventory service is going to take care of granting the item to the user. So if you go back to the browser and we say, let's say we're going to grant 2 of the potion, actually 2 of the grant to the bronze shield to the user, I'll say grant. And then if we go back here in grant item form, we can see that the inventory items URL is going to be invoked. This time is 5005/items. And that is going to use the user ID that we specified in the client side, the catalog item ID, which is right here, and the quantity, which is 2. And just to not lose it, I'm actually going to grab this user ID. I'm going to copy this one so that we can query for it later. And then, I'll hit continue. And that would have granted the item to the user. Now, there's no visual representation of that completion in this page, but that's why we have this other page for inventory. So let's go to the inventory section over here. And here is where you can paste that user ID and you can get inventory for the user. Now, all the logic here is happening. If you go back to the front end, this is happening actually in the inventory.js page. So this is the page that is going to allow us to populate items based on this on the entered user ID. That's going to go ahead and talk to inventory API with that user ID, and that brings back all the items that are in the user's inventory pack which is rendered over here in this section, render items table. So we go back to the browser, we'll just hit get inventory, and there you go. The current inventory for the user is presented. In this case, just a bronze shield. Now, once again, it's also interesting to see what happens if there's an update, if an update happens to this item, right? Would the UI be able to reflect the fact that inventory needs to have updated data from the catalog when that happens? Would that take too much time? How would that render? So let's see. So we have bronze shield, it's named bronze shield, basic shield, quantity 2. So let's go back to the catalog, and we're going to edit the bronze shield, and we're going to change the name. So instead of having it as bronze shield, we'll just call it basic shield, right? And perhaps we'll also update the price. Let's say it's 9. And so now the bronze shield is named basic shield. So I'll hit save, and I'll go back to inventory, and I'll query again for the items of this user that we just granted inventory to. So I'll hit get inventory, and as you can see, the name has changed to basic shield. That means that as soon as we performed the update in the catalog microservice, that was immediately replicated via an asynchronous message into the inventory service, and inventory is now able to present the updated name of the shield, in this case basic shield. And that happened really fast. So there you go. We have gone through all the sections in this basic front-end user interface. So that marks the end of this module, and you have connected a modern single-page application built with React and hosted in Node.js with your two .NET-based microservices to light up a basic end-to-end scenario. And you learned all about cores along the way. I hope you enjoyed building this system with me so far. Congratulations, you made it till the end. I really hope the course met your expectations and gave you a good sense of how to get started building microservices with the .NET platform. Please consider hitting the like button if you got value out of this, and don't forget to subscribe if you'd like to know right away when I publish new videos. Now, microservices development is a huge topic, and this course only covered the tip of the iceberg. If you want to become a microservices developer and you are considering this architecture style for a real-world project, you will need to master many other techniques and patterns essential for distributed systems development. Also, as you move your system to a cloud-based environment, you will need to add many other pieces to your tech stack to ensure your microservices can be built and deployed quickly, to scale the system to meet the production demands, and to have the tools to monitor and diagnose the services when things don't go as expected. To cover all these topics, I created the Building Microservices with .NET Complete Learning Pad, which expands what you saw in this basics course with dozens of additional lessons that will teach you step by step how to add all the building blocks needed for a complete microservices-based application and how to take everything to a production environment in the cloud. If you are interested, please check out the links below to get all the details on this premium offering. Thanks for watching, and I'll see you next time.